This is the Python for Cybersecurity tutorial series, training series, and this was recommended by actually a few of the people in our community that wanted to learn more about Python automation. And since this is a channel about cybersecurity and ethical hacking, obviously we're going to be talking about Python in the context of cybersecurity and ethical hacking. So I know that there are a lot of other Python tutorials that are available on YouTube, and I completely respect them. I think they're amazingly valuable, but this particular video is going to be with the context of cybersecurity in mind. And we're going to go through a lot of the basics towards the beginning, just in case you've never seen any of the other stuff. And if you have seen the other stuff, you can just skip to the portion where we're going to be talking about creating algorithms and all of that. But we're going to cover a good myriad of things, and it will be included in it the beginner portions of learning about Python, as well as some of the more intermediate and advanced concepts where we actually create some algorithms for parsing logs and going through just making sure that you actually have some really good tools for your journey as a cybersecurity analyst. My name is Hank Hackerson, and I am your host/trainer for today. And to get more videos like this one, or really anything about cybersecurity or ethical hacking, I do encourage you to like, subscribe, and turn on the notification bell so that you can get notified the next time that a video comes out. And as always, this video is sponsored by our Hackaholics Anonymous membership community, which is actually intended to be, and I promise it will be, the premier YouTube community for security professionals and hackers, mainly because of the fact that I really love this community. I love the people that come and join us in our comment section and watch the videos and leave their feedback, and I wanted to add some real value to them. And there's things like, going for bug bounties together and getting some Python automations that have already been created so you can use them in your jobs or just for your day-to-day life, anything of that sort. There's a lot of perks that's attached to it. I'm not going to take too much time going through it. I would recommend you go and check it out. This video is on our homepage for the channel, and I think you'll be pleasantly surprised. And if nothing else, I would love to see you as one of our YouTube subscribers, and hopefully I'll get to actually hear from you in the comment section as well. Now, without further ado, let's actually jump into our Python for cybersecurity tutorial. Okay, a quick note before we actually jump into the content here. I'm running Mac OS, which is very similar to Linux as far as the syntax of the language of the command line is concerned. It's a little bit different than Windows. So if you're running Windows, you may have some challenges if you're trying to emulate what I'm doing inside of the terminal. That being said, everything else that we talk about when it comes down to Python itself as a language should be standard all across the board. It should be very uniform. And if you do have challenges for some of the commands that I'm running inside of the command line, I would recommend you use something like ChatGPT or Gemini to just double check and make sure that your Windows version of those commands will actually hold up, and you can run the stuff that we're running over here to confirm that you can do everything that we're doing over here. But there isn't too much stuff that we're going to do inside of the command line inside this video. Everything is going to be inside PyCharm, which is an IDE for writing Python scripts. And when you install PyCharm and you're using Python, all of that is going to stay very uniform and standard across the board, so you won't have any issues with that. That's basically the main note that I wanted to give you, is that I'm running Mac OS, and if something kind of doesn't match on your computer if you're running Windows, mostly it's because of that reason, that there's different languages and they do differ in some capacities, but they're also very, very similar in a lot of other capacities. That's the main note that I wanted to give you. All right, the first thing that we want to confirm is what your Python version is. Most computers have Python already pre-installed on there. It just happens that maybe it's not the most recent version of Python. And to do that, it's a very simple command. It's actually something that you can run by just doing python-version like that, or because I know I already have Python 3, so it would be Python 3 -- version. And then now you can see that it actually gives us what the version of Python is that I have on this particular computer. You should have Python on your computer. Almost all computers have them, unless like it's super ancient or something. So it would either be Python 3, or it would be Python 2, or it would be Python followed by -- version, and that's how you would find out what kind of version of Python that you're running. Now, that being said, everything that we're doing on this computer or in this tutorial, as you can see, is running Python 3. So to make sure that you have the most recent version of Python, we're just going to go and find out exactly where you can do that. And again, it's super, super simple. To download the most recent version of Python, we're just going to go into Google and just type in Python download or download Python, whatever you want. It should be the very first link that just says download Python. And then as you land on the page, it literally detects what your operating system is. So I'm Mac OS, and it'll say download the most recent version, which is with this gold button right here. And you click on that, and then it gives you the install file. So I'm just going to click just so you can see, and it brought the install file here for me. And then you open up the install file. Depending on what computer you're running, there's a wizard for the installation, and it takes you through the installation, and it just installs it on your computer. And that's basically it. It's very, very simple to do. And once you have Python 3 installed on your computer, then everything else that we're going to talk about in this video will actually make sense. I mean, I think most of the commands that we're going to run in this video would still run with all the other versions of Python as well. But what we're doing for our intensive purposes, we need Python 3 for it. And I just want to make sure you don't have any glitches or anything like that. So just update your version of Python and we should be all good. You should be good. When you install the most recent version of Python, or I think even any version of Python, there's something called idle that comes pre-installed with it. And idle is kind of the basic emulator or the basic environment for writing Python scripts. So let me just show you what that actually means. So this right here, what you see right here is my basic shell, my command line shell. And if I wanted to write some kind of a Python script in this shell, I would have to first call on Python, and I would just do Python 3 and I press enter. And now you see that it actually has changed it into these 3 arrows right here, which means now I can actually, let's say, create a variable, which in our case would be hello, and then we turn that hello variable into hey there learner, hope you're well, whatever, right? That's our string value for this variable. And now I can do print hello, and it'll print that onto my screen. And all of these commands that I'm doing right here are Python specific. So this wouldn't work if I was just inside of the bash shell. And if I want to exit, I'll press exit, and then I am now back in my regular shell. So if I wasn't going to use idle, this is how I would create some kind of a basic script or something like this. And I mean, not really even a script, because personally, I actually don't know how to turn what I just did. So if I wanted to turn this into a script right here, for example, I actually don't know how to do that inside of the basic shell. I know how to do it with idle, which I'll show you in a minute, and I know how to do it with PyCharm, which is one of the things that we're going to be using for the rest of this video, but not inside of the shell itself. So if you actually know how to do that, I would love to hear from you inside the comment section, and maybe you can kind of school me on this a little bit, and maybe you can teach me a little bit. Or obviously I can just go to Gemini or GPT and ask that, and it'll teach me as well. But for I don't want to get too distracted on this. I just wanted to show you what it looks like when you convert your regular command line shell into a Python shell, which is exactly what we just did, and then what it's going to look like when you use idle instead of using the Python shell inside of your command line. So let me actually show you what that looks like. All right, so I'm in my root directory right now, which when you run pwd, that's what it shows you. If you do cwd in Windows, it'll show you your current directory. I'm in my root directory, and usually it also is in the root directory for Windows as well, or it's inside of the users directory for your specific user, where you have something that is called program files for Windows, but in Mac, it's called the applications. So in my root directory, there is a folder, as you can see, that's called applications. And once I go into my applications, I can actually find, I need to learn how to spell that. I can actually find something inside of my applications folder, which is called Python 3, because I installed Python. And so it's inside of my applications. And for Windows, it'll be inside of your program files for your specific user that you're using. All right, once we are inside of our applications folder, we have another folder, as you can see, that is the Python 3.12 folder. And we need to go inside of that to be able to find what we want, which is idle. So idle is an application. And for me, it's .app. For Windows, it's .exe. Once we get inside of our Python folder, for me, all I have to do is just do open idle, and then it'll just open it for me in a new window. And it's basically another shell window, as you can see right here. Unfortunately, I don't think I can zoom in like that. So I would have to kind of hopefully just rely that you can see this. I think you can zoom in on your window as well. But basically, this is what it looks like. So as you remember, when we converted our command line shell into a Python shell, it had these 3 arrows at the beginning of it as well. And now we can just do the same thing, right? So I can just create a new variable called hello student, hope you're well, whatever, and then press that and nothing happens. So now I can do print hello, and it'll print it onto the screen for me. What I like about idle compared to the regular command line is that it color codes things. And if there's some kind of an error, so if I do print hello, let's say, and I do that, it won't give me the same color coding that it gave me right here when I did it successfully. Or if I do something that is incorrect, it'll actually do some kind of an error message for me, right? So let's say I'll do this. Let's do that, I guess, something like this or whatever. It'll give me some kind of a syntax error, or there is a traceback kind of a call error. There's a few different types of errors that will happen in Python, but it at least gives you the error, and it'll even kind of, again, the color coding is what's very, very useful, believe it or not, once you actually get into writing some scripts. When you see the correct coding of something, those coding, that specific correct color coding gives you the hint that you're on the right path. And then when you see that the color coding isn't done properly, so if this piece right here is all green, that means I have a good successful string. And then if I am trying to print a variable, but the last piece right here is now in green, that's telling me that, oh, I opened up the quotation right here, and everything inside of that is technically a string. So now there's something wrong here, and I haven't done that correctly, etc., etc., etc. You'll find it out as you mess around with it, and then as we go through the rest of this video, you'll also see that color coding is actually really helpful. It's like super, super useful. And now here, if I wanted to actually save something, I can save this and turn it into a Python script, a Python file, because I'm inside of a specific editor right now that is for Python, which is called idle. And now I know how to do this and how to turn this into a script, which is as simple as just doing, Control S or Command S, depending on what kind of an environment you're in, and then it'll bring up the save menu for you, and then you could just save it as whatever kind of save file that you want. So that is basically it for our introduction to idle. And now that you have seen what idle is, I think you'll really appreciate PyCharm. And for you to be able to install PyCharm, again, it's as simple as going to Google and just saying install PyCharm. Let me make sure that I'm actually doing this right. We just go install PyCharm, and there we go. And it's the very first link. PyCharm is a product of JetBrains, and JetBrains has developed a lot of great things, including PyCharm itself. And there are 2 versions of it. So we have the professional version as well as the community version. I'm going to be using the community version because it has a lot of great features. It's still better than nothing. The professional version is for people who are, again, trying to be professional developers. So if that's you, then by all means, go ahead and get that. But for the most part, I am going to be using community, and we can still get all the things that we want to get done using the community version. And the way that you do that is you just click on Get PyCharm right here, and you can tell that it's already detected that I'm on a Mac OS. So you click on Get PyCharm, and it'll bring you to this page. And at the very top, they want to give you PyCharm Professional, but you just scroll down a little bit and you find PyCharm Community Edition, and then you just download that and you go through the installation wizard, and you will have PyCharm installed on your computer. And just like that, that's it. That's all you got to do. And now you can see what it looks like when we use PyCharm, which is super freaking awesome. So if we go back into our applications folder, we will see that we actually have something right here called PyCharm EDU. And I'm just going to do it using the command line because I want you to also get a little bit more comfortable using it during the command line. And in this one, this is an actual application because you can see that there's a .app at the end of it. So I can just do PyCharm, open PyCharm.app, and it'll open up the application for me. And you can always just go to your program files or application folder and just double click on it, and it'll open it for you. And just like that, we have the welcome to PyCharm. And for you, it's probably not going to look like this. These are all of my previous files that projects that I've created. So for you, it's probably just going to be a blank thing right here. And you can just click on new project right there. And for new project, you'll be able to go and create your new folder, and it'll choose the base interpreter that you want for your Python to be. And just like that, you do create, and it creates it for you, and it'll open up PyCharm for you. and it usually also opens up a basic main kind of like an introductory script right here. So anytime that you do a new project file, it'll create a basic introductory script for you, and it gives you a couple of comments at the top. So this is sample Python script. You can do Control R to run it, and you can do double shift, I think that's what that would be, double shift to search everywhere for classes files, da 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 da. And then this is our function that basically is called the print high function, and it has a name as an argument. We'll talk about what all of that means. You don't need to know what that is right now, but that's basically what our sample function is right now. And then when we run it, we need to just give it a name, right? So in this case, it's giving it the PyCharm name. So when I run this, it'll say at the bottom right here, hi PyCharm. And then if I changed it to Hank and then just run it again, it'll say hi Hank. So that's basically a very, very basic script right here, and it'll just work for our intensive purposes of just showing you this. But this is just a sample. It gives you the link to the help for the JetBrains website, so in case you ever needed any help with PyCharm, you can go there as well. But this is usually it. It's called main.py, which is the sample file that they give us. All the files for Python end with a .py, just to make sure that the computer understands that it's a Python script, and you, as the developer or as the hacker or the cybersecurity analyst, you understand that it's a Python script that you're dealing with. And that's basically it. That's really all the introduction that we need for Python and PyCharm and all that stuff. And now we can actually just jump into using Python and using PyCharm. All right, now we're going to talk about installing libraries and modules, and consequently importing libraries and modules. So there's a series of libraries that just come pre-installed when you install Python. So for example, one of them is the OS library, which stands for operating system. So the simple way that you would do that is you would do import OS, and then it just imports the OS library for you. And now you can do things like, for example, print os.listdir, which would be list directory, list the stuff that's inside of the directory. And if I run this, then it'll show me all the stuff that's inside of my directory. And this is actually more advanced of a beginner script that I wanted to show you. I just want to show you how to import something, right? So you basically do that using the word import and then the name of whatever the library is. And there are certain things that just come pre-installed with Python. And then there are certain things that you would have to install, and then once you install it, you get all of the capabilities that comes with that library. So this is what that looks like. These are some of the libraries that are not pre-installed with Python, and you would have to install them using pip3. And pip3 is a package manager, basically, is what it is. For Python, the first version, it would be pip. For Python version 2, it would be pip2. Python version 3, it would be pip3, etc. And so you would do pip3 install, and then the name of whatever the library is that you want to install. And I'll get you a couple of like sample commands so you can understand what that is. But these are just some libraries for data science and machine learning, which is the NumPy, Pandas. I've used Pandas a lot. It's an analysis library working with structured data, for example, CSV files and things like that. Then you have, web development for Django and Flask, which is for web application, for requests, which is if you want to actually make requests like a GET request or a POST request to an actual web page. Beautiful Soup, which is for parsing HTML and XML files or XML pages, which is actually really useful when you're trying to build a web scraper. We have Pygame for creating games. There are so many different libraries for Python. And just depending on what you're trying to do, you would use these various libraries. As cybersecurity people, we're most likely not going to be using Pygame. You'll probably end up maybe using PyInstaller at some point to turn your script into an executable. You may end up using Beautiful Soup for parsing HTML, XML documents. I've used requests frequently to create scripts for making HTTP requests from web pages, and a combination of requests as well as the OS library to create a script that can do things like that. And a lot of other things. I've used Pandas before. I've used NumPy before in the context of cybersecurity specifically. And these are just very, very useful libraries. And you can always just go to Gemini and say, hey, is there a library for doing something like this? And then what's really interesting is that you can actually have a Python library for individual security appliances. So let's say Snort, right? So let's actually do it like this, right? So you can basically go into Google and ask about any appliance that you want. Does Splunk have a Python library? Does Snort have a Python library? Does, fill in the blank have a Python library? And if it doesn't have an actual Python library, then you can interact with the API of that security appliance, and then you can code that into your specific script so that you can interact with Splunk or Snort or Wazoo or any of these things using the Python language inside of your script. And it's very, very, very useful, especially when you're trying to automate security activities and cybersecurity analyst activities. So this is one, apart from all of the libraries that we have listed here, apart from those libraries, you also have the libraries that are specific to the security appliances that you would end up using as a security analyst. And then you can install those security appliances and then very simply just do something like what it says right here, where you can just do import from Splunk lib client, import connect, or import URL lib3, which is for making URL requests and commands, and as well as the request library. So you do a combination of import commands to import a specific type of module into Splunk, or into PyCharm, so that you can now interact with all of the different capabilities of that specific program, of that specific software. So it really just depends on what it is that you want to do and what it is that you're trying to use. And there's just a variety of different libraries on top of all the stuff that comes pre-installed with Python when you install Python. And then we're going to go through all these different functionalities and these different libraries as we go through the rest of this video. But just depending on what your use case is and what you need, you can go ahead and install your own specific library that is fitting with your module. And then from there, you'll be able to do anything really essentially that you want using Python scripting. All right, now we are going to talk about the comments and readability of your code, which is actually very important for two reasons. Number one, comments, when you're doing analysis of a web page or of somebody else's script, comments help you understand what the mindset of the developer was when they created their code. When you're analyzing a web page, comments help you understand what certain parts of the web page are supposed to do. But also when you're doing analysis for the purposes of pen testing, sometimes developers leave sensitive information inside of the comments of the web page or inside of the comments of the script, and you can use that sensitive information for finding other vulnerabilities or other attack vectors, or maybe finding exploits that you can, or maybe sometimes they might even leave a username or a link to a hidden page on that holds other sensitive information, so on. So comments are actually very, very useful in terms of doing analysis or pen testing, but they're also really useful for just understanding what somebody was thinking when they created a specific type of script. For you as a developer, for somebody writing the code, comments can do a variety of things. Just like what we just talked about, it can help you understand what you were trying to do. It can help somebody who's using your script to understand what you were trying to do. It can also be a placeholder for you for the future if you wanted to come back and work on your script later, so you understand what you were doing, and if you need to work on certain parts of your script where you just left it alone and you said, hey, insert such and such here. Comments are very, very useful for a lot of things, including just making the script easier to read and understand what's happening. So here's how you actually use comments inside of your script. All right, so just basically looking at our previous placeholders that we had here, import OS could get a comment by itself, and you just do a hashtag like this and you say, this is importing the OS module, just like that, right? And if you wanted to really just talk about the overall structure of the script, you would put your comment at the very top where you say this script is about etc., right? If you have a long description for your script, instead of doing a hashtag for every single line, you could just do 3 quotation marks. And I notice how PyCharm automatically just gave my 3 quotation marks at the end as well, because it's helping me wrap my block of comment. And this is another reason why I just love PyCharm in general and these IDEs, because they kind of help you do some of the work to make sure that you don't mess your syntax up in any way. But now that I have these triple quotes, I can now just do enter a couple of times, and I could just literally do anything inside of this and it won't matter. and it won't affect the functionality of my script because this is all being commented and it has nothing to do with how the script functions. It's just notes that I can leave for myself. And usually at the top of a script, I'll leave my comments in this kind of a format because I can just do a multi-line comment and just explain what the script is actually about. And notice how, again, when I highlighted this whole piece and I added the triple comments, and it does it again every single time, that it also added the triple comments at the end of it as well to just make sure that the whole block is now being commented. And if I wanted to take that whole thing and do parentheses around it, notice how it would also put the closing parentheses at the end of that block as well. This is why PyCharm and IDEs in general are just so freaking useful, because they help you do a lot of these things by completing what it thinks you're trying to do. So comments are, again, you could just do it like this. This is a comment. This is also a comment. And then comments could also be in this format where you say you're importing the OS module, and right here, this is printing the contents of our directory, like that, right? So each line, and if you really want to be like very helpful for yourself as well as for somebody who's going to be reading your script down the line, I would actually say put a comment for each line. You can write the code, but then later on come back and just explain each line of the code so that this is very elementary, okay? People who are advanced, I don't think advanced coders actually do this, but we're not really advanced coders. We're security professionals that are trying to learn how to use Python for the purposes of cybersecurity and pen testing. So for us, it's important to understand what we've written and what we're doing. And then you can now do this, right? So this is where you do A, and then go down the line, and then you say, this is where you do B, and then you can do these things as placeholders for when you come back and you are going to write the rest of your code. You can do this, and then now you know where each piece of the code is going to go and what each section is supposed to do. And this is what I mean when I say you can use comments as placeholders, because you can just remind yourself for the future, oh, this is what I wanted to do the next time that I came back, so this is what I'm going to do. So not only does it help with readability so that you understand what's going on, it also helps with placeholders as far as you knowing what you're supposed to do later on. And that's one of the most powerful things about comments. And this is really, really basic and it's really simple, but I really want you to understand that this is actually very, very useful. And if you just get into the habit of leaving a comment for everything that you're writing, it'll become extremely useful down the line to you, to people who are using your code, to employers who want to hire you, so that if you send them a sample script of what you wrote, you actually, as you explain what you've done, they'll be like, oh wow, this guy really knows what they're doing. This whole thing was done with the intention of displaying their understanding of the Python language. So that's basically all I'm going to say. And what we're going to do as we go through the rest of this video is we're going to leave a comment basically for everything, because I want you to get into the habit of leaving comments so that for later on when you're done with this video, you just have that habit instilled in you and you can use it for a lot of other things. All right, now we are going to write your very first program, and hopefully by now you have actually installed the most recent version of Python. Hopefully you've installed PyCharm and you're typing along with me as I do this. And I recommend, even if it seems super simple what we're doing, I do recommend that you actually go ahead and type these things out, like practice these things so that you just learn how to navigate PyCharm, and you know how to write scripts, even though they're super simple. Like some of these things that we're going to do are really, really simple, and I do understand that they're really simple, but it's practice. They're building blocks. As you write simple pieces of code, you get used to the syntax of Python, and then when we go into the more advanced stuff later on in this video, you're going to know exactly how all these things stacked on top of each other, and then you're going to already be used to it. You're going to be adapted to it, and it'll be very easy for you to write the rest of these things. So this is how I learned Python. I just typed along click by click with the teacher that was teaching me, and I think that this will be very useful for you if you also just start typing along and actually doing these things with me. So the first thing that we're going to do, this is the first program that I learned how to write. So this is going to be the first program that you learn how to write, which is going to be the hello world program. So there's our comment. This script is going to say hello to the world, and we're going to use a function that already comes inherent with Python when you install it, which is print. The print function is a very important function. You're going to use this function all the freaking time. And so the print function prints whatever you want it to print onto the screen. And you would need to do a open and close parentheses. So when you actually do an open parentheses, PyCharm will actually do a close parentheses for you, and your cursor will be right in the middle of it. So anything that you put inside of it will just be wrapped inside the parentheses. And since we don't have anything else other than what we're going to print, we're going to put it inside of quotations. And quotations are going to declare that this is a string value. We'll talk about values in a little bit. And we're just going to say hello world. And that's it. That's our entire script. Just like that, you're done. So you're going to do Control R, and then just like that, it printed hello world onto the screen. Now, what's really useful to understand, and this is also a very important note, is that Python will process everything line by line. So if I do print hello world and then we do print goodbye world, then what it'll do is that it'll print both of those lines sequentially, right? So this is very useful to know because you can start doing things according to the order that you want them to be done. And even with that, we can actually start creating shapes, right? So for example, we could do things like this. And just like that, this may seem odd right now, but when I actually run it, it has actually created this little shape for us. It did give us some kind of a weird error message at the end of it, but technically it's all good because it actually printed what we wanted it to print. So we technically printed a shape. Now, what's important to understand is that, again, this happened in order, right? So if I were to remove this piece right here and put it at the end of our script right here and then printed it this way, you'll see that the shape will actually change, right? The shape changed. So let me kind of drag this up a little bit just so you can see right here. The shape changed because why? It's doing it in order. And this is something that's really important for you to understand about Python. So everything is done in order. And when something is broken, when something doesn't work, so if I break this down, so let's see if this will actually work. I think it was writing things out for me, but technically that could have actually been a good example as well. So if I do that right there, and now I should have an error because we got a red squiggly line at the end of it. So if I try to run this, it won't really work, and it's going to give me an error because as it tried to process this program, none of it worked, right? So it actually tried to do it line by line, it didn't work, and therefore the program crashed. You'll see that this is going to happen as you learn more about Python. And as you develop your scripts, these error messages are going to tell you on what line. So detected at line 5, and this is where we were, where I removed that specific quotation. It'll tell you where the error occurred, and we'll talk about errors in a little bit as well. It's just important to understand how to read the errors. You don't necessarily need to understand all of the different things about it, but it'll tell you how to read the errors, and from there, you'll know how to fix your code. All right, now that we have gotten this out of the way, let's now really get into some of the nitty-gritty stuff so that you can understand what Python is, how Python works, and how you can leverage it. So the first thing that we have to understand is data types. So the data types inside Python allow you to really do a lot of neat things. The first data type, which is probably the most common data type, is the string data type. And string data types are like this. You essentially put something inside of quotations, and now you have a string. Very, very basic stuff, right? Nothing crazy. So strings could be anything that is inside of the quote. So updates needed would be a string. In this particular case, we can also do 20 or 30% or whatever, and that's technically a string. We can do 5.0, that's technically a string. We can do whatever, anything really, and that would be a string. And you can also do this, which is kind of like a placeholder for dates. It's like a regex expression, and that's technically a string. So because of the fact that you can do essentially whatever you put inside of a quote is considered a string, you can really manipulate data in a lot of different ways by converting it to a string, okay? And we'll refer back to this in a little bit. There's one final thing you need to know is that this is what's called an empty string. So you can create an empty string as a value for variables, and you'll then be able to fill it up with content as your script progresses and as it pulls data from different sources or certain events take place. So you can actually have an empty string and that'll still be really useful. So we have all of these different strings that we have over here. So what we've learned already is the print command, right? So we can just go over here and we can do print, and then we now put updates needed inside of our script. And then if we just run this, now we'll see that it prints updates needed, right? So if something happens, you can do updates needed, for example. That would be one of the things that you can do with strings. Now, the next one that we're going to talk about is something called a list. List data is inside of these square brackets, and it could be something like this. It's all separated by commas. So it could be a set of numbers, or what is also known as integers. That's a list. We can also have a list of strings inside of the square brackets. So for example, I'm just going to bring these things that are printed here just so I can show you what that looks like. That's a list right there. That's a list of usernames, for example. You can also have a list of values, which could be true, false, true, true. These are all list values as well. And then a list could also consist of a combination of things. So it could be a number, it could be a string, it could be a Boolean value is what we call this. It could be something called a float, which has a decimal point in it, or combined with another. And this is all, again, a script. So these are all, lists. These are all various lists that we have over here. Now, if I went to this and wanted to just print this, right? So let's say this one actually. Let's say we want to print this specific list. So we go here, paste this inside of our print statement right here, and now we have that. And if we ran it, it's going to print what we have inside of that specific list. And notice how the string was still put inside quotes, even though it's a single quote, it's still put inside quotes. The number was printed as a number, true was printed as true, the float was printed as a float, etc. So you can print a list very similar to the way that you print a string, and it'll still work for you. And just like that, you know how to print two different types of data, right? Then we have something called an integer. Integers are numbers. So this is technically an integer. This is technically an integer. The negative integer still works, right? A 0 could technically be an integer. It's essentially any number so long as there is no decimal point in it. So if you wanted to print a number, you don't have to put that inside quotes actually. So you could just do print the digit 5 and it'll print it for you. And it's as simple as that. And I just wanted to kind of modify what we already had just so it prints everything that we got. So print the first string that we had, which was updates needed, print the list that we created, which was this list, print the digit number 5, which is that. And notice again that it happened in order. And something that you'll probably notice is that none of these things printed onto the screen. None of these things printed onto the screen. These are values, or these are, we can call them data points. These are data or values that have not been referenced at all in our script because we haven't used any kind of a command or called on any of those data points within Python. Print is the only action that Python is going to take for us. It will disregard all this other stuff, very similar in a way that it disregards our comment, right? So you can have these values just sitting here. It looks ugly, and I mean, they serve no purpose, so it's like kind of pointless for these things to exist. But just for our intensive purposes, I just want you to know what the different examples of these things are. I'm actually going to delete these things just so we can kind of keep this a little bit clean. But now we have our different data points. So we had these three different data types, which is string, we have a list, and we have an integer. So now let's talk about the other data point over here, which is a float. A float is a data point that is separated by a period or a decimal point, I guess we can call it. It could be anything. So it could be longer numbers, it could be negative numbers. So this could technically be a float. All of these things are considered to be floats. And really the big thing that you need to understand is that floats consist of decimal points while integers are just single numbers. And it might be kind of irrelevant because technically you can say, well, technically a float can be considered an integer, and technically you would be right. But in the context of Python programming, we have two different names for it. And when you get an error message later on, if you are writing your code and you may hear, or the error message could say that such and such is an integer when it should be a string, or such and such is a float when it should be a string. You can't do this with floats, you can't do this with integers, etc. When you see that, I want you to know what you're dealing with. So technically, these are all floats, and if we wanted to, we could again just do the same thing, right? You can just do this, and it'll print that float for you inside of your data points right here, and now you know how to print floats. And what's really useful about Python is that you can actually start messing around with what we call mathematical operators, and we'll be talking about this in a little bit further detail later. But you can actually combine floats inside of your print statement by doing print 231 times 5, or 0.5, plus whatever, 5,484, etc. And you do that, and now it actually gives you the combined value of those things, and you've used something called a mathematical operator. And if I do minus, hopefully it'll actually give me a negative. Yep, it gives me a negative value as well, because 231 is smaller than 5,000. So that is how you work with floats and how you use mathematical operators, just like plus and minus, as a quick little example, with our float data. And actually, before I move on, I also want to show you this, right? So if I do the integer or the float itself with a string right here, and I try to run this, I should get an error message. Yeah, you see, so we get an error message where it says that this is an integer, this is a string, and it says unsupported operand types for float and string. str stands for string and float stands for float. So you can't subtract a string from a float or an integer, anything like that. Mathematical operators can only be used with numerical values. So as long as this is not a quotation wrapped around it and it is some kind of a number, then we should be fine and we should not get any kind of an error message, and we don't in this particular case. So I wanted to kind of point that out as well. You can't, when you're doing mathematical operators specifically, we're going to talk about logical operators in a little bit, but when we're doing mathematical operators, you're going to only be able to use actual numerical numbers, whether they're integers or they're floats. You can only use numerical numbers. I guess while we're here, we could actually just cover the rest of the specific mathematical operators as well, just to kind of get it out of the way. So you could do, we already did plus and minus, obviously. We can do multiplication, which would be done by the asterisk. You can do division, which would be done by the /, and all of these would essentially be our mathematical operators. Plus, minus, multiply, and divide are your overall mathematic operators. And you can run this and you'll end up getting a variety of different values, right? So after the printing of the integer 5, now we have a variety of different values that subsequent or that relate to each one of these individual values. And you can tell that it goes as many decimal points as it needs to give you a definitive answer, which is one of the things that I really love about Python. So now you have a full understanding of mathematical operators, which is super easy to understand. Plus, minus, multiply, divide, those are the basic ones that we have. And there is no such like division sign with that one dash and the 2 dots on it. This would be the actual division sign, which is very similar to creating some kind of a fraction. So this is how we design our mathematical operators combined with floats in this particular case. And now we can move on to our next value, which is going to be the Boolean value. And I'm sorry about this. I feel like I referred to this as some different type of data type, but true and false are our Boolean values. So you can use true and false for a variety of different things because they actually can tell you something, or you can just print them. So for example, if something happens, you can say print true, right? That's one thing that could happen. But you can also do this. So if I do print 9, or let's say, 9 is greater than, yeah, there we go. If I print 9 is greater than 10, that's technically a false statement. So that should actually give me false as a result right here. So you can't do that because this is greater than. If I did greater than or equal to, it should also say the same thing. It should actually give me an issue that says, no, that's also false. You can't do that. If I did less than, right? If I did less than or equal to, again, it will say what? It's less than, correct, technically it's less than, equal to, I guess technically it's also correct because at the very least one of these two things are true. So it will say, yeah, sure, it is less than or equal to 10. 9 is less than or equal to 10. That's right. If I wanted it to actually be equal, so if I wanted it to be equal, meaning comparing that this is equal this, then it should give me what? A false message as well. But if we wanted to assign something, so if you use one equal sign, you're assigning it. And notice how immediately it gave me a red squiggly line under it, because that's not going to work. You can't assign 9 as 10. And when you use a single equal sign, you're assigning something. When you do a double equal sign, you're now doing a comparative sentence, and that comparative sentence is going to say, okay, it's either true or false, right? That is what Boolean values are. They either give you a true value or a false value. Our next data type is going to be called a tuple. And a tuple is similar to a list, except instead of being wrapped by square brackets, it's wrapped by parentheses. And the very distinct difference between a tuple and a list, as we'll discover in a little bit, is that a tuple cannot be changed. It's called immutable, while a list can be changed. So these are called indexed values. So this is starting at the index of 0, this is starting at the index of 1, 2, so on and so forth, all separated by commas. That's how Python is created. So everything starts with an index value of 0, and then we'll talk about that as well in a little bit. I don't want to get too far ahead of myself. But the one thing that should be noted is that a list can be changed, which is called mutable. The items of this list could be changed. I could replace this with a different number, or I can even add values to this list to make this list longer. I can mutate. Technically, I think that's what that means. So a list is mutable, basically, while a tuple is immutable. You cannot change these values. If they're inside of a parentheses, they are set in stone, for lack of a better word. And it can, again, be a variety of different things. So you can have a tuple that is combined of just strings. You can have a tuple that is combined of just integers. You can have a tuple that is combined with strings, integers, and booleans, right? So you can have a variety of values sitting inside of a tuple. The main difference between this and a list is that the tuple is immutable, it cannot be changed, while the list is mutable and it can be changed. And then we have another value set, or a data set, which in this particular case is called a dictionary. And a dictionary consists of key value pairs. So one or more key value pairs is basically what a dictionary is. And in this particular case, we have the first value, or the first key essentially, would be 1. And then the value for that would be east, which is a string, as we've established. And it's separated by a comma. And then you have your second key, and then the value for that would be west, separated by a comma. 3 would be north, separated by a comma, and then 4 would be south. And these are inside of the squiggly brackets. They are not inside of parentheses, nor are they inside of square brackets. So squiggly brackets, just in the context of dictionary sets of data, this would be inside of a squiggly bracket, and then you can have as many values as you want inside of this, and you would be able to refer to this specific set as much as you want. So if I wanted to do a print statement right here, so let me actually do this. So I do a print statement, I highlight this whole thing, and I wrap them inside of parentheses, and hopefully I should be able to print this. Actually, no, you know what? I can't, because I removed my my squiggly brackets, and I was not supposed to remove my squiggly brackets. So let's see if we can do it this way. All right, so let's see if that'll actually print. We put basically the entire dictionary inside of our parentheses, and if we run it, it prints the whole thing for us, very similar to in the way that it ran the list for us. And what we're gonna start assigning these things to variables so that we can start messing around with the individual elements of these dictionaries and these lists and things like that, because once you start assigning all of these things to a variable instead of just using a print statement to print this, then you'll start noticing something very useful with what you can do with these data sets. It's just you need to know what these actual data sets are and how we can refer to them before we move on to variables, because it's very, very, very important, and they're super useful. Like, these things will stack on top of each other, as I promised earlier, and you'll just see how valuable these things are. Now let's talk about variables, and variables are very, very useful pieces of Python, and you will run across them all the time, and you'll use them all the time. In very, very basic form, variables are essentially containers that store data. So we'll go to the top of this whole thing, and we're just going to start fresh with this entire page. So let's see. What are variables, right? And how can you use them? So previously we had our string, which was hello world, right? That's basically what it was. Now what we can do is we can turn that into a greeting. So let's say greeting equals hello world. And instead of saying print hello world the way that we did before, now we can say print greeting. And now you're printing that specific variable. And if I run this, there you go, it prints hello world for us. What's interesting is that in the world of cybersecurity, there's a lot of different pieces that variables fall into, or I guess a lot of different pieces fall into variables, I should say. So we can create something called device ID, for example. So now we're going to start talking about the actual context of cybersecurity. And let's say this is going to be our device ID. So I can do anything, in any case, with this specific variable. And one of those things would be what? I can go ahead and print device ID, right? And then run it, and it'll print the device ID for me. And notice how it prints it exactly as is. It doesn't mess with any of the casing, and it doesn't change the order of anything. That's basically what it is for us, right? If we wanted to just demonstrate the difference between variables and strings, we could actually go create another device ID and then print those, and then it'll still print both of these values for us. There's something else that we can do, which is we can assign a variable the value of another variable. So for example, I do device ID, and device ID in this particular case is a string, right? Now I can do device type, right? Technically, I guess, or not device type, my bad. I could do data type. I could do data type, and that would equal type, and then we can do device ID. And now I have stored the type of this particular value, which is, in this case, is going to be a string, inside of this variable, which is my data type variable. And now I can do print data type, and once I print both of these, we'll see that the first one is the actual value that's inside of the string, and then the next one is the class that's been assigned to this particular value, which is a string value, which is what str stands for and what it represents in this particular case. If I were to replace this specific device ID, instead of doing it as a string, if I did an integer right here, and then we ran this and we printed it, you'll notice that, again, it'll just print those digits for us, but the class has now changed to integer because the type of this specific variable now has changed from what it was previously to what it is now, which is an integer. Now, if I put a dot in the middle of it, I guess you'll know what's going to happen, right? So it'll print what we got, but then the type of that value has been changed to float instead of being an integer, because we put what? We put a decimal point in the middle of this data. Something else that's really important to know about variables is that variable values can be reassigned. So if this is our device ID for now, and then we go over here and we print the device ID in this case, and now I create or no, I guess recreate is probably the right word, the same device ID variable, but now I put a different type of value inside of that. And then now I go ahead and print again device ID. And if we run this, we'll see that now we have both of the variables or the values of the variables. And in the first case, it printed this value and it printed it exactly as it's supposed to. And the next line of the script, because this is all being processed in order, right? So the first line was this assignment, this printed that assignment. The next line for the same exact variable, there's now a new value that's here. And when we print that, now it gives us the new value of this. So this is called a reassignment. So the very first one was the assignment, and then this is called a reassignment because we are reassigning a new value to the same variable. Now, to use just another example of this, I forgot to use comments in my last thing, and I'm literally saying, hey, you should use comments and everything. So what we're going to do is we're going to assign a value to username, and then we're going to reassign a value to username. And in our particular case, so this whole thing has to change now. So it's going to be username. In this particular case, we'll have be Smith, and then we'll print that. And then what we're going to do is we're going to reassign username into something else. We'll do Hackerson because he's a cool guy. And then we'll do print that username. And again, we ran it, and the first username value was J Smith, and it printed it perfectly. Then we reassigned it to H Hackerson for Hank Hackerson, and of course, it printed the new username, which is H Hackerson. Now, what we can do is we can assign variables to variables, as you already saw, right? What we did with the device ID and the data type, we can do the same thing in that particular case. So what we can do in this case, now we can do this. So we have our first value or our first variable, which is going to be username, and we can assign that to another value, which is going to be old username, which is going to equal username. And now if I did print old username, it'll print what? That same value, right? It should, right? Exactly. So it prints that same exact value. So if we wanted to put all of this together, we can create a really basic script right here. And it'll actually be really fun to do. And I really hope that you're, again, doing this as we're going through this whole thing. So here's our first basic script. For our first basic script, we're going to combine a few of the things that we learned and put it all together with a new little piece as well so that you can kind of get the feel of this whole thing. So first one is going to be username, and that's going to be whatever. We'll call it J Doe, I guess. Is that how you spell John Doe? I think. I don't know if that's how they do it. Old username is going to be equal to username. And then we're going to create a new username value now, right? And that's going to equal H Hackerson. So we have username right here, and that's our first username. So let's do this. First username, assignment, right? There we go. So now we have the comments for these first two pieces right here. And now we're going to do another comment where it says username is reassigned new variable or new value, excuse me. And now we have, technically, we have a few pieces right here. So first username assignment is going to be JDoe. The username, or in this case, is now reassigned to a new variable for old username, and now username is reassigned the new value, which is in this particular case H Hackerson. So technically we have two different usernames in this particular case, right? So we can now do this, since we want to be able to use both of these values, but both of these values technically at some point in the script have been assigned to this username variable. So what we can do is this: we can do print, and then we can put this inside of a string. We can say previous username, because this is literally going to be printed as a string for us, and it's inside of those quotations. And then you separate that with a comma, and then you do a space, and then the previous username is going to be what? Old username, right? And then we'll do another one, and it's going to say current username, or you could do new username, whatever you want. New username, again, is going to be separated by comma, and it's going to be just what? Username. And in this particular case, what do you think is going to be assigned in this case? Because this was the first line of code, and then this was the next line of code that assigned this value as this variable, and then we reassigned the value of username after this was done though, right? So this is after this was done. So we reassigned it to this value right here. And now technically when we run this, we should get both of the values along with this nice little string where it says, hey, previous username was jdoe, current username is hackerson, right? You see how that works? It's pretty cool, right? It's pretty interesting. And then we're just going to be able to now compile all of these things on top of each other as we continue to go along. But that was like a very basic understanding of variables, how to assign them, how to reassign them. And now you know that you can assign variables. Essentially, you can assign any data value to that variable. So I could technically even do this, right? I could basically go username and just turn it into usernames. And then from here, take this piece right here and do that right there. And then paste that over here and close that with a square bracket. And now I have a list of usernames that are listed over here. I can get rid of this whole piece right here. And now my variable is a combination of strings. And because the old ones don't exist anymore, you get that red squiggly line under there. And now we can say, instead of saying current username is this, we can say list of usernames are, and then print that, and now we'll get this list right here. There we have our list of usernames that have been assigned to this variable, and that's how it works. So you can assign essentially any data type to a variable, and you can manipulate it, you can print it, you can do a lot of neat things with it. We just printed them for now, but now you understand how to assign values and reassign values to variables. All right, now that we have gotten all of these basics out of the way, it's time to start talking about the pieces of Python that immediately and directly involve algorithms, or I should say these things yield algorithms. So when you understand how to work with conditional statements or iterative statements, functions, so on and so forth, when you understand the depths of these various concepts, you'll see how relatively simple and I dare say easy it might be to create algorithms. And so we're going to first go through what these things actually mean, how they work, and then we'll start creating some really basic algorithms. And then we're going to go further into it, and then by the end of this, you'll hopefully know exactly what to do and how to actually create your own algorithms depending on what it is that you're trying to build. A conditional statement is something that starts with the word if. So when you see if at the beginning of something, that is where the conditional statement starts. And immediately after the word if is the condition. And usually this is being applied to some kind of variable or a series of variables or a list or something of that sort. It's never really done by itself. It's rarely done by itself, I should say. So if starts the conditional statement, and then the keyword right after this is going to be the condition that is actually specified. So for example, let's actually just create something very basic, and then you'll see what I mean by that. All right, so here's our very basic if-else statement. So essentially what we're saying is that if a condition is met, then I want you to do something. In this case, it's just going to print onto the screen, hey, bring an umbrella if the weather is rainy. Otherwise, so that's where else comes in. So if the weather is rainy, do this. Otherwise, do this other thing, meaning else. So if or else, right? That's basically what we're kind of talking about in this syntax. So if the weather is rainy, print bring an umbrella. If else, then I want you to just print that the weather is nice today. So if we just ran this, it's going to say bring an umbrella because the weather is rainy. Now, anything other than rainy is going to constitute this specific outfit, or not outfit, this specific statement, right? I'm thinking about, oh, well, what are you going to wear if it's not rainy? My mind immediately went to outfits. So if we did sunny, for example, right, then it would say the weather is nice today. But if I also did windy, it would also say the weather is nice today because it doesn't exactly say rainy. So we can now put another condition in here that, hey, if the weather is sunny, great, or if the weather is windy, then maybe say bring a sweater or something like that. And this is where elif comes in. Elif is else if, and you can have as many of these as you want. So elif in this particular case, we're going to say elif weather equals windy, and then we've now given another condition. I want you to print onto the screen that bring a sweater, right? So now we're saying, hey, if the weather is rainy, bring an umbrella. If the weather is windy, bring a sweater. Other than that, the weather is nice, so we're going to be fine with that. And then we print that, and now we say, oh, it's bring a sweater. If I put cold again, right, it's going to say the weather is nice today. So this is where it becomes very specific that the condition actually has to match this. And this is where it becomes a very big deal when it comes down to strings. So if your conditions have to do with strings, not integers or any kind of numerical value, if it has to do with string value, then it becomes an issue. And then we have to worry about, or we're going to be talking about this in a little bit, we're going to be talking about logical operators. So if something is in one of our variables, right? So if rainy is in weather, for example, and let's say the weather is going to be this long string instead of just saying cold, right? It could say the weather is cold, for example. That's where the logical operators come in. And so you'll have things like in, or you'll have things like and or not, for etc., etc. And we'll talk about that in a little bit as well. But this is essentially the gist of an if-else statement or an elif statement, which is what we essentially call a conditional statement. So this is what we need to just understand, that you can do this, right? So we're going to keep elaborating on this just so you can understand what it looks like in the context of cybersecurity and how you would apply something like this in cybersecurity. So let's actually look at that now. All right, so here's a very basic one in the context of cybersecurity. So let's say we have a piece of our script that calculates the number of failed attempts, or we pull this data from one of our login authentication logs that we have. So a failed attempt would be when somebody tries to log into their account and then they don't use the proper username and password, and so now they have a failed login attempt. So if the failed login attempt number right here, if failed attempts is greater than 3, then I want you to print that the account is locked. And then ideally we would also put something else right here where we would actually stipulate the condition that it would actually lock their account, right? It would take that action and actually lock their account, and then print to that person, hey, your account has been locked. That's essentially what this would do. But the condition in this particular case, it's a little bit vague because we're saying that it has to be greater than 3. So if it's actually 3 failed login attempts, it's going to be the same thing. So actually, you know what? Let me run this as 6. So as 6, it says account is locked. If I do it as 3, it'll not print anything. So if failed attempts is greater than 3, print account is locked, and it's not going to do anything for me because I have not said greater than equal to 3. So, and at the same time, I also don't have any other stipulation. So I could say this, right? I could say else print login successful. And now we'll see what this looks like. So if I run this, it's actually going to say login successful because login attempts is 3. It's not greater than 3. This is very important to understand. So because it's 3, it's going to say, oh, you logged in successfully. Now here's the other issue, right? So if I say if it is equal to 3, so if we do double equals, that means that it's a comparative statement instead of assigning. When you have a single equal sign, you're assigning the value of this variable. When you do 2 equal signs, now we're comparing and we're saying, okay, so if failed attempts is exactly 3, then I want you to print that, hey, account is locked. But now here's the issue. So if the failed attempts is 5, it's going to say, oh, login successful. That's the problem with having double equal signs. So what do we do in this particular case? What we're going to do is we're going to say it's going to be greater than or equal to 3. Now in this particular case, if it's 5, it's going to say account is locked. If we say 3, it's also going to say account is locked. If it's anything that is below 3, then it's going to be login is successful. So this is how you use these specific greater than or equal to, less than or equal to, or exactly equal to by using 2 equal signs. That's a very, very important piece right here. that is something that you're going to probably use very frequently when you're dealing with specifically authentication and just making sure that people, and I mean a lot of values, it just really doesn't matter. It could be the IP addresses inside a specific file could be a greater than a certain number, so on and so forth. So I'm not going to get too ahead of myself because I do have other examples to be able to allow this to make even more sense for you. But this is one example where we're doing in the context of cybersecurity where we're talking about login attempts, right? So if it's 2, or let's say if it's 3 or greater, it's going to lock the account. If it's less than 3, they should be fine and they should be able to log in. That's basically what this does. So let's look at another example in this particular case where we're going to be looking at an operating system. Okay, so here's another basic one right here. So if it says if the operating system is 2, for example, it'll say operating updates are needed, right? If the operating system is not 2, then it'll say no updates needed. Now, in this particular case, again, we're going to have an issue because if the operating system, for example, is OS 3, we're going to print this and it's going to say, hey, no updates needed. If the operating system is OS 2, we're going to print this and it say updates needed. Oh, I accidentally clicked on my dictation piece right here. So let me just delete this real quick. So if the operating system is OS 2, it's going to say updates needed. If the operating system is OS 1, for example, it will say no updates needed, but that's not what we want because that's also an issue. So it should be technically less than, anything less than operating system 2 should say you need updates needed. But because we're not dealing with numbers, we can't use the value of less than or equal to. This is technically a string. So this is where this piece specifically, again, comes into play, where you have to now have an elif statement and say if operating system is also OS 1, then I want you to print same thing, right? Updates needed. If operating system is not 1 or 2, then you're fine. So in this case, we run it. Now it says update needed. If and then we like super fancy with this, right? So we can say if it's OS 2, for example, we can say this. So we can say so just like that. Now we can make it a little bit more user-friendly for us, where we run this and now it says operating system is OS 1 because in this value right here we have OS 1, so update is needed. If we're running it as operating system 2, operating system is OS 2, updates needed, right? So these are our conditional statements in this particular environment, and we're comparing what these specific values would be to what they should be, and as long as they are one of these two values, we get this type of a response. But if it's operating system 12, then there's no updates needed. If it's operating system 45, whatever, if it's anything other than these two, you'll get no updates needed. And this is where elif statements come in. And now you could literally do this for as many iterations as you want in this particular case, which is kind of useful, but it can also be redundant because in a lot of cases it may be a very long list of OS values that you have, which in that case you would probably go into using dictionaries, which we're going to do in a little bit, so on and so forth. But this is, again, just kind of helping you understand the conditional aspect of this, and then how you can have one value and that would be a condition for your if statement, and if this value is met, if this condition is met, then we want it to do something else. And then if the condition is met right here, we want it to do something else. So this would be the header, and I should have probably mentioned this earlier, so my apologies. So this portion of it without the indentation is called the header of the conditional statement. And then everything that is inside of that indentation is the body of the conditional statement. And then this one is considered another header, and this is considered the body, and this is considered another header, and this is considered the body. So the conditions are inside of the header, and then inside the body is what you want to take place when those conditions are met. And if the condition is not met, you also need to specify what you want your script to do. You should never leave anything to chance, or you should never leave anything undone, especially when it comes down to conditional statements or iterative statements. You want to make sure that every specific thing is accounted for, meaning that if all of these things are, you could have a dozen of these if, elif type statements, and then if there's nothing else, if it doesn't fall within those dozens or whatever those number is, you want that final else statement that says, if none of these conditions are met, I want you to do this one final thing, which is, whatever XYZ the action step would be. So you just want to make sure that you wrap your conditional statement with that final else condition at the very end to just make sure that you close it out. Let's look at another example in the context of cybersecurity. So we can say that status, so the status of something, could equal to, I don't know why it does these squiggly things when I've done nothing incorrect here. So if status equals to, for example, 200 in our particular case, we can have an if statement that says if, and then there's also a way that you can do this where you can put the condition inside of a parentheses if you just want it to be a little bit cleaner for yourself. So if status equals 200, you want to print that okay, right? So that's basically it. So you run that and status equals 200 and you're all good in this particular case. You can put it in parentheses. I usually don't put them in parentheses, but if you have multiple conditions that you want to put inside of your header for your if statement, it might be a little bit easier because you could say if status equals 200 or, and then do another one inside of your parentheses that you can separate your, and then it just makes it a little bit more reader friendly, I guess. Okay, so before we go into more examples of our conditional statements, I think that this is actually important to kind of just make sure that we handle this particular case here where we talk about our operators. So we have the less than operator, that's what that is. We have the greater than operator, that's what that is. You have the less than or equal to, right? That's what that would be. And then you have the not equal token. You have the greater than or equal to, right? My gosh, the autofill stuff can be kind of a pain in the butt when you're trying to do stuff like this. You have the exact equal to particular symbol right here. And then you have something that is called not equal to. So when you do a exclamation mark and the equal sign, it would be not equal to, which is what these operators are. So, if you can kind of just avoid or ignore these specific red squigglies, we don't care about these things right now. We're just trying to kind of extrapolate or match up what these things mean right here. So this is less than, this is greater than, less than or equal to, greater than or equal to. This is specifically equal to, so it's a comparative sign right here where one equal sign would be an assignment, two equal signs would be if it is actually equal to such and such. And in this particular case, when you do an exclamation and an equal sign, you're saying that it's not equal to. You're going to be using this very frequently, especially when it comes down to numbers. You can probably do the not equal to part with strings, and as you already saw, we can also do the equal to with the two equal signs with strings as well. But most often than not, when you use the greater than or equal to, when you use those specific operators, it's going to have something to do with numbers. And when you use anything other than numbers, you can use the double equal signs or the exclamation equal sign as well. And it could even work with Boolean values, which could be, the true and false values. You can also say that. So if it does equal to true or if it does equal to false, you want something to happen in that particular case. So these are our operators. We can, I guess, call them comparative operators. I don't exactly know what the technical term for this is. So I think it is called a comparison operator or a comparative operator. It's one of those two. Because we're technically comparing one value against what our condition is supposed to be or our variable is supposed to be. So that's what these are. And we're going to talk about logical operators in a little bit as well. These are specifically comparison operators, and they can be used for digits or numerical values as well as string values, depending on what the actual operators that you're using. And then we're going to be talking about logical operators in a little bit, which aren't very directly applicable to numerical values. They're only applicable to variables or string values or other types of values. So that's the main thing that I wanted to kind of get across real quick, just so you can have that as well. I feel like I may have skimmed over that. I'm not sure because I'm recording this video in multiple sessions or across multiple days. So I can't remember if I did speak about it earlier in this video. If I have spoken about it, then great. Now you have a redundancy and you're reaffirming that information and you're getting more of it, you know, kind of re-ingrained in your brain. If I didn't speak about it, then great. Now you actually have that information. So that's what we got right now. So let's do a few more examples of cybersecurity if statements, conditional statements. In this particular example, what we want to do is we want to compare status, right? So if the status of something equals something, and I should actually assign a variable to this already. So status in our particular case is going to, let's say it's going to equal 200 in this particular case. And then what we're going to do is we're going to say if the status is 200, I want you to print okay. If the status equals 400, which if you don't know your HTTP statuses, this would probably be a good idea to review them. Bad request would be what we can do for 400, and then we can have another elif statement if our status equals 500, which is a server error, so that would be internal server error. And then finally, we can have our else statement at the very end of it where it says check other status, right? So if it's anything other than, it could be a 300, so on and so forth. So if it's anything specific to these things, we have some messages that's going to print. And then if it's anything other than these specific things, it's just going to say check other status. So if we run this, it's going to say, hey, status is okay. You're all good because status 200. If I run 300, then it's going to say check other status because it's not 500 or 400. If I run 400, it's going to give us the bad request. And if I run 500, it's going to give me the internal. And you can see how this really can just go on and on and on, which makes it a little bit difficult because there are so many different status codes that are available for HTTP responses. And if those specific response, if we were to create an if or an elif statement for every single response status, then this thing would become very, very long. So this would be a great time to introduce our logical operators. And a logical operator kind of takes into account multiple sets of conditions and tries to combine those conditions for you. So for example, the status of 200, anything between 200 and 226 in HTTP response codes is technically considered to be a successful response. So we can actually assign an AND operator to our if statement to kind of account for that. So it would be like this, right? So if you do if status is greater than or equal to 200 and status is also less than or equal to 226, then we can just close our statement right here. That's what the colon does. It just closes that statement. You can say now print successful response, right? And that's basically what would happen in this particular case. Now my status at the very top right here is 500, so obviously that's not really going to work. But I could just do, do else right here and then just go print unsuccessful, whatever. You're kind of, hopefully you'll get the gist of what's going on here. So if I print this or if I run this, because my status is 500, it's going to say unsuccessful response. But if it's 224 and I run this, it's going to say successful response because I have, if my status is greater than 200 and my status is less than or equal to 226, if it's actually 200 because we have greater than or equal to, it'll still be good. If it's actually 226, it's also going to print successful because it can be less than or equal to 226. So this is called a logical operator, and we can have or be one of those things as well as the word not. So let's look at a couple of examples of that. So in this particular case, it was status equal to greater than or equal to 200 and then less than or equal to 226. Instead of deleting what we have over here, I'm just going to start adding to our statement right here. So if status is, for example, 100 or status is 102, which were the codes for informational responses, then we're going to have an informational response printed onto the screen. So if I do 100 in this particular case, it's going to say informational response. If I do 101, now interesting part right here, right? It's going to say what? Unsuccessful, because I don't have that actually stipulated in this particular case. I could technically go or status equals 101. I could technically run that and it will still say informational response, but in this particular case, we're not going to do that. We're just going to have these two specific values, and that's going to be separated by our logical operator, which is the OR operator. And then we have this beautiful little if, elif, else conditional statement block that we've created for ourselves, and it can be all fed by our status variable at the top right here. Now what we want to do, I'm going to just do another one right here where we add the elif, and in this case what we're going to do is not, right? And then we're going to do status is greater than or equal to 200, and status is less than or equal to 226, which is essentially what we're doing with our final else statement at the bottom right here. Then you can do whatever you want as your print statement right here, which is we could just do check status. Something that I want you to kind of pay attention to is that you could do a specific series of conditions inside of parentheses just to make it a little bit more legible. And when you do it like that, this piece right here, when you do a not in front of this, it considers this whole piece as the not condition. So if it's saying basically, if the condition is not this, I want you to write check status. If the condition is this, or if the code is this for status, I want you to print this thing. If it's this, I want you to print those things. So if I run it, now here's what's interesting, right? So this basically right here kind of says the same thing as this. But since this one came first, then it's going to print this specific result. If this one had come first, then it would print unsuccessful response. But this piece is technically saying the same thing as this else statement right here. But we have just assigned it to this, if the status is not greater than or equal to 200 and not less than or equal to 226, I want you to print check status. Does that make sense? And that's kind of what just another way that you can do something like this, but this is more specific. It's much more specific than just saying, hey, otherwise I want you to print unsuccessful. Instead of just saying that, you are specifying what you don't want your condition to be. And this, I would say, is probably a better way of doing it because, again, it's more specific and you're declaring exactly what you don't want the condition to be. And then in that case, you can have a series of actions take place inside of the body of your statement. But that's how you add a not logical operator to your statement. And then this is now we have our or, we also have the and these are all logical operators. That's pretty much it for our logical operators, and I think for the most part we've covered everything that you need to know basically about conditional statements. We're going to go through loops in a little bit, and we'll combine conditional statements with loops as well, so you'll get exposed to more examples of conditional statements. But for the most part, this is really what you need to know about conditional statements, that you can, again, just to finally reiterate, you can have your header, which is what this whole piece is right here. It starts with if, elif, or else is what your header would start with. You would have your condition right after that, and then it needs to be closed with a colon. And then your body would be indented, or it would be 4 spaces. It could either be 2 spaces or it could be 4 spaces. When you use something like an IDE, it'll just automatically create that indentation for you. If you don't use an IDE, you would have to manually either press tab or you would need to press the space button twice or 4 times to create that indentation. And that's very important to understand when you're writing a script inside of the terminal using Nano as your text editor or something similar to that. It's not going to automatically indent for you, and you need to fully understand that there is an indentation for every item inside of the body of your if-else statement. So if my specific body involved multiple lines of code, which we're going to see in a little bit, you're going to see much more complex versions of this in a little bit. If your body has many lines of code, you need to properly indent. Otherwise, you're going to have an error that's going to come back later on, and then you'll just see examples of this as well, because I want you to understand what errors look like and how to kind of decipher the error, or how to discern and differentiate what's going on with your errors so that you can debug your code properly. So this is the overall gist of what conditional statements look like, how they work, and that's basically all you need to know. And we're just gonna now move into the next phase so that we can just keep stacking on top of this, and then you can see how more and more complex algorithms could be built. All right, moving on to a bit more of a complex, but it's still super simple. Once you kind of wrap your head around it, you'll easily understand it. We're now going to go through iterative statements, and this is again that like this combined with the conditional statements and the operators that we just went through. When you combine just these three pieces along with all the basics that we just learned, then you can really start seeing the beginning workings of an algorithm being put in place. I just keep saying that. I understand that I keep saying that, but I promise you, as we go through more of these things, you'll just see how all these things are going to play out, and how it will ultimately end up becoming an algorithm. And you'll be like, oh, that's an algorithm? That's all it takes to build an algorithm? Yes, that is actually true. That is all it takes to build an algorithm. So let's talk about our first iterative statement, which is a for loop. So we have for loops and while loops. So let's talk about for loops. All right, if you are not familiar with the word iterate, what an iterative statement does is that repeatedly executes a set of instructions until another condition is met, and or you manually instruct a code to stop running whatever that iteration is. So it essentially means to repeatedly execute a set of instructions. That's what an iterative statement does. Now, in this particular case, a for loop repeats the code for a specific sequence or a specified sequence. So for example, it would be like this. All right, very, very basic right here. We have for I in this specific list that we got, 1, 2, 3, 4, and I in this case stands for integer. This could be replaced with anything. You could do an underscore. I've seen a lot of people do an underscore, and then you just need to, on this particular case, also say print the underscore. I don't like using an underscore because it's kind of confusing to me, but you can. I've seen people use an underscore and the code still works properly. So in this particular case, we're saying for I in 1, 2, 3, 4, or you could say for integer in 1, 2, 3, 4 print integer. Doesn't really matter, but just to keep it short, just to keep it simple, for I in this list, and there's 4 elements in this list because they're separated by these commas, so you have 4 individual elements inside of this list. I want you to print I. And now when you see this, each line is dedicated to that specific item in here, because it's going to go through this for loop, and for each of the items inside of this list, it's going to print that item on a new line for us. That's essentially the workings of a for loop, and it's very, very simple to understand. So it begins with the keyword for, and then that word signals the beginning of the loop itself, and then following that there's going to be the loop header, which is essentially this full thing that is ended by the colon, and then there's the loop body. And this can be very, very complex as you'll learn how to write more advanced code, and we'll go through this as well. For loops are used very, very frequently in Python, and this is the beginnings of automation. This is where automation really starts coming in, because you can build a massive script by just using for loops, while loops, if statements, and that thing can automate a lot of things for you. Every for loop also needs a loop variable, which is in our particular case I. So I is going to be our loop variable, and then after that loop variable, there needs to be something that is what that variable is connected to. And the variable is connected to specifically a sequence, and it's connected to that sequence with the keyword, or in our particular case, the operator in. So using that operator, you are now connecting your variable, which is I in this particular case, to whatever your sequence is, which is our list that is 1, 2, 3, 4 in this particular case. Now, what's interesting is that it doesn't necessarily have to be a list of numbers or a list of values. It could technically be a string. So if we wanted to do, let's say this is our string, or just to make it a little bit shorter, we could say our string is Hank, right? So we can say for I in Hank, and it's going to take every single item right here, every single character is going to be considered a piece of that I. So when I run it, it actually prints each individual character inside of this. Now, if I wanted it to be specifically 2 words, right? So if I wanted it to be 2 words right here, and I wanted to print Hank Hackerson individually, if I don't separate it, or if I don't put it inside of a dictionary, or if I don't put it inside of a list, it's going to treat every single one of these letters as an individual item. So if I want this to actually be printed as 2 words, I would need to put it inside of a specific dictionary, which in this particular case, it would be like this. So it would be Hank, and then you separate that with a comma, and then you do Hackerson, and you separate that with a comma, and then you print it, and now you have each individual word. But what if you don't have a specific number of items that you want to iterate through? What if you just want to repeat a specific action a certain number of times? Okay, this is another thing that's very, very useful with these for loops and these iterative type statements. So in order for us to actually understand what that means, the first thing that we need to understand is what a range function does, right? So there is something called range. And in this particular case, if I'm looking at a range between 0 and 10, what's going to happen is that it's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's going to stop at 9. So it's not going to get to 10, but it's technically still going to repeat this 10 times because we're also counting the number 0 here. So when you count all of these things, that's actually 10 times, but it's going to stop before 10. So this is very important to understand. If I did 0 to 11, then it would go until 10, and then it would stop at 10. If I did 0 to 100, it would go until 99, and it would stop at 99. So if you want something to iterate a certain number of times, you need to understand that specific part of it. The range value is going to stop at the number right before this specific number, the second number here. So this is something considered very useful inside of for loops, because what we can do now is we can actually use this range portion for our for loop right here. So if I did for range in 10, right? So for I in range 10, now meaning that we're going to go up to the number 10, including 0, so it is going to print something 10 times exactly for us. Now I want you to print something for me. So I want you to print I guess cannot connect, let's say, just to keep it kind of in this specific context of cybersecurity. But again, it could just print anything for me. So now it's going to say for I in range 10, I want you to print cannot connect to the destination. So when I run this, it's actually going to print this 10 times. So this is the same exact string that it's now being printed 10 times. And it's useful because sometimes you just need to do something repetitively and you don't know how to do it, especially when you need to do it in a very big range. So I mean, I'm gonna kind of go crazy here and I'm gonna print it 100 times, and now you can see that it's printed 100 times, and I could even do 1,000 or 10,000 and it would print it 10,000 times. And what's very useful again is that it does it in a second, right? In one little click, all it did was it printed this entire thing for me 100 times, or excuse me, actually 1,000 times, because I put 1,000 over here. So that's very, very useful. It didn't even take a second, and it did that for me. And a lot of times you actually need to do something that's that redundant, and that's why Python is actually so freaking powerful, because it can do something so quickly. It can do such a redundant, repetitive task so quickly that you start to wonder why you weren't using Python your entire life. And actually, that's when I first started learning this stuff, I really did wonder. I was like, dude, I've been missing out my entire life by not knowing how to use this amazing language. So this is one of the very, very extremely powerful portions of using these iterative statements, these for loops, to do a lot of repetitive things, especially when it comes down to doing something sequentially or doing something that's inside of a sequence. So we're combining now the power of for loops with the power of the range function. Now, just to give you a couple of more examples of what we can do with for loops before we move on to while loops, and I want some of these examples to actually be very relevant to this whole idea that we're talking about, which is cybersecurity. So let's say that we have a list in this particular case, and our list is going to be usernames, and our list of usernames is this. All right, so these are our usernames. Now, what I want my list to do, or what I want my statement to do, is I want to just give me all of the usernames in this particular case. I'm going to say for I in usernames, I want you to print I. Now, usually what happens in this particular case, when you have something multiple like this, you actually don't do that anymore. You actually say for name in usernames, and then you say print name. Or you would do for username in usernames print name. But this part, this specific piece, this specific variable doesn't really matter as long as this piece matches up. So as long as the username portion matches up, you could technically call this anything. It could be for I in usernames, it could be for name in usernames, it could be for X in usernames, whatever it is. So the usernames portion actually needs to match the name, that's the variable that's been assigned to the list. And then this piece right here also needs to match what's being put inside the parentheses for the print statement. So now what we're going to do is we're going to run this, and now it's going to give us all of our usernames printed out one line per, or one item per line, right? So that is something that you can do that would be specific to the cybersecurity world, I guess, or for system administration. Another one that we could do, for example, would be, let's say you have something called computer assets. So let's say you actually have a giant list of computer assets. And in a little bit, we're going to talk about how to work with files so that you don't have to paste your entire list of computer assets in here, because you could technically have thousands of computer assets. So you want to assign this variable to a document instead of manually copy pasting something in here. But for the sake of this particular example, we're going to have our computer assets, right? So our computer assets are going to be, and those are our computer assets. And then I can just say for asset, let me actually make sure I print that correctly, for asset in computer, and I'm just going to click tab and it's going to fill that in for me. I want to print asset, and then you run that and it'll print your asset for you. This is very, very useful. It's a simple example that we're doing right here with a very small list, but once we get into reading from files and just iterating through the items inside of the file, especially when it comes down to logs, when you start doing some of that stuff, you'll see how powerful these concepts are. But essentially, you can iterate through a list, you can iterate through a range of items and have it repeat something multiple times. You can iterate through a specific string. So let's say we change this completely and we say that's our string, because why not? So I can say for I in string and then print I, and then I will run that, and it's going to print every single thing for me, one per line. Now, here's what's something that you should also consider, is that the space is also considered as a character. So these two right here are actually being printed because it's in here as well. So you can iterate through each specific character of a string. And if you wanted to print these individually, we already saw what that is. You would have to actually put this inside of a dictionary, or not a dictionary, I keep saying that, inside of a list. You would need to put it inside of a list, which is wrapped with these square brackets. And then each one of these needs to be separated inside of its own quotation and then separated by a comma. And when you do that, then it will print each word for you individually. And this is what that would look like. I mean, you already saw what that would look like, but that's what that would look like. So if you want to print each individual word, then it needs to be assigned to its own string, separated by a comma, and it needs to be wrapped inside of a list. And then you'll be able to print each one of those words individually, one per line. If you don't do this, if the whole thing is inside of one set of quotes, then you're going to have a full thing that's available like that, that'll print for you. Well, it's actually interesting because I did not close the list out. So this is now considered to be one full item because it's inside of these brackets, and it's technically considered one item inside of a list. If I wanted to print each one of those letters, then I would do it like this and take it out of those square brackets, and it turns into one letter per line. So this is how you iterate through each individual letters if you wanted to. And I don't know why you would want to do something like that. It's just so you can understand how it actually works when you're working with these various data types, right? So a string, unless it's wrapped inside of those square brackets, that string is going to print each individual letter as a new line when you use something like a for loop. And finally, the last thing that I want to show you is something else that also has to do with range, which is you can actually ask Python to iterate through something in a certain, I guess, count, we can call it. So let's say we have this is our range right here. So this is what we're telling Python to do in this particular case. And I got to wrap it with a colon at the end. So for I in range 0 to 5, I want you to iterate by 1. And then when we run this, it's going to print each one of these things. Is going to go until 4, right? So it's going to say 0, 1, 2, 3, 4, and it's iterating by 1. If I did by 10, so I want you to do 0 to 10 and iterate by 1, it's going to count to 10, stopping at 9 because we already established that, and it's going to count by 1. Now if I did 2 here, now it's going to count by 2. So you see it's going to say 0, 2, 4, 6, 8. So this final number at the end right here, you're telling it by how many counts you want it to iterate through. So if I count every 3 numbers, then it's going to say 3, 6, 9, right? You see how that works? So this whole thing could be 100, and I could say I want you to count by 1, and it's going to give me 1 or 0 to 99 every single one. And then I could say, okay, well, I want you to count by 5, and it's going to give me 5, 10, 15, 20, etc., etc. I want you to count by 10. It's going to give me 10, 20, 30, 40, and you can see the results right here. So the first and second digit, and technically I could just say for range in, I don't know actually if I could, so let's try this. If I could just say for range in 100, print by 10, yeah, it's not going to work. So we actually do have to declare that first number as well. I just wanted to actually kind of test that out for myself. So if we're going to count in the range of 2 specific numbers, I want you to count by 10, and then I could just say from 10 to 100. For range between 10 to 100, I want you to count, and then you can see how it'll count 10, 20, etc., etc. For range in 50 to 100, I want you to count, it'll start at 50. So the first number is going to be where it starts at, the second number is going to be where it ends at, and then the third number is the number of places that it's going to count through, and that could be every 10 places, it could be every 5 places, etc., etc., etc. So that's actually one of the things that, again, this will become handy depending on what your use case will be, but it's also good to know that you can actually do that with the range function, where you can declare where you want it to start, you can declare where you want it to end, and then that third number is going to be the number of counts, the number of increments that you want this specific for loop to take inside of that range, and then it'll just go based on that increment, which is in this particular case 10. All right, now that we have understood how for loops work inside of our iterative statements, the next thing that I want to teach you is what while loops are and how they work inside of iterative statements. And while loops are very, very powerful and very useful as well. So while loops, the way that they work is that we're essentially saying while a specific condition is true, I want you to do something like this. And then when that condition becomes false, then I want the loop to stop. So previously for the for loop, we were saying for this many counts, I want you to keep printing. And then essentially you have to tell it how many times it's supposed to do something, or you give it some kind of specific condition or the number of conditions that it's going to use as it iterates. While loops work with a true false type of condition where it says while something is true, I'm going to keep doing this. If it becomes false, then I'm just going to essentially stop, or excuse me, if it becomes false, I'm going to stop doing something. So this is what that would look like essentially. So if we do time is 0 in this particular case, we're going to say while time is less than or greater than, excuse me, less than or equal to 10, I want you to print the time. And then if I just left it as this and ran this, it's going to keep going. It's just going to keep running. It's going to keep printing 0, and it won't stop because time is always going to equal to 0 and time is always less than 10, and it's just going to keep going. So I need to stop this from running because it's going to just destroy my computer RAM and the processor. So what we need to do is we need to give it another piece inside of this while loop, inside of the body of this while loop. We need to give it another piece so that it knows when to stop. And this is what we're going to do, is we're going to do another time variable, but now it's inside of the body of the while loop. And now it's going to be time, that original value, plus 1. So let's say for each time that you iterate through this, you're going to print the time. And then once you've printed that time, I want you to add an increment of 1 to that value, and then loop through this again, and then print it again, add an increment of 1, loop through it again, add an increment of 1, until you reach 10. And then when you reach 10, if you are less than or equal to 10, you're going to stop. So if I run this, now you see it stops at the value 10. So time is 0, it'll stop at the value of 10. If time was 5, you print it, it'll start at 5, and it'll stop at the value 10. And we can do this by, again, different variations. So we could say iterate by 2. So if it'll start at 0, it's going to print 0, then add 2, then add 2, then add 2, then add 2, you stop at 10. That's how a while loop works. It's going to keep doing something until it reaches the limit that you assign it. So here's how this is going to look like in the context of cybersecurity. All right, here's our little script here. So just to clarify, right, everything that is indented is inside of this while loop. It is the body of this while loop. And then this piece right here is outside of the body of this while loop. So what do we have here? We have a variable at the top called max devices, and we have assigned a value of 5, meaning that whoever the person is, they get a maximum of 5 devices that they can connect to their network in this particular case. And we have another value, which is our increment, and that our first increment is 1. So they start with 1 device, essentially. So while that increment is less than the value of max devices, so while 1 is less than 5, or 2 is less than 5, or 3, etc. While it's less than 5, you can just say user can still connect additional devices. But every time that they do, we're going to add an increment of 1 to their overall connected value. Once that I is no longer smaller than 5, meaning they have hit 5, then you're going to print this. The loop is going to break, that while loop is going to break, and then it's going to print user has reached maximum number of connected devices. If I indented this, it would print this every single time. As a matter of fact, let's actually show you this. So I'm going to indent this. So it's actually going to be included inside of the body of this loop. So if I do this, you'll see that it actually prints this. User has reached the maximum number of connected devices, because it's printing this every time that it iterates through the loop. So we don't want that to happen. We want it to print when they're finally done. So when we run this now, it's going to say, oh, 1, they got it. 2, cool. 3, 4, oh, they just hit 5. Now we could say greater than or equal to, or excuse me, less than or equal to, and then they'll get 5 completely. 3, 4, 5. So they'll get 5 completely. And then on the 6th one that they try to connect the 6th device, is going to say they reached the number of maximum devices, right? So if the maximum number of devices is 5, they can actually connect 5, which is what it should be right here. It should be greater than or equal to that. And then once they've reached that, actually, no, you know what? This doesn't even make sense, because this is where they would hit their maximum. You can't tell them that they can still connect to additional devices, because that would actually be misleading. So it should be actually less than maximum devices. And then this is upon their connection. So we could actually say something like this. So connected final device, and then user has reached maximum number of connected devices. Fifth device, right? This is the fifth iteration of this loop right here, and they've completed that, and now they've connected their final device, and they've reached the maximum number of connected devices. That's what a while loop does. It checks for a condition, and if that condition is still true, it's going to keep running. When that condition becomes false, it stops running, and the script moves on to its next piece. Okay, so let's keep playing around with this. So here's another example. So now we're going to do something that's actually really close to cybersecurity instead of just system administration, because connected devices is a little bit more, it's a little bit closer to SysAdmin stuff than it is to actual cybersecurity. So we want to create a specific script or a little algorithm right here that's going to look at the number of times that somebody has tried to log into something. So login attempts starts at 0, and while the login attempts is less than 5, we wanted to just print saying, hey, login attempts, and we're going to say this is your current login attempt value. And then we're going to, again, we need to increment this, because if we don't, it's going to keep iterating through this thing. It's just going to assume that everything is all good. So we need to increment this every single time that it goes through this loop. Otherwise, it'll just keep going through the loop. So then you go through this, and now you should be all good. And you go here, and then now if that whole thing is done, we can say finally right here. So we could say no more login attempts, right? And that would be it. And then we just run this, and now you have login attempt 0, 1, 2, 3, 4, up, no more login attempts. And that's basically how it starts. So I'm gonna do 1 in this particular case, because you can't say login attempt 0. They currently have 1 login attempt that's been done, and then we can now go through like this. So boom. Login attempt 1, 2, 3, 4, you have no more login attempts because you've been capped out, right? So we can do this. Maximum of 5 attempts reached, no more login attempts. That's what you got. So this is what technically what we're doing for a login attempt type of a script that checks somebody's attempts of logins. And more often than not, if you're using something like Active Directory, these things are already done inside of the scripting of Active Directory, which is why so many people and so many organizations love using Active Directory. But this is how you know what's working in the background. When you assign a variable, when you assign a certain number of login attempts that a user can make, this is what's going on in the background. The computer is going to say, oh, okay, all right, so we're going to compare their login attempts with the number that, John just assigned to the maximum number of login attempts that a user can have. And if they hit that maximum number of login attempts, we're going to send them an email that says, hey, you've reached your maximum number of login attempts. Account is locked. I'm just going to even do that, right? Account is locked. Boom. No more login attempts. Or to really make it official, contact your system administrator. We can say that, and that'll be the message that's printed onto the screen, and that's what they would see. That's typically what actually happens, right? It's like maximum number of attempts reached, and account is locked, contact the system administrator. And more honestly, to make it even secure, because this is kind of giving away to, if somebody's hacking your system, they're like, oh, okay, so I have a maximum number of 5 attempts. So instead of doing that, we're just gonna lock them out. Account is locked, contact your system administrator. Now they don't know how many maximum attempts that they have. Now I'm just kind of speculating and playing around with this, but you can kind of see how this whole thing plays out, right? So this is the whole point behind a while loop is this. So you have your initial variable, it sets your beginning condition. The while loop will iterate through the condition itself, and as long as that condition is true, it's going to take a specific type of action. When the condition becomes false, the while loop will break, and it'll move to the next action that is supposed to happen inside of the script. Now, if we wanted to create a little bit more of a secure version of this system that we have right here, because this is technically giving away some intel to somebody that is potentially trying to hack into our system. So we're actually telling them the number of login attempts they've made and all those different things. So instead of doing that, we could actually create a different type of while loop that would be a little bit more secure. It doesn't give as much intelligence away or as much as sensitive information away to somebody that may be trying to penetrate our system. So first we're going to create a variable that is the count variable, and it's going to start at 0. Then we're going to use a Boolean value, which is in this particular case going to be the true value for the login status. So their login status is true. Now, while we say while login status is actually true, then I want this while loop to do something. And in this particular case, it's going to print try again. And then we're going to iterate. So we want to iterate and add something to our count value. And then from there, we're going to add an if statement inside of our while condition, and that's going to say if the count equals 4, now I want the login status to change. Login status is now going to become false, and then we finish our while loop right here. So now we've combined an if statement inside of our while loop, and we're doing a few things with this thing. So you can see how just by a little extra few lines of code, our script has become significantly more complex. So we have the count, the original count, which starts at 0. Then you have your login status, which starts with true. And the while loop says if the login status is true, you're going to print try again. But then you're going to iterate through this count value and just add another attempt to it. And then if the count value reaches the value of 4, then the login status now becomes false, and they no longer can keep trying again. So then we can say, and now we go through that and look at that. Try again, try again, try again, try again. Whoop, your account's been locked. So simple. It's a very simple script. This is not that many lines of code, but it is relatively complex when you look at, oh, okay, we're combining a few things here. So we have the while loop that has been implemented, and there's an if statement that's inside of our while loop, and this if statement is adding another level of security to what's going on with this entire process, with this whole the purpose of this script, which is to check somebody's login status and whether or not they can log in. Essentially, this entire purpose of this script has been a little bit more complex, and it's been a little bit more secure by simply just adding this if statement inside of it, and now it's checking against the original count, and it's checking to make sure that login status is either true or false. And if it is indeed false, because once the count hits 4, it becomes false. When that actually happens, then it's going to lock out the account. The while loop is going to break. They're not allowed to try to log in anymore, and it's just going to print that the account has been locked. Pretty cool. Now, instead of relying on Python to actually break the code for us or to continue with the code for us, we can actually manually instruct it to do something like that. And we would do it with the keywords break and continue. So break will actually say, hey, I want you to break this loop, break out of this loop. Continue will say, you know what, skip iterating through this and just continue with the next one. So if something's wrong with whatever you're doing right now and you find some kind of a glitch with whatever you're doing, I want you to just skip this particular iteration and move on to the next one. So here's what those actually look like when we try to create some code. So we're going to go back to our computer assets. And just to make life easier, I save this. So I'm gonna put that right here. So there you go. So this is our computer assets. And now we're going to say this is our specific iteration. So for computer, or for asset in computer assets, what I want you to do is I want you to have an if statement inside of my for loop. And I'm going to say if the asset is desktop 20, then I want you to break. And then print the asset. And again, pay attention that the print statement is not inside of the body of that if statement. Print is inside the body of the initial for loop here. So what's going to happen when we run this? It's going to print laptop 1, and then if the asset is desktop 20, it's going to break the loop. It's not going to keep iterating, and it's just every single time that it does iterate for the asset, it's going to print whatever the asset is. So just to kind of show you what that would look like if we actually had more assets inside of this. So if I went over here and I just printed smartphones, and then I had desktop 20, and then I'll just do another thing right here where we would be IoT device. We'll do IoT 1 right here, and then break that, and then that's basically our entire list right here. So if I did this now, it should print this, it should print this, it should print this, and then it'll break this, and it won't print that last device, and you can see that it doesn't. And so just to confirm that it's all still working, what else can I do? I'll do smartwatch. I guess that would be another one. We run it, and then we can see that when it hits desktop 20, the cycle breaks, the for loop breaks, it doesn't continue, and for each iteration it'll keep printing whatever those assets are, because the print statement is outside of this if statement right here. This print function is inside of the body of the for loop right here. So for any asset that's inside of this computer asset, it's going to print that asset unless that asset is desktop 20. Once the asset equals to desktop 20, the loop itself is going to break, and it's no longer going to keep printing whatever the name of that asset is. And that's how you break a loop. Now, if we wanted this to keep working, you could technically just say continue working. So you don't want to break the loop. So for asset and same thing, everything stays the same. But instead of saying break the loop, I want you to continue the loop. That's what I want you to do. So if I run this, now all of a sudden you see that it does, for this particular case, we're saying that don't include desktop 20. That's basically what we're saying. Don't print desktop 20, but continue with the rest of the loop. So for asset and computer assets, laptop, smartphone, IoT, smartwatch, laptop, smartphone, IoT, smartwatch, and it just skipped over this particular one. That's basically what this if statement right here is saying, is we're saying don't include this in your print function right here. That's what we're saying. Keep going with the loop, and if I had, a million other items, it'll keep going. It won't break my loop. But if this specific thing is right here, then I don't want you to include it in your overall function. Now, something that could be interesting with this is that if you're dealing with a list of IP addresses and you want something to happen with those IP addresses, and you want those IP addresses to be allowed, for example. So let's say you have a list of IP addresses and you can't really cycle through all of those IP addresses manually, and you want all of those IP addresses to be allowed unless there's one IP address in that entire list that is a malicious IP address, so you don't want that IP address to be allowed, but everything else you want to be allowed. So instead of it being a print statement right here, it would be similar to firewall allow. That's not the syntax, but it would essentially, what you would be doing is that, hey, firewall allow this particular IP, allow all of these other IPs, but if the IP address is this specific IP address, do not allow it. But I don't want the break to happen, because I want you to keep allowing the rest of the IP addresses that are allowed on my list. I want all of those things to be allowed. But if this one is in there, or if my asset is inside of this dictionary that I have, or if the IP address, these bad IP addresses, let's say I have five bad IP addresses. If that IP address, if any of these bad IP addresses is inside of this giant list that I have, I don't want you to allow those IP addresses, but all the other ones I want you to allow. That's kind of what this is doing right here. This is essentially the function that it would have for this particular portion of the for loop. That's what continue does. You don't want it to break. You don't want the script to break. You want it to keep running. You just don't want those limited devices or those denied devices or those denied IP addresses to be included in whatever the functionality of your script is. So that's how we use break, and that's how we use continue. All right, now we are going to go into functions, and functions are, as you guessed, very, very useful in Python engineering, cybersecurity, etc. A function is essentially a section of code that can be reused in a program. And we've already actually used several functions. There are things that are called, I guess, built-in functions. So Python has a lot of built-in functions. And then there are user-defined functions. So one of the built-in functions that we've already used multiple times has been the print function. This is actually a built-in function that comes with Python. And every time we call on this function, in the background, inside of all of the other installation requirements that is required for Python, something is running in the background to actually run this print function. And then what it does for us is it just prints whatever we put inside of this thing onto the screen, right? So that's one of the pre-installed or built-in functions that comes with Python. And I'm going to show you actually a list of a lot of different functions that are actually very useful, and we've used several of them so far. We have obviously the print function, the type function we used a little bit earlier. The input function is very, very useful. I use the input function all the time. The length function returns the length of a sequence. The type function we already know. Input is basically, it prompts the user to input something. So you ask them a question or you tell them to do something, and then they have to interact with the script that you're running and input something into the script in order for it to continue running. And actually, they don't input anything into the script. They input onto whatever they're using to run the script. So it could be their command line interface, it could be Python as the IDE, because you can interact with code that way. And then there's all of these other pre-made built-in functions as well. And we're going to be talking about split and join and these various pieces as well, just so you can kind of get a chance to work with these and know how to use them specifically in the context of cybersecurity. There's a lot of this stuff that applies to engineering in general, but we don't necessarily need it for this tutorial, especially because we're not going to be doing extremely advanced stuff. I want to keep it fairly simple for you so that you can wrap your head around all of the necessities. And then when we get into the algorithm building, we're going to be combining a few of these things so that you can actually start building your algorithms. And then most likely there's going to be a completely separate tutorial that I will pull together so that we can do some more advanced stuff together. So these are just some of the built-in functions, and they're the most commonly used built-in functions. These are not everything that comes with Python. There's a lot of built-in functions that comes with Python. For our intensive purposes, though, we're going to be building our own functions. And we're going to start with obviously super basic ones, and then we're going to keep making them more sophisticated and more complex as we go along. So just like everything else that we've done so far, there's an initial word or an initial series of letters, so on and so forth, that will define what it is that we're trying to do. So previously we had the while loop and the for loop, so on and so forth. In functions, the initial phrase or the initial word, I guess, is def. So def is defining the function. You start the function with the word def. Right after this, we need to assign the name to the actual function. So for our case, let's say we're going to create one that says greet employee, and then this is how it ends. So this is going to be our header. You should already be familiar with what headers are because we've used them for loops and while loops. So the greet employee is the name of the function. It has to be wrapped with this open and close parentheses, and then we can also even put various arguments inside of this, and we'll talk about that in a little bit. And then the header is closed with a colon. For all intents and purposes, most of the things that you're going to be doing, even when you create classes and objects, those things are also going to be closed with a colon. And then because of the fact that we're using an IDE, as soon as we press enter, it already tabs forward for us, and then now we can write the body of our function. So now in this case, just greet employee is going to be very, very simple. We're going to call on one of the built-in functions, right? And it's going to say, hey, welcome, you're logged in, and that's it. So logged in, and there we go, and that's it. So this is the function, very, very, very basic, very simple. But if I run this, it's not going to do anything, because I have to now call on the function. So this is what's very important to understand about this. We need to always, there's actually a lot of times when I was creating functions for various other scripts towards the beginning of my coding career, so to speak, and I kept forgetting to call on the function. And I'm like, dude, why is my code not working? It's glitching, there's something wrong. And the big thing is that I just never called on the function. And so to call on the function, it's very simple. You just actually type in the name of the function, just like that, and then now you've called on the function. And that's basically it. And now if I run it, it's going to call on that function. It's actually going to do what it's supposed to do. So that is a very, very basic function where we just say, hey, greeting the employee. Now we can do this. And now they're going to call on the specific thing as many times as we want. And what's fun about this is that when we start putting arguments inside of it, and you can start customizing the function based on the arguments that go inside of that thing. So that's what we're going to try to talk about right now. All right, now here's the modified version of our function. And the only thing that we've done in this particular case is we added an argument to it. So we passed an argument, which is in this particular case is just called name. It can be called anything. You can have multiple arguments. In this particular case, we're just calling it name. And what I've done here is I've formatted my string. So when you see this F in front of it, I could technically do a version of this, which it ends up just becoming much more complicated and requires much more work. But if there was an unformatted version of this, I could technically do this. I could actually remove that F from the beginning, and I could say welcome, and then I would have to put name by itself now, just like that, because now we're calling on that variable, and then you can say you're logged in, right? And that's technically a version of this. But then if I wanted to add this cool exclamation at the end, I would need to also either do it separately or just do this kind of a thing where it's like it's a little bit weird, and you still try to run it, and I mean hopefully it'll work. If I feel like it's not gonna work because there might be something missing, yeah, so it says perhaps you forgot a comma. Yeah, I did forget a comma, so I need to put a comma right here, and then I'll probably need to have put a comma right after this as well in order for this to work. So this specific piece right here is going to do exactly what this does, but now you can see I had to first put welcome inside of its own quotes, then separate the variable name or the argument name, and then add this piece at the end. And once we run this, it's going to do exactly what we wanted it to do on the first line. So what you're doing when you put F in front of this, you're now creating a formatted string. And a formatted string allows you to put variables and arguments inside of it, and it'll make the call to that variable or the argument. When you do this, you have to put the variable or the argument inside of these little squiggly brackets, as you see right here. And now you can essentially do as many of these things as you want. The reason why this is much more convenient is if you had multiple variables that you had to call on and you had to pull them inside of your string, it is really a pain in the butt to just keep doing open quotes, close quotes, and then try to fit in the variable, so on and so forth, when you can just put F at the very beginning of the string. And then if you wanted to do it in a sense where very kind of similar to our comments, where we wanted to just do enters, right? Like now you want to create a new line and you want to just keep typing, let's go, hope you enjoy your stay, something like that. Let's see if it'll work without the indentation. It does, right? So it actually now works, and now I can keep typing as much as I want, and I can recall that function again and run it again, and it'll still recall that function. So this is very, very useful with formatted strings, and all you have to do is just put an F in front of your string, and then you can put whatever else you want inside of your string, so long as you make sure obviously you use the right number of quotes. And then because of the fact that I don't have triple quotes, now the rest of this looks really, really funky and it doesn't recognize what's going on, so I need to put everything back on one line so that it can read the string properly. But that is what a formatted string is. Okay, so now we can talk about recalling this function, and this is what is kind of very useful about this. So if I wanted to now say greet employee John, and then we'll do another one and we'll say greet employee Jane, and we run this, the same thing happens with just now these new arguments, right? So it'll run everything that's inside of the function body. it'll do that as many times as you need with the new arguments that you assign it every single time that you call on this function. And this is what is very useful about creating and running functions. So this is the very basic version of a function. And now you understand what it means to be able to reuse the function as a block of code. And now we're going to go into creating a little bit more complex of a function, so that now we can kind of get to see all of everything that we've discussed so far, how it actually fits into creating a little bit more of a complex function. Okay, so now we're going to create an investigation function, and it sounds super funny, super fancy. I was going to say not really funny. So first we have to obviously declare that we want to create a function, and we do that with the def keyword. And then we want to, assign a name to it. So it's going to be this investigation is going to be the name of our function. And we want to pass this argument, which is type, and then you'll see what I mean by type in a little bit. And really, the only thing that the function is going to do is it's just going to print this string for us, and it is a formatted string because I want to pass my my argument into it. So it's going to say investigate the type activity, whatever it is, right? So that's basically what the body of the function is going to look like. But the script obviously is not done, and we need to do some more scripting or coding in order for this to actually do what we want it to do in regards to our investigation. So first we are going to create a new variable which is going to be the application status. And the application status is going to say potential concern, right? Then we're going to create something that is the email status, and that's going to say okay, just for this particular case. Now, what is going to happen is we're going to create a couple of if statements. The first if statement is going to be applicable to our application status, and we want that to say if the application status is potential concern, then I want you to print onto the screen that the application log is going to say something to us. So this is coming from the application log essentially. So the application log is going to tell us what the function is going to tell us, which is our investigation function. And now I need to make sure I just pass a type into it. And in this particular case, we're going to pass the string email, right? So investigation not email, my bad. It's going to say application because this is coming from the application log. So if the application status is potential concern, you're going to print onto the screen application log, and then we're going to call on this function, which is going to print onto the screen investigate application activity, or ideally that's what it should be printing onto the screen. So that's what that's going to do for our application status, the if statement for that. Then we're going to create another one for email status, and it's basically going to say the same thing. So if email status is potential concern, right, it's going to print onto the screen. Now in this case it's going to say what? It's going to say email log is talking to us, and let me just keep it consistent. So email log is talking to us, and the email log is going to tell us what the investigation function is going to tell us, and in this case where it's going to say email, right? So, or let me keep that lowercase just to keep that consistent. So that's basically it in this particular case. What we've done is we've called on our function twice inside of this code, and inside of this code we are essentially saying that the function is going to just print this onto the screen, and it's going to print the type of log or the type of activity that's going to need to be investigated. And then we assigned these variables outside of our function. So these this is kind of just throwing this at you. These are called global variables. If they're outside of the function, they're global variables, and they can be used in any part of your code inside of any function that you create. When the variable has been declared inside of the function, so if I did this inside of the function and I created application status inside of the function, this would be considered a local variable, and it can only be used inside of that function. The data that would be inside of that function for application status could be different, and it could only be used for that. You would never rename, like you wouldn't use the same name for a local and a global variable because it would just become really confusing. But in this particular case, just to kind of throw this at you, I understand that this might be, I don't know, it feels like it might be a little bit out of order. But again, I'm not like the greatest coder, so I'm just kind of trying to make sure that you get all the information that you need. So these are the two global variables that we've created. There's the application status for potential concern, email status that's currently saying okay. And in our if statements, we're saying, hey, listen, if the value for application status says potential concern, then I want you to do this, right? If the value for email status says potential concern, then I want you to do this. Now, if I run this, hopefully it'll actually work. And it does, because the only one in our two conditions that we have here, these are our conditional statements, right? So the only one inside of these two conditions that actually matches what we were writing right here is the application status. If I change the email status to also say potential concern, then we should actually get a message for the email log as well, saying, hey, investigate email activity now as well. If both of these say okay, then none of those things are going to print. And let's do that just so you can see what that looks like as well, because there is a possibility that the script is working and you're just now, when it finishes with a code 0, that means there were no errors or anything that happened inside of your script. The script ran fine, everything was all good, but nothing printed onto the screen because there is no concern. There's no potential concern. Both of our application statuses are okay. The application and email statuses are both okay. So we don't need any kind of investigation message to come up, right? So that's basically our, it's kind of a more complex scenario, but the function itself is a very, very simple function. And then we called on the function twice using these two if statements, and we assign these global variables to measure and manage what happens inside of our if statements. So if both of these say potential concern, it's going to print something onto our screen for us that says, hey, the application log requires investigation, the email log requires investigation. If both of them say okay, then neither of these things print because, and I mean, let me actually do that, right? So if I do this and say if right here, and then we have an else for this one, and then it's going to say print everything is okay with email or application, right? And then in our particular case over here, we're going to do another one that says else print everything is okay with email. There we go. So we run this and it says everything's okay with application, everything's okay with email, because both of the statuses on here say okay. If the statuses said potential concern, then it would print, hey, there's potential concern that you have to worry about. All right, so I'm just reviewing my notes here, and one thing that I do have to correct, because I know the comment section is going to come after me. This is when it's being defined in the header of the function, it's actually called a parameter, and then when you run it, you are providing an argument. So parameter is when it's being declared inside of the header of the function, and then when you run it as a script, or when you run it later on, or when you call back to it, you are supplying an argument. So in this particular case, this is our parameter, which is type, and then application, when we call on the function, application in this phrase, or in this case, is the argument, and in this case, email is the argument. And I kept referring to it as argument earlier, but when you're declaring what you want inside of the header of your function, you're creating a parameter, and then when you call on it later and you supply the information or supply the data, that is the argument. So I just wanted to make sure I clear that up before, I mean, the comment section probably at this point, because it's too late now, so some people have already dropped a comment saying that I made that mistake. So I appreciate you paying attention, and if you're going to correct me about it, I appreciate you trying to correct me, but I did fix my own error. I did address that. So let's do a few other function examples before we get into some of the more complex stuff. So we're going to now create a new function, and this is going to be a very, very basic one. that is going to combine a few of the things that we've learned so far. So we did already the if statements combined with calling on a function, but we can now create another very basic one that inside of the function we're going to use a for loop, and it's going to have the range function inside of it, and we'll give it a range of 3 for in this case, and then we're going to print for that range potential security issue, investigate. And basically what this is going to do once we call on it is hopefully it will actually print this for us. So it's going to print this particular thing, and I mean it should. So let's see. Oh, you know what? I'm missing something. That's why it's giving me a squiggly, a red squiggly. So there you go. That's what it is. I forgot the keyword in. So the alert function is basically just running this for loop, and it's going to run it 3 times because we gave the range of 3, and it should print onto the screen what potential security issue investigate. That's basically it. And this is just an example of using a for loop inside of a function, and we're going to create something that's a little bit more complex right now, which is going to convert a list into a string. And this is going to be, you're going to kind of start seeing how powerful this can be when you run it inside of a function. So first what I'm going to do is I'm going to import, because I don't like typing dictionaries and I don't like typing lists, so I made one in advance, and I'm just going to copy this real quick, and we will paste this in here. Hopefully it comes through fine. There we go. So this is our username list, and as you can see, this is a list, right? Because it's wrapped inside of these squiggly brackets. Now, if I were to just print this, so this is what it's going to look like, right? So I don't know if you remember this, but if we were to just print this, it's actually going to print it exactly as it is. It's going to include these square brackets. It's going to include the quotations around each one of the usernames. And that's kind of ugly. It doesn't work. I don't like it. So what we're going to do is we're going to convert this to a string. And we're going to create a function that will be called list2string in this particular case. And this list2string function is going to take all of those list items, and it's going to iterate through them, and it's just going to print them onto the screen for us as an individual string. And this is super freaking simple, but you can see how powerful it is. So it's literally 2 lines of code inside of our function. It's going to be for I in username list, that's it, print I. That's it. That's the entire function. And then when I call this now, list2string, when I call this, pay attention to what happens at the bottom right here. We have a list that's being output like this. I run it, and now we actually have this wonderful organized, you know, E. Larson, B. Moreno, each person gets their own line. There is no ugly square around them. There is no quote around them. Very, very basic little script, like literally 2 lines inside of the function, including the function header itself. There's a 3-line piece of code, and it happens to do something very nice for us where it creates a cleaner output for us. So this is how you put a for loop inside of a function. Now what we're going to do is we're going to recreate this in a way that you can actually print all of these things in one line. So what I'm going to do first and foremost is I'm going to do it, I guess, kind of incorrectly. So the first thing that we got to do is we got to take our username list variable, which is currently a global variable because it's sitting outside of the function. We're going to cut that, and we're going to bring it inside of our function. And now it's going to be a local variable. Then we're going to do something and add another little variable, which is going to be the sum variable, or I could literally, if I actually just call it sum, it's another function that's inside of Python, and it's going to try to create the addition mathematical function where it actually tries to give you the sum of something. So we're going to say sum, or I could even say total. I think that should be fine. Or we could say complete. That should be fine. Either way, we're going to turn this into an empty string. So now we have two variables. We have one variable, which is the actual username list, and that is an actual list. And then we have the complete variable that's just an empty string. Okay, so far so good. Now what we're going to do is we're going to modify our for loop in this section right here. So instead of just printing I, what we're going to do is we're going to, for each one of these iterations, we're going to just do a new complete variable, and that is going to be the original complete plus I. Okay, so it's going to just do this, which is an empty string currently, and then for every single one of these items, it's just going to do that complete empty string plus that item, then that item, then that item, so on and so forth. But you may have already guessed that this is actually going to give us a little bit of an issue. So what are we going to do at the end? We're going to print our completed variable right here. And then let's see what this actually looks like. So I'm going to give you the kind of before we correct everything. You see, it jumbled up everything together. And this is like weird, right? So it is technically all on one line. That part of it is right. But now E. Larson and B. Moreno, like it's very difficult to be able to separate these people and try to understand what's going on. So we do need to make another little addition or modification to our code so that it can actually do what we want it to do. And it is really basic. It's actually not complicated at all. So what we're going to do is we have complete, which is the original variable, plus that item, right? And that's all good. So what we're going to do is we're just going to add another plus at the end right here. And we're going to put a string separated with a comma and a space. So now it's going to say this item, comma, space, that item, comma, space, that item, etc., etc. And we run it, and look at that. Beautifully done. And now you have all of these people converted into, instead of being a list output, you have a very, very nice and beautiful string that is on one line instead of being one person per line. And that's basically the entirety of this function that we have over here. And just to give you the difference in the two outputs, right? So if I just did this, if I do this and then do print username list and then we run this, you can see the difference between the two, right? So you have, this is the one that's currently in a list format with the quotations, etc., etc. So what we wanted to do in this particular case is turn it into a string format, get it out of that list ugliness, and then still make sure that it still has the comma and the space separating all of the usernames so that it's nicely readable or legible, I guess is the correct word. And we have done that. So very, very easy, quick little function that we just created that is very functional, and it actually does some really good work for us. All right, the next thing that I want to share with you in regards to functions is I want to go back to creating another function that has a couple of parameters assigned to it. And in this particular case, we're going to assign two parameters. So previously what we had, and we'll just go back to the greet employee function that we created. Previously we had just something called name, and then we just gave the name. But what we want to do in this particular case, we want to give a first name and we want to give a last name. I don't know why I said last week. We want to give a first name and a last name. So you notice that you have our two parameters, they're separated by a comma, and now this function is expecting two parameters, two arguments to be fed into it. And it's going to say what? Print, right? We could do this version. So we'll do welcome, you're logged in, and then we'll do space, close that, and then comma, first name, and then last name, right? You could do it like that, which is perfectly fine. In this particular case, we need to make sure that because we're doing the print statement and we are doing the assignment of these two specific arguments that are being supplied to it, it does need to be separated by a comma in the print statement. But in actuality, when you want it to be printed, it shouldn't be printing a comma between them. But the syntax in Python requires that when you provide two different arguments to it, you need to separate them by a comma, but it's not going to actually separate them by a comma. If it was going to separate them by a comma, we would need to supply the comma inside of a string like that, and that's not going to be what's going to happen in this case. We just need to separate them by a comma because we're providing two different arguments. I hope that makes sense. So now we have finished our very basic function one more time, and now what we want to do is we want to call on our function, but now we got to give it the actual name and last name, right? So it's going to be, let's say, John and then Smith, right? First name, last name, greet employee, John Smith. You run that. Hey, welcome, you're logged in, John Smith. And notice it does not have the comma separating the first name and last name, right? Very, very simple, very easy. And that's basically how you supply multiple parameters into a function. And you can have a lot of these things, right? So, and this is why I like kind of using formatted strings. So let's say we do this now. Let's say we add another piece in here where it's going to have their city. And if I wanted to do that, I could do, again, so this would be the thing, and then I would have to do, I would have to comma, separate that, do a period, and then add the rest of this that I want to add, and it will be, let's say you're located in city, do that, separated by a comma, and then put the city here, and now we've called onto this thing. And then finally we can go down here and then we can say, I don't know, wherever, New York. Whoops, it needs to be a string, so New York, right? You run this, and now you says, hey, welcome, you're logged in, John Smith, you're located in city, New York, okay? So you can supply as many parameters to this thing as you want, but when you go after like higher than a certain number of parameters, it becomes really complicated to just keep doing this thing where you separate these by this. So what we can do is we can just create a formatted string, and this is why I like formatted strings. And it could say the same exact thing. Welcome, you're logged in. Now we can do what? First name, right? Just like that. And then we can do, again, last name, because now we don't need to do a comma separating these things. Period. You're located in, and I don't even need to do city at this point. I could just say you're located in, and then do our little squiggly bracket, boom, and that's it. And now we're done, right? So we run it, and now you have two different lines that are printed. This one actually gave us even a better output, or I forgot to put you're logged in, so we'll do that. It gave us a different output because in this case there were two spaces for whatever reason, because I put a space here, and I guess it was going to already create a space between this and the next one. So that has already been taken care of by the formatted string, because all I had to do was just type it the way that I normally would, and then just put the first name and last name inside the squigglies. I put the period, and then I did you're located in such and such. And yeah, it's just cleaner, it's easier. If I wanted to do another piece right here and do job title, right? You're located in city da da da. This would be the version right here where we would have to do, again, comma, go here and do another string and says your job title is, and then feed the guy's freaking job title into it. And then it's going to be, I don't know what his job title is going to be, but we'll fix that in a little bit. Whereas in this particular situation, I could just keep typing inside of my quotes and just say your job title is, and then do job title, just like that, right? It's just easier, I'm telling you, especially when you're dealing with more and more parameters. And specifically, we're dealing with strings right now, because for strings, this is what's important. And you're going to create functions, sorry, I just hit my microphone. You're going to create functions that will require the printing of certain lines and strings, because of the fact that you either want to communicate with the user, or you want to kind of know where the function is working and at what point of the code it's in, so on and so forth. So you're going to want to call on parameters inside of your function, and you're going to do it inside of a string that's being printed onto the screen. And when you do that, if you have too many of these things, and so let me actually give this guy a job title. What is he going to be? Your job title is tech guy, whatever. So run that. And that's it, right? So when you do this, you just want to get into the habit of creating formatted strings. That's all I'm going to say, okay? Get into the habit of creating formatted strings. It'll make your life so much easier instead of having to do this whole spiel right here where you do the comma separated by the da 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 da. So you get what I'm talking about, right? So we wanted to use formatted strings, and this is an example of how you can create a function that does multiple parameters inside of it. All right, now what we're going to do is we're going to incorporate another piece, and we're going to teach you about something called a return statement. So when you are working with data inside of functions, a lot of times you're going to want the function to return something that it's doing if it's calculating something, for example, or if it's processing something, if it's pulling data from another source or from a file, so on and so forth. You want it to return that data, meaning return it to you so that you can use it for something else, or you can print it onto the screen, so on and so forth. So we're going to do something where we create our function again, and it's going to calculate the fails, right? So failed login attempts, essentially. And what's going to happen is that we're going to give it two parameters in this case. One of them is going to be the total parameter, or the total amount of attempts. And then the next one is going to be the failed number of attempts. And those are going to be our two parameters that are going to exist inside of this function. Then we have to now calculate this. So what's going to happen is we're going to create a failed percentage variable, and we're going to take the failed attempts, right? And we're going to divide them by the total attempts. That's going to be how you calculate the percentage of something, right? So you take the failed number divided by the total attempts that have been made, and then it's going to now give you some data. So in order for us to be able to return this data, because we can't really, I mean, I could technically print it onto the screen, but maybe I don't want to print it on screen. Maybe I want to return it so that I can reuse this data. And this is what's going to be a big deal, is that you want to be able to reuse data later on in your script. So it's more important than just printing what the thing is. So this is where the actual word return comes in. And then you just say return the failed percentage. And now if I call on this function, and notice how as soon as I did that, it actually now went back on the indentation, because it is assuming that the function is now over. Typically when you use return at the end of something, it's going to end the function. So if I wanted to, before this, if I press enter, you see how that is still indented. But if I go right after my return statement and press enter, I am now on a brand new line, and it's just assuming that I no longer am going to be inside of that specific function. So now what we're going to do is we're going to call our calculate fails function, and now we have to give it a value, right? So it's going to say there's 4 total attempts that were made, and 2 of those attempts were failed. So let's run this and see what happens. Nothing happened, because it just returned the data. It didn't do anything else. If I wanted it to do something else, I would have to say, hey, print fail percentage. And let's just do that, right? Let's see what happens in this case if I just print the failed percentage. Now it actually is giving me the calculated number that it got. So we had 4 and 2. So 4 was the total number. 2 was the failed attempts. The failed percentage is calculating the failed amount, which is 2 divided by 4, which is going to be what? 50%. That's basically what that is. That's half of this right here. So I have now printed my failed percentage, and I can even say this, right? Let's kind of combine all the things that we're using. F for formatted. We're going to create a string, and it's going to say your failed percentage is, and then you do that, and then you just wrap this thing inside of the squigglies. I gotta make sure I just delete that, so fail percentage right there, and I just gotta make sure that I do this part correctly so it doesn't mess with anything, and you do that, and there you go. So now we have our formatted string. Instead of just saying 0.05, it's going to actually print that onto the screen where it says, hey, your failed percentage is 0.05. Okay, so now we have a little bit of a working function. But what we want to do is now we want to give it another action step to do, because we don't necessarily just care about knowing the fail percentage. We want to do something with this information. So if somebody's failed attempts, right, is greater than or equal to a certain percentage, we want something else to take place. Okay, so this is where the information gets really, really interesting. So what I can do now is I can create a new variable, and inside of that new variable, I can actually have the function be the value. So calculate fields is going to be the value of this variable that we've created here. And it's going to have the same thing. It's going to have the 4 and 2. And then I'm just going to delete this piece right here. And now what has happened is that my function has returned this information. And now my script can use the information, that information that's coming from this function. The script can use that information to supply the value of this new variable that I've created. And now that I have that, now I can say if percentage is greater than or equal to 0.5, then what I want you to do, I want you to print, and in this case we're just printing that the account is going to be locked, but ideally you would want to actually also lock their account. So now if we do this, it says, hey buddy, listen, your account has been locked because your percentage, we already know that the percentage is 0.05. It's going to say, hey, your percentage is 0.05. Your account is now locked, right? If I went and did this, it probably isn't going to print your account is locked because your percentage is 0.025. So what I can do is I can give it another else statement and say print access granted, for example, right? Just like that. Now we run this, and now you say access granted. If it was 3, so it's 75% now, account has been locked. Does that make sense? Failed percentage is 100%. Yeah, your account's been locked. Does that make sense? So this is how you return data from a function, and then you use the data that has been returned to create a new variable. And now what I can do with this new variable is I can create new conditions. And I can say, hey, if the value of this variable is such and such, I want you to do this. Otherwise, do something else, right? And if I wanted to, I can also write an elif statement inside of it where it's saying else if something else is going on, else if something else is going on. But that's basically how you can return data from a function and then reuse that data throughout the rest of your script. And just for good measure, so what we're going to do is we're just going to create another one. And this one will be for remaining login attempts. And for this, we're going to, again, max attempts, right? And then we're going to have total attempts. And those are going to be our two parameters. And our function is just going to say return maximum attempts. And you can also do it like this, right? So where instead of creating a variable that says, you know, calculate, etc., previously we had the percentage and then that percentage equaled the calculation, but I can actually go do max attempts minus total attempts. And now what the return is going to do is it's going to return the calculation for me. I don't have to assign it to a new variable. So this specific function is now just going to run that calculation for me, and it's going to return that data. Now, what we're going to do is we're going to create something called remaining attempts, right? And remaining attempts is going to be the remaining login attempts function, and then we supply the values to this thing. So in this particular case, let's say your maximum attempts is 3, your total attempts is 2, and you can now calculate that because this is just going to make that calculation for us and it's going to return that data to us. And now what we can do is we can create our if statement that says, hey, if the remaining attempts are, let's say, less than or equal to 0, then you can print account locked, and that's it. Else print access granted. Very simple, right? That's our script. We run it. It says access granted because what? It processed that calculation for us, and it says, hey, your max attempts is 3, your total attempts was 2, so the value of that is what? 1. And so if the remaining attempt is less than or equal to 0, then, I mean, I guess it could technically be negative, but if it's less than or equal to 0, print account locked, otherwise allow them access. If I change this to 3, it is going to be less than or equal to 0, and now the account has been locked. So this is how we return data. We previously created a new variable where it was remaining, I guess could be that, and then the remaining could be max attempts minus total attempts. That could be it. And then I could return remaining. I could technically do that like that. Or I could just say return the calculation the way that we just had it right now. And if we just run this, it'll do the same exact thing, right? So that's basically how you process data inside of a function, return the data so that you can reuse it outside of the function for the rest of your script. All right, so it is important to go over a handful of the built-in functions that come with Python because we are going to be using them later on and as we create more scripts. And I just want you to know what these things are, how to use them, so that later on you're not kind of blindsided as we go through this thing. I do recommend that you check out pretty much every other built-in function as well if you're interested in learning Python. If you just want to use Python for cybersecurity and for security analysis, things like that, these specific built-in functions should be good enough for you so that you can use them and do what you will with them. The first one that we're going to be talking about again is print, right? So print is the specific function, and we use this probably the most often, especially in this particular video series. We've used print the most out of everything else that we've done. And print gets an input, so every single function has some kind of an input, and then it gives you an output. In this particular case, we've established two different types of inputs for print. We have the regular input, which is just the string, right? This is a string. And then we're going to say this right here, where you can now do separated by a comma and do an integer as the input, and you can say is a number, right? So that is one type of input into print. There's another one, which is the formatted version of this thing, and hopefully it'll work actually with an integer. I've never tried it as an integer, so let's see. This is a string, but all right, let's see if that actually works. I've never tried it with an integer specifically inside of print. I've only used variables as the formatted inputs. So if we run, oh, it works. It works even with integers. So essentially a formatted string allows you to put any other type of data inside of that print function, and it'll still process it as if it was a part of that string. So we can input integers into it, we can input floats into it, we can input a lot of other data types that we've discussed previously, and then it'll output for us onto the screen the combined version of that without any of the extra commas or any of that sort. So these are the inputs that go into print, and then we have the outputs that come out of print. Now the next function that I want to talk to you about is the type function. And we kind of discussed this a little bit as well. I think we actually used it one time earlier in this. So print type, so you do that, and then you put another parentheses, and then you do security. So you have to put whatever the value is that you want the type for inside of parentheses as well. And then we're just going to do print type, and then just do, I don't know, 732.5, whatever. So you want the type of this data, and then you also want the type of this data. And what you can do with this particular function is that if you're going through log files, or if you're going through any other type of file and you're processing the information inside of that file, but you don't know what kind of information is going to be given back to you, you can use the type function so you can see what type of information. So I'm going to run this just so you can see. The first one is a class of string. The second one is a class of float, and we've already discussed this. So if it has decimal points, it's a float. If it's just basically inside of these quotations, it's considered a string, and anything inside of these quotations would be considered a string. So if I did the same exact thing inside of this quotation and written it out, it would still give me string because it's inside of these quotations. So anything that's inside of a quotation is going to be considered a string. Anything that has a decimal point is considered a float. If we remove the decimal point, it's going to be an integer, as you can tell from here. And really any other type of information. So I could technically even do this. So it should just say that this is now a Boolean. There you go. So the type function will just give you the type of data that you're looking at and you're processing with. Now, this is actually useful when you don't know the type of data that's going to be output from another part of your function or another part of your script, right? So this is how you verify the type of data that you're using, and then once you understand the type of data that you're using, you can then further manipulate and use the data accordingly. Another built-in function that is fairly useful is the max function. So we're going to assign 3 different variables right now. So we'll have A, B, and then C is going to be 5. And so what we want to do is we just want to get the max of that. And so you still do need to provide arguments to this. If I run this without any kind of arguments, it's going to say, hey, you didn't provide me any arguments. So I'm going to do A, B, C. I'm going to run it, and now it's going to give me the maximum value out of all of these variables. And it could be, I mean, very many variables, and you can feed those variables inside of a list, and then you can use that to give you the maximum value out of that. But it's essentially, as the name implies, it gives you the maximum value, the highest value inside of this entire thing. Conversely, there is something called the min value, which is going to give you the minimum value out of all these variables. So then it would give you the lowest value inside of this entire set of data that we have over here. Another really useful function is the sorted function, and as the name implies, it's going to sort through data for you, and it typically works with lists. So let's say we have a list of usernames. And now we want to sort these usernames for whatever reason. So you will print the sorted version of usernames. That's basically how you call on that function, and voila, you get the alphabetically sorted version of these usernames. These are actually very useful. Believe it or not, you're going to end up using these in the future as well. You just need to know how to call on these things, and typically it's as simple as using the print command and then using sorted and then another set of parentheses, and then inside of that you would put that information. And you could literally do this where you just copy and paste that inside of the sorted portion right here, and it would hopefully, I would say, it would give you the same information, but it's now going to. And so now what we're going to do is we're going to combine some of the stuff that we just went over with these built-in functions to do a few exercises just so you can really get it ingrained in your head. So we have failed login, and then it's going to give us a list. So here's the list of the failed login that I have over here. And I don't like typing lists, so I do copy paste with a lot of these things. So that's the list of the failed logins that I have over here. And then what I want to do, for whatever reason, is I want to go ahead and sort these. Now, it's useful because this actually works with IP addresses when you're trying to sort IP addresses, just so you can parse through them easier, or if you want to visually analyze them and there's a long list of IP addresses, you can sort them in ascending order, and that way you'll be able to then look through them easier, right? So very similar to what we just did is we're going to do sorted, and then right here we're just going to say failed login, and then we're going to run this bad boy, and then it's going to print all of this data for us sorted in ascending order. So sorted actually works with numbers as well as string values that need to be ascended or alphabetized in. My accent kicks in every once in a while. It's going to be alphabetized for us in ascending order. That's what sorted does for you. I can, of course, just use the max function as well to bring the highest value of these items. I can do the min function to bring the lowest value of these items. It's very, very interchangeable, very practical, and believe it or not, it's actually very useful. So let's now create a little function that will end up doing some of these things for us. Alright, so we are going to combine everything that we have learned so far to create a mini algorithm, and this is going to help us analyze the logins of a user and tell us whether or not everything is all good. So obviously we need to start with defining our function. So it's going to be define def analyze logins, and we're going to pass in several parameters into our function. It's going to be the username, there's going to be the current logins, and then there's going to be the average logins. Okay, so these are the three parameters that are going to be fed into our function. So the first and foremost, the thing that we're going to do is we're going to print onto the screen that the current day login, and I want to do this as a formatted string, the current day login for our username is, and then we're going to feed the other value into it, is going to be current logins. Okay, that is the first portion of this. Now what we're going to do is we're going to continue building our function out because it needs to do a lot more things for us. So first we say that this is their current login total for this particular username. Then we're going to print onto the screen that their average, so this is data that the system has pulled for us already. And you can, again, the average logins could be something that has been calculated previously that we're now feeding into the analyze logins function. But we're just assuming that we have this data already. So this is how we're kind of working with this. So first we said that this is their current day login, and then the average logins per day for this username is, and then we're going to use average logins, right? So this is our two print functions that are going to give us some data about the current user that we're working with. And just so kind of we have a little bit of an understanding, because this is going to get a little bit longer and I want to get better at using these comments to kind of help everything. So we're going to add a couple of comments so that we know what we're doing as we go along with our function. All right, so here are our couple of comments here. The first one is describing this, that we're going to display a message about how many login attempts that they made that day. This is the average number of login attempts that they made that day. All right, so now we got that. So next thing that we want to do is we want to now calculate a ratio, because we're going to use that data for the latter part of our script. So the next piece that we want to do is calculate the ratio. There we go. And I'm really horrible at spelling today. So there is our comment describing what the next piece of this is going to be, which is going to create our login ratio. And login ratio, you should be familiar with this, is going to be our current logins divided by our average logins. That's how we create our login ratio. Now our login ratio needs to be returned, right? So return the ratio, and that's as simple as return login ratio. So far so good. And you can see that it now created a brand new line for us, because Python in the IDE and PyCharm, it knows that when you use return, that means you're pretty much done with creating your function. And we are. So now what we're going to do is we're going to create a global variable outside of our function that is going to be our login analysis function, or excuse me, our login analysis variable. And that is going to equal the returned value of our analyze logins function. So we're going to say analyze logins, and now we have to give it the arguments. The first argument is going to be the user, so it's going to be E. Jones in this case. Their current login number is 9, and their average login number is 3. So their current login attempts is 9, their average login attempts is 3. And now we have the login analysis variable. So now what we can do is we can create a new piece of this, which is going to be our if statement that is going to compare certain pieces of information and do certain things for us, right? So we're going to say if login analysis is greater than or equal to 3, then I want you to print that, hey, there's a problem going on. Alert, this account has more login activity than normal. There we go. So now we have a fairly complex, sophisticated script that we've created. Just to review what's going on, right? So we have the initial function that has 3 parameters fed into it. And these parameters are the username, the current logins, and the average logins. Most likely, these will be pulled from another file. So this could actually be your authentication log, for example, or it could be just another CSV file that has all this information. And now you want to analyze the data inside of that CSV file to do a little bit of security analysis, right? And you can say, okay, let me see if everything's all good with our company. And so you have these 3 different fields that you've assigned as your parameters for your function. And the function is going to first display the message about the login attempts they made that day. Then they're going to display a message about the average number of login attempts that they made that day. And then what they're going to do is it's going to create a new variable that will have the login ratio of those 2 numbers. It has the login ratio of your current logins divided by the average logins. And then it's going to return that data to us. After that, we have a global variable that's being created that's going to call on the analyze logins function, and it's going to feed it these 3 arguments. So it's going to be eJones, 9, and 3. And then if the login analysis, so if that returned data from our login ratio function, if that is greater than 3, then we need to be on alert. So let's run this and see if it works. And it does. So it says the current day login for eJones is 9. The average logins per day for eJones is 3. Alert, this account has more login activity than normal. And this could be as little as 4. And you can say, oh no, average logins per day is 3. If login is greater than or equal to 3, then it should be printed. Oh, it's actually interesting. It didn't work. I wonder why it didn't work. Oh, because you know what? It's the divisible number. So it's the ratio, excuse me. So if it's greater than 3, it's the divisible number. So if it's 4, then everything's all good. And I should be doing an else statement just so I understand what's going on. Print login activity is normal, right? Boom. There we go. Login activity is normal. Now I understand what's going on, right? So this is the script right here. And what it's doing is it's dividing the 4 by the 3 to see if that number, if the result of that is greater than 3. So obviously 4 divided by 3 is not going to be greater than 3. Anything higher than 9 will be greater than 3. So 10 divided by 3, hey, it's greater than 3. This account has more login activity than normal, and this is what we need to go and address. So this is our basic function. And this is now stepping into the realm of creating algorithms, right? So you created their original function. That original function is now processing some data for you, and then that data is being returned so that it can be reused later on inside of another variable. And then you can do a comparative statement where you say, if the value of this is greater than or equal to what I think it should be, I want you to do this. Otherwise, I want you to say everything's all good. And that's exactly what happened. So we have combined several functions, and we brought all of those things together to now create a very functional script, no pun intended. We've combined these functions to create something that's actually very useful to us. And you can use something like this, or at least a version of this, in your career as a cybersecurity analyst. And you can, I would recommend you kind of test it out and try to learn how to do something like this, even just for yourself. We're going to, in a little bit, we're going to go over how to pull data from files. And then we're going to combine that with all of these things that you're learning here, and you will be fully functional, where you can now pull data from a file, analyze that data, parse through that data, and then create some kind of a latter part of your script that will do a certain activity for you, take certain actions for you, so on and so forth. But that is pretty much it, what we got for functions. It should be I think it's fairly comprehensive. It's obviously not everything, but I think that's more than enough to be useful to us as we continue with the rest of our series and as you learn more with the various tools and resources that we're going to be using in a little bit. Okay, now we got to go through a few things for strings and lists, and these are various functions and actions that we can take with these data types that are going to be important for us as we go into building our algorithms and pulling regular expressions and then starting to work with files and ultimately building our parsing algorithms. So the first thing is that we want to do, or at least take a few key actions or learn how to take these actions specifically with strings. The first thing that we want to learn how to do is how to convert an integer into a string. There are going to be a lot of times where you're going to need to work with numbers and need to process numbers, but you won't be able to use certain functions with integers. You'll only be able to use those functions with string types. So as we go through this, we're going to first demonstrate what an integer type is, again, just so you can see what that is. So if I run this, you'll see that the class for this specific piece right here is indeed integer. Now what we're going to do is we're going to create a string in this case, and we're going to just put that same thing inside of this function called string. So str stands for string. And then I'm going to go ahead and print the type for string, and then we'll see that that one is actually a class of string. So to convert any numerical data type, which would be an integer in this particular case, it could also be a float. You could turn a float into a string, and I wanna make sure that I'm actually doing or using my data types correctly. So just in case, I just want to write that. Yeah, so it is a float. When you put a decimal point, it's technically a float. So to convert a float into a string, you would use the string function, and essentially any other data type, technically you could just use the string function and turn it into a string. Now the next thing that we want to do is we want to print the length of a string, and this will also be useful as you go into developing algorithms. You'll need to, at the very least, learn the index positions of something and be able to print the length of something. And I'll discuss the index positions in a little bit as well, because they're very important. So we're going to print the length of something. So first we're going to just do this. This is very simple. You could do print length and then just put the string inside of it. So hello could be your string in this case. And then because you're using the length function, it's just going to count the length of the actual word, which in this case is 5 letters. So you have 5 as the length, and however long this would be, it'll just go ahead and count that for you. And it's very important to note that it also counts spaces. When you use the length function, it will also count spaces of something. So if you want a specific character count, technically the space character is also a character in this particular case, and it does contribute to the length of it. So if we were to, usually when I create YouTube titles for videos, I want to try to keep it lower, less than 50 characters. And so I have to also consider the space as one of those characters that is going to take up my 50 positions. So this is how we print the length of a string. And now what we can do is we can try to mess with concatenation. And we kind of did this a little bit earlier as we were trying to put together, or we were trying to convert a list into a string, and then we tried to combine it together. But a very simple way that you can do this is by simply using the plus symbol, the plus mathematical operator. Concatenation is essentially just a fancy way of saying combining, so joining two things together. So it's not that complicated to literally just say, hey, we want to print hello plus world, and then now you've technically concatenated that and you've printed those things together. Notice that there is no space in between them. If you wanted to actually add a space, you would need to do a space inside of quotes and then do a plus and then run that again, and now we have a space between them. But you can do this with a variety of different things. You can concatenate the outputs of certain functions simply by just using the plus symbol. And we did this several times earlier, but I just wanted to dedicate a specific description or a section to it, because I think it's very important to know exactly, I guess, what the term is for this, because concatenating something is very, very important, and you're going to end up using it, especially in the future. Now, this next function, as well as the function after this, is actually very important because we use this in password operations. Maybe not the upper function, but specifically the lower function is going to be used in password operations, or maybe processing of data that's being input into a form for case sensitivity. And there's several other functions that are similar to this as well. One of them is called title, that will capitalize the first letter of every word. But essentially, as you probably can guess, when we do upper, and this is not the way that we did before where you would do the function before the actual string inside of values. This is something that is added to the end of the string by doing dot upper, and then you would put the parentheses at the end of that. And this is how we would print hello as all caps lock or all uppercase letters. And then obviously, as you can guess, if I just wanted to just switch this to lower, I would go ahead and change this to lower, and it would take that whole thing and do it as lowercase letters. And just for the hell of it, we could just say applying the title to this, and you do that and you run it, and it would just capitalize the first letter. But it's more effective if we use all lowercase and if it's a longer string. So we can say, there we go, and then you just run that, and now you can see that the first letter of each word is now capitalized, and that's what we call the title function. So it's actually very useful if you're trying to make something look really fancy or look pretty. You would just use the title function and you would add that to your string, and it doesn't matter if this was all caps lock, if it was all lowercase, doesn't really matter. It'll just change that into a title function for you so that it looks really nice when somebody's reading it. Okay, so now what we're going to talk about is something called the index value, or the index position of something, as well as a slice of something. So this is, again, these are going to be concepts that we're going to be using as we develop more advanced scripts. And they're basic concepts, but they're very, very powerful concepts. And I mentioned this earlier in the video as well when we were talking about lists and how you can have list versus tuples, and lists can be mutable and tuples are immutable. This is where that concept comes in. We haven't gotten to the list yet, so I'm kind of getting a little bit ahead of myself. But the index portion of this is where you can mutate a list, or you can change elements of a list. And very similar to what we can do as we manipulate strings as well. So first we need to understand how this actually works. So if I went to do hello, and then I have this piece right here, and I put it inside of brackets. In this particular case, we are referring to position 1 of the word hello. Now, what is important to understand is that with indexes or indices, the positions don't start at 1. It actually starts at 0. So let me just actually demonstrate this, so just to make it a little bit simpler to understand. So if I just did print hello and then at position 1, you'll notice that it prints the letter E, because this, the H, is starting at the 0 position, then it goes 1, then 2, then 3, then 4. So this is very important to understand when you're dealing with indices, and you're going to deal with this a lot. I'm going to assume that you're going to deal with this a lot because it does tend to come up very frequently. It is a very basic concept, but it's a frequently used concept, and it's a concept that's referred to very frequently as well. So looking at the index position of something is very, very important. And I really want to jump ahead and show you this with lists, because it's really powerful with lists, but it's just the same concept. You're only dealing with lists at that point. So printing position 1 of the hello word would technically give us the letter E. Now this is where slices come in as well. And slices are essentially just, as the term kind of implies, it's a slice of the string. It's a portion of the string. And the way that that works is also very similar to this. It's actually pretty easy to wrap your head around, except instead of just using one digit to allocate something, we can just put a colon, refer to the next position that we want, and it will now take everything from position 1, including position 1, to position 4, including position 4. So if we run this, the first piece, because we were just taking position 1, is going to be that E. The next one is going to take E, L, L, because this is 1, 2, 3 or excuse me, it doesn't include position number 4. So I stand corrected. My apologies. So it does not include position number 4, because technically position number 4 would be the O, the letter O. So it takes everything from 1 to 3. It includes the first position, second, and third, and it stops before it gets to the fourth position. If I wanted to get everything, I would just do 1 to 5 like that, and I would get allow. And then if I could just do this, if I just leave that blank as well, it will also give me a low. So it will just go to the end of the string. So if this was a longer string, then it would give me the entire string. If I didn't know what the last, the position of the last letter is, I can just leave this part blank, and I say I want from position 1 all the way to the end of this thing, and it will give me that entirety as well. And the opposite of this is also true. If I leave this blank and I go to position number 8 and I print this, it will give me everything from that very first position, which is technically 0. It'll give me everything from 0 all the way to position number 8, which is in this case the letter H in the word there. So this is, as we've established, these are 5 letters, 6, 7, and then we have 8 right here. But what if we don't know and we want to find out what the position number of a specific item or specific letter is? So the way that we would do this is, again, we can just use our print function just to understand it. We would print hello there, and then what we're going to do in this case is we're going to do dot index, and we're going to refer to the index function. And in this case, I'm just going to go put inside of the parentheses what I'm looking for. So let's say I am looking for the letter L, and I'm going to print that, and it's going to say that it's in position 2, because this is 0, this is 1, and this is 2. Now what's important to understand here is that it's going to give you the first instance of that letter. It's not going to give me the one in the third position. So anytime that you look for anything in particular, it's going to give you the first position that it shows up at. So if we did the letter E, for instance, it would give me position number 1 because it shows up at position number 1. If I did the letter T, it will give me position number 6 because that is where it starts at. And this is, again, very important to understand. If you did not know where the specific position of something is and you want to find out where the position of that is, you would simply use the index function and then put the letter in there, and it would show it to you. Once we get to lists, again, same thing. It works in a very, very similar concept, except you're not looking for letters at that point. You're actually looking for the items inside of that list. Now, as we've referred to these words several times already, strings are immutable, meaning they cannot be changed. So if I wanted to take the position of, or the letter, we should say it like this, right? So if I can, I'll go ahead and completely change this piece right here. So if we went and created one variable and we call that hello, and then we go create another variable where we take the first position of this, right? So my string at the index position of 1, and this is how you refer to anything inside of a variable for that index position. You just put it inside of those square brackets without any dots or anything like that. And then you say that you want that specific thing to be A. So we want to replace E with A. So if we went and ran this, we would get an error, and we did get an error, and it says, hey, this is a type error, it's a string object, and string objects do not support item assignment, meaning an item inside of a list, which is what we're referring to technically. That's what we're referring to, is we're taking that index value of this thing. It's saying that that item is not mutable. You cannot change that. This is an immutable data type, and strings are like that. You cannot support item assignment, meaning take any individual position of this and reassign it with something else. You can't do that. So strings are immutable, and it's important to understand this because as we go on, we will find mutable data types. Okay, so now we are going to look at the backwards counting of an index position. So this is, again, something that's very important to understand. So let's say we have our string, which is hello world. And what we're going to do with this is we want to work backwards. We don't know exactly how many characters, for example, there are, but we know that we want the second to last item in this, for example. So this could be a list again as well, but in this particular case, we're working with the string. So we want to print the string, And then what we want to do is we want the last position. So if we wanted the last position, instead of working with 0, because you can't have a -0, so you can only start at -1. So -1 in this particular case will bring us the very last letter, which is the letter D. If I wanted the second to last position, I would just use number 2, which would give me letter L, etc. and etc. And so this works also as well with lists, but this is how you work backwards within the indices inside of either strings or lists. Okay, so this is our practice algorithm or function. It's super basic. I don't even know if this can be considered an algorithm, but this is a demonstration just to show you what the behind the scenes of a password length parameter really looks like. So let's say that I have a new variable called password, and this is my password technically. And then the length of my password is going to use the length function, len, for that variable, which is the password variable here. And we created an if-else statement where it says if the password length is less than or equal to 5 characters, then you're going to print that your password is too short, try a longer password. Otherwise, print that your password has been changed. So if I change this to pass in this case and run this, it'll say your password is too short and try it again. If I leave it as password, it will say that what? That your password has been changed. And there are ways that we can use a lot of various functions as well to make sure that there are alphanumeric characters in here. There are at least 1 numeric characters, for example. I'm not going to go into that because that's beyond the scope of what we're trying to accomplish with strings specifically. I just wanted to show you how you can create a basic little function that says, hey, you know what? We're going to check the length of a string, and then if the length of this string is beyond what we wanted it to be, or if it's shorter than what we want it to be, then we want it to print that, hey, you know, this is what we want you to do. If it's not, I want you to print this other thing. You can do a variety of things where you just count the length of something and then you print something or you take another action. This is just a very, very simple demonstration of how you can take the length of a variable, which is in this case a string type, and then you can try to use the value of that length to do something else inside of your script. Now what we're going to look at is how to find a substring inside of a string. And a substring, as the name implies, is essentially a smaller string or another string inside of a longer string. And a lot of times you're going to want to do something like this as well. So let's say that we want to find Hank inside of this long string. Okay, so this is what it would look like. Okay, so that's our specific string because it's all inside of those quotations. So that whole thing is one string. Now I want to do is I want to find Hank inside of this entire string. So I can simply just do dot index. And previously we were just looking for the index value of a single letter, but in this case I can look for the index value of an entire word, and I can just type in Hank in there. And then we're going to just go ahead and go down here and print the Hank index, because this whole thing, this entire variable, is actually taking this string and looking for the index value of Hank within that entire string. So now I'm going to print that variable and we should get the position of it. So let's see what that looks like. It's going to say 23. So this is what's important to understand. It's telling you that it's technically in the 23rd position. That's where it starts, right? So if we counted 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 is where Hank starts. So this is very useful when you're trying to find something inside of a long block. I mean, if it's a really, really big block of text, it can be kind of daunting to try to find the 23rd position or the 230th position inside of a long block of text. But at the very least, it can show you whether or not it exists. And if it gives you the position of it, then you know that it does exist inside of that long string, and then from there you can just kind of do a little bit of manual labor, so to speak, and try to find where that positioning starts. Okay, now what I want to do is I want to use everything that we just discussed right now and create a variety of functions and a variety of short little scripts so we can combine everything that we've done to create some real life case scenarios that you would write some scripts to verify certain data types and to work with certain string data and measure them and essentially further manipulate them and further work with them. So the first thing that we want to do is we want to just work with data types in general. So using the string type and the integer type just to see how it works within variables and certain portions of functions. So first what I'm going to do is I'm just going to write the whole thing and then I'll describe what I've just written out. Okay, so here we go. We got a very, very basic series of actions that we're taking. First and foremost, we're assigning employee ID a value that is an obvious integer. So it's just 4 numbers. Then we're going to print that type. So we're going to print the type of this specific variable, which is going to be this instance of the variables. And then we're going to reassign that same exact variable, but we're going to convert it into a string now because we're using this string function at the beginning. And then we're just going to print the type again and see what happens. So as we print it out, obviously you see that the first one is an integer because it is obviously an integer. And the second one, because it's a string, it has now been converted to a string. Or because we use the string function, it's now been converted into a string. So this is how it works when you're using various functions to convert data types. And as we previously, what we did is we immediately applied it to an actual string. But in this particular case, we're applying the string type or this string conversion function to a variable, and it still works exactly the same way that we want it. So very, very basic, and that is the first example of what we're going to be doing with data types and strings and just kind of manipulating data types to become a string in this particular case. So let's move on to the next one, and this one's going to be a little bit more complicated. Okay, so there you go. Very, very basic. And as you can kind of tell from the comments, I'm getting a little bit better at using comments more frequently. As you can tell from our comments, we have created our employee ID. We have converted the employee ID into a string value. And in our conditional statement here, we're saying if the length of the employee ID is less than 5 characters, then you want to print that this has less than 5 digits, right? And so it does obviously print that it has less than 5 digits because it only has 4 digits. So if I added 2 pieces to it, it's going to print or it's going to process without any kind of error messages, meaning that it actually processed correctly. So if it has an exit code 0, that means it processed correctly. But if we wanted to just confirm that this was indeed the case, we can say successful, and that's pretty much all you need. And there you go. So I even misspelled successful. So that is our, for like, you know, a little bit more of a complex thing, but again, it's not that complicated. When you kind of wrap your head around these concepts, you can see how quickly they can just be stacked on top of each other and how easily you can start building something that is very functional and it can serve a lot of different purposes for you. So now what we're going to do is we're going to kind of elaborate on this a little bit, and we're going to extrapolate this specific code and just play around with it some more. So let me make a couple of more modifications here. Okay, so this is the new code now, and I think by now you'll probably notice some of these edits that we're making and what we've done here. So the first portion is exactly the same as we had before, and we have the employee ID, and then we've converted the employee ID to a string. Now, the reason why this is actually important is because later on, so first, and then we're going to print the employee ID, and then later on we're going to check the length of the ID, and if it's less than 5 digits, then it's going to concatenate the letter E plus the employee ID. And the reason why this is important, I think it would have worked either way. I think it would have worked whether or not this was a string, but sometimes maybe it doesn't. So what we've done is we've made it so that we can take this string value. So this is originally an integer. It's been converted to a string. And then now we're concatenating the letter E, probably for employee, along with that employee ID. If the employee ID is less than 5 characters, and then you just print the new employee ID. If it's not, then this is not going to work in any case, and then it should print the original employee ID. So let's run this, and then we'll see that we have the original employee ID 3656, and since it was less than 5 characters long, it's now going to add that E in front of it to actually make it 5 characters long. So if I went over here and added another number at the end of it, and if we just printed, it should just print the exact same ID, right? So this specific thing doesn't work anymore because of the fact that the original employee ID was actually 5 characters long, so it didn't add the E in front of it. And this is how we make sure that if something is supposed to be a certain number, you can just concatenate it. You can actually add something to it. And then there's something called the random library, where you can just import the random library. And then instead of choosing the letter at the beginning, you can just say, hey, I want you to pick something randomly, and then concatenate that to the front of this specific employee ID. And that one, I'm just not going to cover it right now. You can definitely check into it if you wanted to, and we will just move on to the next piece, because I do have several other examples that I want to share with you for specifically manipulating strings that I think are important before we move on to the rest of the stuff, and then it serves useful for everything else that we're trying to do in this video. So that was it for concatenating a specific letter at the beginning of the employee ID, but very similar to the previous function that we had, where it was just measuring the length of the employee ID. Okay, so now what I want to do is I want to combine what we learned earlier with indices, and we're going to use it in the case of working with a URL. And we're going to combine a lot of the things that we've learned so far with the indices to get an ultimate result. And then you'll kind of see the use case for this as well as we start stacking it out and building it out. So first and foremost, okay, so very basic script. We have a variable that has a URL that's been assigned to it. And what we want to do is we just want to extract the protocol of the URL and print it onto the screen. And the way that we're going to do that is we're going to use the index position of the URL from the very first position, which starts at position 0. And it's going to go until the 8th position, which would actually be that second // So if I run this, it should give me https ://. So this is the first level of this, the first layer of this. Okay, now what we can do is we can create we can now pull the specific position of another portion of the URL, and we're just going to keep messing around with this URL variable that we've created. So now instead of extracting the protocol of the URL, what we're going to do is we're going to display the index where the .com is located. And as you probably remember, we're just going to do .index in this case, and then we're going to put in a string .com. So we just want to see where this starts. At what position does this start? So when we run this, it says that it starts at the 19th position. So now that we have this, what we're going to do is we're going to extrapolate on this. So the very first thing that we're going to do is we're going to create a new variable called index, or ind at least, and then it's going to be the index position of .com that we just pulled. So now we actually have this value, this 19th position, stored inside of a variable. And now that we actually have this 19th position stored inside of a variable, what we can do is we can now manipulate that specific index position. So it'll be like this. So we'll still have the URL variable, But now inside of these square brackets, instead of putting a number, because we don't technically know, for example, we wouldn't know where that number is, we're just storing, because at any point, because of the length of the URL, this index position could be different, right? It could be 25 or it could be 15, whatever it is. So what we're going to do is we're going to do as the first part of our index, as the starting point of the index, we're going to use the actual IND variable, and then we're going to put the colon, and we're going to do IND plus 4. So now for the most part, most extensions of domain names are going to be at least 4 characters long, including the dot. So it would be a .com, that would be 4 characters long, .org would be 4 characters long. So now we know that it's going to pull that position for us, and it's going to give us that actual value, right? So the first one, so if I went and just did this in this case, just to kind of give you a little bit of an example, if I did print IND in this case and we ran this, it would give us the 19th position. If I did example URL, whatever it is, it's going to run it again, and it's going to give us the 22nd position, because now we added a few characters extra to this. And if I removed a lot of these things and we ran that, it's going to give us the 17th position. But it doesn't matter what that position is, because the first thing that we did was we created this variable where it points to the index position of wherever .com starts from, and then it's going to print that for us just to let us know where it is, and then it would print the rest of the domain name, assuming in this case obviously it's going to say this is the .com that you're actually looking for, so obviously it would print .com. But if we wanted to extrapolate this further and use the regex library, we would be able to create something similar to this, where it would be, if you know anything about regular expressions, this is not supposed to be a regular expressions education. So, but if you did this, you would technically say that I want to have the dot be present, and then anything after the dot I want to show to me, or I could just do dot along with the plus sign, and in either case it would pull whether or not it's .org, it would put .edu, .com, .net, it would pull whatever it is for us, because we're putting a regular expression pattern in there instead of putting the literal letters, and then it would still pull that information for us. And sometimes you would need to do something like that in order to pull it off, because you don't exactly know what you're looking for, but you know that it would look like a certain pattern. And so if you have that pattern, you can go ahead and pull that information and display it, or do something else with it. So another version of this would be that we can now, instead of pulling from the beginning index, which is where that position is right here, right? So from the 17th position, technically, from going from the 17th position to the remainder of that, we can now do the opposite of this, where we can do, you have the ending position being the 17th piece right here, and then prior to that, you can now say the 8th position, because we established earlier that everything after, or from 0 to 8 would be the HTTPS all the way up to the /. So from the 8th position, which would be, this is where the E would start, all the way to wherever that 17th position is, I want you to print that portion of the URL, which would actually be the URL in this particular case, which is example UR. So if I did URL all of this, it should print the full URL for me, right? So this is how you work with creating the variable for the index position of where you want it to be, and then you can use that as a starting point or an ending point when you want to print the rest of the data. And that's pretty much it for our manipulation and working with strings specifically. So now what we can do is we can move forward and start working with lists. All right, so from what you remember earlier, this is what a list looks like. It's essentially any kind of data separated by commas sitting inside of these square brackets. Now, what we can do is we can extract from a list, very similar to what we did with extracting from a string, except now it would actually pull that entire portion inside of these commas, because this would be position 0, this is position 1, position 2, etc. So instead of pulling just a single letter, and I mean in this particular case it is technically a single letter, so we can just do something like this. where we have multiple letters, just to kind of prove the point here. So instead of pulling a single letter like it did from a string, it's going to pull the entire item inside of that position. So for example, it would be print, and then same thing, my list, so that part is going to be the same, and then it's still going to be a square bracket, and then now we're going to pull everything from position 1, which is in this particular case BC, right? So it's not pulling any individual letter, it's actually pulling the entire item that's sitting inside of this. Now if I had certain numbers here and I wanted to pull that, it would pull all of the numbers inside of that position. So this is the beautiful thing about creating lists, working and then trying to pull information from those lists. And very similar to what we did when we concatenated two strings together, you can actually concatenate two lists together, and it would literally be done in the same exact manner. So you would do print, and then you would do my list plus numbers list, right? And then you just run that, and that prints both of the lists together all inside of one large item, and it will give you the A, B, B, C, da, 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 and then it give you 1, 2, 3, 4. It's concatenated the two lists together. And sometimes, or actually, honestly, I think a lot of times, especially with data science and data processing, you need to combine data. And what you can do is you can just use something as similar as concatenating to essentially do a kind of like a glorified copy paste type of a function. So very, very, very useful to be able to do this. And very similar to what we did with the string, or actually what we established when we were running the string, was that strings are immutable, right? So you can't change individual letters inside of a string. But what you can do with lists is you can change whatever you want in that particular position, and they make them mutable. So lists are mutable, strings are immutable, tuples are immutable. So if this entire thing was sitting inside of parentheses, then I would not be able to change any of those elements. But what I can do in this particular case, now I can say my list, right, position 1, instead of being BC, is now going to be 546. And then what I'm going to do is I'm going to print my list. And what I'm going to actually do, just to kind of show you the difference real quick, is that we're just going to print my list at the very beginning as well, just so we can see both versions of this. And then you can see that you have ABBC, which is exactly what this was. And then what we did was we changed the position 1 into 546, and then we printed the same exact list again. And now it's changed that position for us. So lists are mutable. That means you can change any item inside of a list. Another way that we can do this is we can use the insert function to add whatever we want into the list. So instead of saying my list equals, or my list, position 1 equals, so actually let me back that up just so you can see what this looks like. So instead of saying my list position 1 equals, I could do my list insert, and then with functions we would use parentheses in this case, and then we would say in position 1 I want to have 3215, for example. So I've technically declared position 1 to be 546, and then I redid my insert command, and now in position 1 I did 3215. So when we run this, it should actually say 3215 and then 546 as well. And what it's doing in this particular case is that instead of replacing the previous item, so when you do index 1 546, it's actually replacing BC. But when we do insert, it doesn't replace it. It just puts something in position 1 in that case, and then it elongates your list. So it actually adds to it instead of replacing the previous item. And this is actually very useful because sometimes you don't want to replace what was already in the list. You just want to add something to that list and keep the original data inside of the list as well. So now let's say we want to remove something from the list. So I can just do mylist.remove. And now in this case, instead of using any kind of an index position, I would just say what I want to remove from that. So for example, let's say I want to remove CD from the list, and I'm going to finish this, and then I'm going to go ahead and print my list one more time. And then so now we should have 3 different versions of this, and you can see this is the original version, this is the version where we added and inserted an item into it, and then this is the version where we removed CD from it, and this would be the final version of the list, and it still kept all of the original data that we added to it. Remove is kind of one of those things that you don't have to worry about replacing data or anything like that, because you're specifically pulling an item from that list and then just removing it from that list. All right, so now what we're going to do is we're going to combine everything that we got, and we're going to write a very simple algorithm using everything that we've learned with list and string operations. Okay, so we have a list of IP addresses. Obviously, these are not real IP addresses, but this is our original list. So we have a list of IP addresses. Now what we want to do is we want to extract the first 3 letters of an IP address. So for example, we would say, so there we go. So we printed the first 3 positions, the first 3 digits of the IP address. Now, what we can do is we can extrapolate this a little bit further and kind of do multiple things with the current list of IP addresses that we got. So first, what we're going to do is this. Okay, so very simply, we created a new variable that is going to be an empty list because we have these 2 square brackets with nothing inside of them. And then we added a for loop that says for address in IP, which is this entire list that we have right here. So this could again be anything, right? It could be an X, it could be a slash, whatever. So for address in IP, networks is going to append, and this is a new function that we're introducing right now. The append method just adds something to a document or a list without rewriting it. So appending just adds information to any kind of data type or any kind of document without rewriting everything that's already sitting inside of that document. So in this particular case, the networks variable is empty, and it would add the first 3 digits of this, then it would add the first 3 digits of this, so on and so forth. And then what we're saying is that we want this to print networks onto the screen for us. So here's what this is going to look like. Now what we're going to do is we're going to combine everything. We're going to take everything that we've learned with string operations and list manipulation, list operations, to actually write this algorithm. And we're going to leave comments along the way because this is going to be a little bit more complex than usual, and it should be pretty exciting to pull off. So let's get started. All right, so first we have a list of approved users. That one is pretty simple and straightforward. And now we have a list of approved devices that will correspond to each of the usernames that we have in approved users. Okay, so in this particular case, this is just kind of the first marker of our script, and we have essentially just created 2 lists, and we are printing the second position, which is basically this one right here, and we are printing. I'm going to print just the first position just to kind of keep that as well. So in this particular case, we're just printing the first position of each of the lists onto the screen. So we have 2 lists, and now we have printed the first item of those 2 lists. So now let's move on and try to extrapolate on this a little bit. Okay, so now we have the several new elements that we've done over here, which is going to be, we added a couple of new variables here. So there's the variable for a new user, which is Hank Hackerson, a new device that's been assigned to Hank. And then we have the append function for each of these lists at the top right here, where we append the new user as well as the new device to those lists. And now we're just going to print those lists. And so I'm going to kind of just keep this a little bit just so they can be a little bit more organized, then we can see these things better. So these are our two lists. These are the two new variables that we're going to be appending to those lists, and then we're going to print those lists. So there we go. And then we have at the end right here, we've added Hank Hackerson here, and then we've added the device that belongs to Hank Hackerson. So far, so good. Okay, now we're going to essentially do something very similar, but except instead of adding or appending a user, we're going to remove the user and their device. So, we added a new employee technically, that was what we just did, and now somebody got fired or somebody left the department, and now we need to remove them from our two lists here. All right, there we go. So now we have these two new variables for people that we're going to remove and the device that we're going to remove. So what we're going to do, you probably have already guessed, is that we're just going to go with remove as our function. And from here, we're going to do removed user for removing from the approved users list. And then we're going to do as our function here, removed device, to remove the person's device from our list. And then we're going to now print these two lists, and there we go, we got them. So naturally the lists are going to be smaller because Hank Hackerson was never added to the list, and now we've removed B Moreno and B Moreno's device from the list. So it goes from E Larson to T Shaw, which is exactly what we see over here as well. And now we have this nifty little series of actions that we've taken. So now we're going to move on to the portion of this where it becomes kind of similar to an algorithm. This is where it becomes an algorithm writing game. And again, like once you kind of understand the basics of this, it's fairly simple, the things that we do. So let's do a kind of like a check algorithm. So this is the first piece that we're going to do. I'm going to remove this element, these pieces that we have here, and we're going to start writing some of the new code. Okay, so there we go. That's pretty much our algorithm. This is actually super simple when you kind of wrap your head around it. What we're checking in this particular case is there's a username variable that's been added, and that username is assigned the value of somebody that's currently inside of our approved users list. And the conditional statement here is checking to see if that username is actually inside of our list, approved users. Then we're going to print the username is approved to access the system, and obviously they would get access to the system following this event. If they're not in the approved users list, we're just going to say that they're not approved to access the system, and then their access has been denied. So I'll just do right here, cool little access granted, just to be a little fancy with it, and then we'll do an access denied portion right here as well. So we're going to run this. And of course, B Moreno is actually in our list, so they're going to be approved, and then they're going to have access granted. But let me see, Hank Hackerson. Let's see if Hank Hackerson is on our list. Oh, Hank Hackerson is not approved to access the system. So the access is denied to Hank Hackerson. So this is a very quick, this is honestly, it's actually very, very useful. You will probably do something similar to this, and we're going to create many more versions of these functionalities where you check for the existence of something inside of either a list or inside of a document, and then you extrapolate on what you would do if you found that or if you didn't find that, so on and so forth. So in this particular case, we just wanted to see if this person was indeed in the approved users list, and if they are, we'll grant them access. If not, they're denied access. Okay, so now let's try to see if we can find the devices that have been assigned to each of these individual users, because we're going to assume that we don't know what their actual device numbers are. So this is, again, very, very simple to do. And once you wrap your head around this stuff, you're like, oh, you know what, I kind of get this. So our username that's been assigned to our username variable is going to be B Moreno. And what we're going to do first and foremost is we're going to get the index value of where he is in our list. So very simple, approved users index, and then it's going to be username. So we're going to now get this index value and see what it actually is. And he is in the 1 position, which is technically the second on the list. So cool. So we know where B Moreno is. So now, how do we find out what device has been assigned to B Moreno? And it's actually very simple. So just from the comment, honestly, we can kind of understand that, oh, you know what? I think I know what we're supposed to do in this particular case. And we're just going to use the print function. But instead of pulling from the approved users, we're going to pull from approved devices. And then we're going to take the index position of that, and we're going to print that out. So the index value of B Moreno has been already established, which is going to be position number 1. And then in this case, we're just going to print that same exact position, but from this list, because that's going to be the device ID that's been assigned to position number 1, which is B Moreno in this particular case. So we run this and we print it, and lo and behold, B Moreno's device ID has been printed onto the screen. So very, very simple, but extremely powerful and very effective. So now that we know this information, let's see if there's something else that we can do to further complexity, that doesn't even make sense, to further extrapolate or build a more elaborate algorithm. That's probably a better sentence to use. Okay, so now that we know what his device ID is, let's see what else we can do with it. Okay, so just based on this comment again, we can see that if it says if, we know that we're going to build a conditional statement, and we're checking to see if the username actually belongs to our approved users list, and then the device ID that has been established here belongs to approved devices at this particular index, obviously. Once that is all good, then we're going to grant access to this person. So this is going to be, I mean, it's simple, but it's just a couple of extra steps really. So if username is an approved users and device ID equals approved devices at the index position, right? That's it. That's basically our entire condition. And then now we just know what's going on. So we're just going to print the access message. There we go. And you run that, and of course, this is all good. Now, we can, of course, just kind of make this a little bit good. So we can say either the username or the device ID is does not have access. Please verify. Because you don't want to give them too much information. This is one of those things that is done with web application testing as well, where you don't want to give too much information in your error message. You don't want to give it away. You don't want to say, oh, the username doesn't exist or the device ID isn't good. You simply say either the username or the password that we supplied is incorrect. You probably have run across a message like that if you entered your password or your email incorrectly when you're trying to log into something. It just says either of this information is incorrect, basically. If we wanted to kind of make this even a little bit fancier, we can do an elif statement in this particular case where it says if the username belongs to approved users, but the ID at end in approved devices, I am so bad at spelling today, does not match. So if that's the case, we're going to create an elif statement in this particular case where it says username in approved users. So that part's fine. And device ID is not, so does not equal, that's what that comparative operator that we got earlier. So the device ID does not equal to the device approved devices at the position of index. So that's our statement. That's our what do we call this? The if statement. I think conditional. There we go. My God, I literally just drew a blank. So that's our conditional statement. The first one is saying everything's all good. The username matches and the device ID is all good for that specific username, so it's all good. But in this particular case, we're saying the username does match, but the device ID is not included in that position. And if that's indeed the case, what we're going to do is we're going to print the statement here where it says the username, in this particular whoever it is approved to access the system, but device ID is not their device. There you go. Now you have that, right? So we can go ahead and run this and everything's going to be all good, but let me go ahead and just change the device ID for B Moreno to the device ID for E Larson. And it should say B Moreno is approved to access the system, but A is not their device ID. Oh, interesting. Okay, cool. So now we have our first elif kind of a statement. So what we're going to do now is we're going to kind of make this a little bit more official of a script, right? So this is going to be one of these things that now you want to start being a developer, like a proper developer. And you'll see how simple that's going to be in this process. All right, so first we're going to start by building a function. We're going to start a function which is called login in this particular case. Now we have a conditional statement that verifies whether or not the username is an approved user. So that's the first thing that we want to do, is we want our function to first check to see if the username actually belongs to the approved users list. Okay, cool. So we have that portion. If that is indeed the case, so if the username is actually in our approved users, now what we want to do is we want to assign that index value to the index of username. And if that is indeed the case, so if the username is inside of approved users, and we've already confirmed that, now we're going to assign an index position to the IND variable, and that index position is going to be directly related to whoever the username is, wherever they are in our list. And if that is indeed the case, so we've successfully verified that they're in our approved users list, we've printed this onto the screen, and now we have successfully established the index position of that user based on their position inside of our list. So now we've confirmed all of that information within our first if statement. Now we have another if statement. We have another conditional that's going to verify a second thing for us. So the first thing that we wanted to verify was whether or not the username was actually inside of approved users. Now the next thing that we want to do is we want to verify if the device ID that's at that index position, so the device ID that should be assigned to that user essentially, if that device ID actually exists at that index position, there we go. So we verified that if they actually are. So if that device actually does belong to that user. So if it matches that specific device at that index position, right? So let's say the username is at index 1. We've assigned that to our IND value or IND variable, excuse me. And now we're verifying that if the device ID is in the approved devices list at index 1, because that's the index for that username, then you're going to print that, hey, this device ID is the assigned device for this username. Now we have our else statement that says, hey, you know, this device does not belong to this person. So this is our function. Let me close this out so you can see it. This is our function so far. We have the first verification that says if the username if the username exists in approved users, we're going to print that this username is actually inside this list. Since we've confirmed that, now we're going to assign the index value of that user, wherever they are inside of our list. We're going to assign that position to the IND variable. And then, if the device ID in approved devices at that index position is actually the correct device ID, then we're going to print that this actual device ID is the device that's been assigned to that username. Otherwise, we're going to say, hey, you know what, the device ID is not their actual assigned device. Okay, so far we have one conditional statement. Inside of this conditional statement, we have another one conditional statement that has its counterpart, which is the else condition right here. So now what we got to do is we got to go and make sure that we're lined up here. And this is what I really love about using IDEs, because they actually show you this line that says, okay, you're in the correct indentation space for this original if statement right here. So inside of this specific indentation, now I want to assign the else value for this if statement, right? So the else value for this if statement is basically going to say that, you know, it's checking. So if the username is not in approved users, right? That's basically what that condition is going to say. And that's basically going to say display. Simple, right? Very, very simple. Okay, so this is basically our entire function. So now, as you remember, now we have to call the function. And the function requires two parameters that we need to give arguments for. So we need to give it a username and we need to give it a device ID. So in this particular case, what we're going to do is we're going to say login, and we're going to give it a couple of usernames that are actually in there. So there's going to be B Moreno and their device ID. Let's make sure we give it like a correct one first. We're going to, actually, you know what? Let's give it a wrong one. So we'll give it a wrong one first. It's going to be B Moreno with that specific device ID. Then we're going to have B Moreno with the correct device ID. So let me get that real quick. And then we'll actually just do one with a user that doesn't even exist inside of this list, because this guy's trying to just hack the system and he doesn't even have a device ID or whatever. Or I'll give like a proper device ID, but the username isn't going to be in the system, right? So we have three different calls to this function. We've called this function 3 times. The first one is the right username with the wrong device ID. The second one is the right username with the right device ID. And the third one is the wrong username with a device ID that exists in our list. So we're going to run this, and voila, we have 3 different messages. So the user B Moreno is approved. However, their device, this is not the assigned device. The second message says the user B Moreno is approved, and this is the assigned device for B Moreno. And the third message is the user Hank Hackerson is not approved to access the system. And that is it for our basic algorithm. This is technically a basic algorithm, believe it or not. This is a very simple algorithm. And just to kind of review the creation of this algorithm, we have 2 lists. We have an approved user list and approved devices list. And once we've established these 2 variables, and these are global variables because they're outside of our function, which means that any function can use them, including our login function. And so we created a login function. We assigned 2 parameters for our login function, which is the username and device ID parameter. And inside of our function, we start with one conditional statement that says if the username is in approved users, so if this username that we feed our function as an argument, if that username is in approved users, then we're going to print, hey, they're approved to access the system. And if they are indeed in approved users, what we're going to do is we're going to take their index position and we're going to assign their index position to an IND variable. And then we're going to check if the device ID in approved devices at that position is actually the approved device ID for that person. So if the device ID in that position is the device ID that we think it is, then we're going to print that this is the assigned device for that person. If the device ID in that index position is not the device ID that it should be, we're going to say, hey, you know what? This is not their assigned device. And then this is everything that's been wrapped inside of our original if statement. And then we're going to have an else statement that applies to our original if statement that says, hey, you know what, if this username or whatever username that we provided is not inside of our approved users list, then we're just going to print that this username is not approved to access the system. And that's it. And then we called on our function 3 times, because it's not enough for you to create the function. You actually have to call on the function. Otherwise, your script isn't going to do anything. So that's basically our entire algorithm right here. This is it. Like, this is the bulk of the algorithm. This entire section of code is the bulk of the algorithm. What we have right here is just the list that's been provided to us, and then in a little bit we're gonna learn how to read documents. So instead of you having to just feed it a manual list like this, you're just gonna have approved users as your variable, and then you're going to read from a document, from a CSV file, from a TXT file, whatever. You're gonna read from that document, and then the document contents are going to be the stuff that's inside of your approved users variable. And then you can still do something like this, but now you're reading directly from a document instead of manually copy pasting the content inside of your code like this. So that was it for our simple algorithm experience. Hopefully this was actually eye-opening for you, and hopefully you learned some good stuff from it. All right, cool. We are getting towards the end of this whole training series. So this next piece, which is about regular expressions, is going to help us understand how to work with files. So regular expressions is actually a really, really powerful tool. I did an entire video that was just dedicated to regular expressions, and I do recommend that you go watch that video and practice with that video, as well as the tools that I share in that video. And I'm going to share those tools over here as well, but there's just more examples in that video that I think will really help you get a good understanding of what regular expressions are and how to build different patterns. And the better you get at regular expressions, the better you'll be at pulling data from any type of log file or any type of file in general, really. And regular expressions are essentially just a language of patterns. So that's the big piece that we're going to be talking about in this segment right here. And for Python, the most important, I guess, the kind of like the first building block of regex in Python is that you actually have to import the regular expressions library to be able to use the various patterns for regular expressions inside of the Python environment. Otherwise, you know, whatever alphanumeric characters or symbols that we use aren't going to be read as regex patterns. They're just going to be read as, you know, whatever they are. So the first thing that we do is we import regex. And that is done by doing import re. Very, very simple and easy to do. So that's the first piece. Now the next piece is I need to share a bunch of different characters and patterns with you. And the best way that I can do this is by giving you a tool that saved my life really when I was trying to learn this, because at the first time that I went through a couple of regex trainings, I was like, okay, this literally is one of these things that I'm like, dude, I can't even wrap my head around it, until I used this tool right here. So this tool is one of the greatest things that you'll probably be able to find for yourself. And it is regex101.com is the actual website. And so you would put your pattern up here. You would put some kind of a sample string down here so that you can see if you're detecting what you're trying to do. And then on the right side, it'll show you, you know, the explanation of each piece of your pattern. And then right here, it'll show you the match information. So it'll show you whatever it matched and whatever it pulled. And then this will explain the pieces of the pattern that you've designed, and it'll help you really try to fully understand exactly what's going on. So that's a very, very powerful tool. So now that we have that, we can actually go through some of these sample patterns, as well as just understanding the few other building blocks that we need to be able to pull this off. So the first building block in regular expressions is the plus sign. So the plus sign, and I'll just type it out as well, the plus sign represents any number, one or more occurrences of a specific character. So when I say any number, I mean any occurrences of a specific character. Meaning what? So let's also type that out. All right, so the plus sign represents one or more occurrences of any specific character. Now what that means is this. So if we have the pattern A plus in this particular case, that pattern is going to match A, it's going to match AA, it'll match AAA, it'll match AAA, like it doesn't matter how many instances of that letter there are, it's going to match as many instances or occurrences of that individual character, which is in this case the letter A. It's going to show it as many times, like it'll pull whatever data that has that representation in there. And so if this is our pattern, so let's say that's the pattern is this. If that's the pattern, it's going to pull any of these things. And just to show you samples of what it would pull in this particular case, it would be any of these. So let me just kind of copy paste this in here. It would pull all of these data points right here. So it'll pull this one, which has one instance of A in it, one occurrence of A. This one has two occurrences of the letter A. This one has one again, but it's towards the latter portion of the data. And then this one has three occurrences of the letter A. So it will pull all of these results just by using that specific pattern. So it doesn't matter how many occurrences of that letter are in there, it'll pull that information for you. So that's what the plus sign represents. It'll pull as many occurrences of a specific character. Now, let's say you don't know what the actual character is, right? So let's say you don't know what the character is that you want to pull, but you know it's at least alphanumeric. So you know it could be any alphabet letter, and it could be any one of the numbers that exist. So how do we find that? In this particular case, \W represents alphanumeric characters, but it doesn't match symbols. So it represents alphanumeric characters, but it doesn't match symbols. So it could be anything like, you know, these, it could be that, it could be that, like any, well, actually, I should stop right there. My apologies. So it doesn't, this specific pattern right here only pulls up one instance. So it could pull up 2, it could pull up A, and it could pull up J. But if we add the plus sign at the end of it, then it will pull up any of these. It will pull up essentially any like number of characters or numbers, anything alphanumeric, right? So as many occurrences of an alphanumeric character. So this specific piece \W means that we're looking for an alphanumeric character. And then when you put that plus sign at the end of it, it means any number of occurrences of alphanumeric characters would show up because of this little pattern right here. Literally, just because of that, it will pull up any amount of alphanumeric characters, and then it'll stop at a special character, right? Because it doesn't, or not as, I guess we can call it a symbol. So it doesn't detect symbols. So if there is a symbol, it'll stop at that symbol, but up until that symbol, any number of alphanumeric characters will show up if we do \W plus. That's basically that pattern, right? So \W will be any \W is any alphanumeric character, and then \W plus is any, or I should say one or more. There we go. Am I misspelling alphanumeric? I feel like I am. Maybe it's not NEU. Maybe it's, yeah, there you go. Okay. I'm thinking neuron, and I think that's why I'm misspelling it like that. So there you go. That's how you do that. So \W represents any alphanumeric character. \W plus is one or more occurrences of any alphanumeric characters. And then we already know what plus sign does. Now, just knowing this, just knowing the information that you got up until this point, you can now design a pattern to detect any email address. And this is what's freaking amazing about regular expressions. So now at this point, we're going to move to our regex 101 website so that we can test this out. So we want to see how exactly can we pull, you know, an email from a file. So let's say, all right, so I have two examples here, right? So this is my two test strings here. This is just a block of text, and then it says, you know, user1 email1.com, and then this is another block of text, and then it says hank@email3.org, and even I'll make it a little bit consistent. Okay, so these are our 2 lines of text, okay? And in these 2 lines of text, we have 2 email addresses. So how do we now find this specific these 2 specific email addresses? So one thing that I want to point out here is that notice this /, and then there's a / at the end of this as well. Usually, more often than not, any pattern that you create that is regular expression specific is going to be inside of /. Okay, and then inside of the / is when you would start creating your pattern. Okay, so that's one note. Now that we know this, now that we know that we have these email addresses that we want to create, and then we have just these basic pieces of information, that we have the \w, it represents alphanumeric, \w plus is any number of alphanumeric characters, and then plus, of course, just represents that. So alphanumeric, and then let me just put this another note here, no symbols, okay? So that's also very important to understand. So it doesn't detect symbols, it only detects numbers and letters, okay? So now that we know this, what is our pattern going to look like? It's going to be \w. Now look how everything lit up, because \w is alphanumeric, and everything is now lit up with the exception of what? This symbol, this dot here, because that technically counts as a symbol as well. And then we'll talk about, because the dot just by itself also represents something else in regex, but I don't want to get ahead of myself. So the \w highlighted everything, and then if I do \w plus, is now going to highlight all of the words. How interesting is that, right? So now we have every word technically, including the actual I guess the usernames of the emails is also lit up, and so are the email addresses, or the domains of the email addresses, and so are the, I keep forgetting this, it's not the root domain, or I think it is, whatever, the .com and the .org, except the dot itself, but the .com and the .org are also highlighted. So very interesting, just with this little pattern, \w plus, we now can detect everything, okay? Cool. So now what I want to do is I want to make sure that I get the rest of the email, because I'm only interested in emails. So the only thing that I do, I just add an @ here. And now what? We have user1 @ is selected, hank @ is selected. So it detects everything alphanumeric, doesn't detect a symbol. So I have to put in the symbol that I want it to match. And in this particular case, it's the @ symbol. So that's it. I just put the @ symbol right there. And now the email company itself, or the domain of the email itself, is something else that would be essentially what? Alphanumeric. So I do \w plus. And now with that pattern, we have both of these emails detected. And the only piece that's missing is this last portion right here. So great. So now here's where it gets kind of tricky, but not even really. The dot just by itself represents a wildcard character in regular expressions, meaning it can stand for alphanumeric, it can stand for, it's a wildcard character, it could stand for symbols as well. So if we want a literal dot, we can't do what we did here with just the @ symbol. So if I just put a dot, I guess in this particular case it is working, but because it's representing kind of everything, we want to be diligent when we're creating our patterns. We want to escape the wildcard version of that dot. So we're going to do a \dot, and that's how you say that I want a literal dot in this particular case, okay? So that's very important to understand. You do a \dot, and now it allows you to choose specifically that dot, and then the rest of it again will be what? The \w plus. And just like that, now we have the whole thing. So the most difficult part of this, I would say, to understand is this piece right here, the \dot. But as we create some more examples, you'll notice that it's fairly repetitive. It's fairly consistent, and you'll wrap your head around it. So that's our pattern. That entire pattern now detected this, and literally the document could be 1,000 lines long, and it could be mixed with a bunch of crap, and the only thing that you want is the email addresses, and believe it or not, it will pull all of those email addresses. So now we have over here, check this out. So the explanation here tells us everything. So \w matches any word character equivalent to A to Z, lowercase, A to Z, uppercase, 0 to 9, and then it also represents the underscore. So I guess I kind of missed that piece. It also represents the underscore, but it doesn't represent a dash. It doesn't represent any other symbol, okay? The plus matches the previous token, meaning this piece, between 1 and unlimited times. So as many times as possible, giving back as needed, and I guess it's greedy or whatever that is. The @ by itself matches the character @ with the index. This piece, you don't even need to worry about that. Again, \w plus, that one, again, same exact explanation. \dot matches the character dot, literally, okay? That's very important to understand. And then again, \w plus, and that's it, right? Now we have this user that's been pulled, and we have this that's been pulled out of all of the lines of text that we have here. And that's it. It wasn't really that complicated to understand, right? So this tool is a very, very powerful tool. I would highly recommend you use regex 101 just anytime that you're creating your regular expressions, just to get a good understanding of it. And we use this tool, you know, for many, many instances in the regular expressions video. So if you haven't seen that one, just go search through the channel and find the regular expressions video. You don't need to like go through all the videos. You just go on the home page and you click the little magnifying glass and search in the content of the channel and just type in regular expressions or regex, one word, just like this, and it will show up and you can watch that video. So that was our first pattern, and that's how we were able to detect an email address. Okay, now that we know how to actually create the pattern, the next piece of it is, how does this apply to Python? So how do we actually use this inside of Python? So we've already imported our regex library. So now what we're going to do is we're going to create a very simple little script that's going to extract our email addresses for us. And first we need to actually dedicate a string. We need to have a string that has a bunch of things that we want to pull. Now in this particular case, I'm going to paste it in here, but what we're going to do in the next section is we're going to essentially read a file and pull the information from the file, right? So we're going to do 3 quotations so that we can have a long string of text. So a bunch of text right here is what we have. And inside of this text, we have this email address, and this email address, okay? So that's it. That's our text that we're going to read. Let me see if this is all good. It's giving me like this, these squigglies kind of piss me off, but whatever. So that's what we got. And I don't think it even matters because it's just a long string of text. Okay, so cool. So that's our string of text, and that string of text has been attached to this variable, which is email log. So being able to find it is as simple as just calling on a module inside of the RE library. And that RE module is called find all, okay? So we can do it with a print function, which would be just like this, and then you do RE, and you see, notice how this one has been highlighted up here now because we're calling that library, and then we do dot. And then when you do the dot, it actually gives you all of the modules that exist inside of the RE library. And what I'm interested in is the find all, which is right here. You can actually see it right here. So I'm just going to type in find all, and there we go. Now it tells you, hey, you need to provide these pieces of information that you want to pull from. So it could be the first you need to provide the pattern that you want me to find, and then you need to provide the string. And in this particular case, my string is coming from this variable, so I could just put the name of the variable, right? So very, very simple. So you do find all, and notice that it says you have to have this this parentheses, this opening parentheses. So we're going to do our parentheses as well. And now inside of my parentheses, first thing I'm going to do is I'm going to type out my pattern, which is going to be inside of our quotation. So it's going to be \w plus, just like that, and then the @ symbol, and then it's going to be \w plus, and then the dot, so \dot to represent a specific dot, and then \w plus. and that's my pattern. And then I can do my closing quotation and then comma, and then provide the source that I want you to search from, which is the email log. And that's it. And that's it. I just want you to print all this stuff from this email log, which has all these strings in it. And once I run this, hopefully it'll actually work. Okay, so it did work. It's just it gives this weird error, which I don't understand why it would even give this error, because it did work. It pulled the information down here and it's now extracted for us. And that's really as simple as it is to be able to pull this information. And you can do this with any kind of pattern, just simply using the find all module, or I guess the find all function inside of the RE module or the RE library, because technically this is a function. So we're doing the find all function from inside the RE, the regular expressions module / library. So that's as simple as it is to be able to use it inside of Python. And then you can have some real fun with this thing. Okay, now that we've done this, what I'm going to do is I'm going to just show you a few other examples, and then from here we're going to start going into some of the specific special characters that come as a part of the regex library, or just the regex concept in general, that language, and we're going to find out how we can use those for the purposes that we have inside of this training series. So we've already imported RE, so what I can do in this case, I can just do RE find all, and then I'm going to say TS, so that's basically the pattern that I wanted to find, and then I'm going to provide the string for it to search through, which is going to be these series of usernames that we have here. You should already be familiar with these guys right here. And so now we're just going to run this. And let me see, actually, I think I need to, I don't know if I could run it and it'll still work. Yeah, it doesn't show me everything because I need to actually run print with this bad boy right here. So we're going to do print, and then we're going to do RE find all, and now it should print it. There we go, we got it. So TS and TS, I mean, it's literally the only two instances that it shows up right here, TS and TS. So it finds that individual series of characters for you. So that's very, very basic to run. Now what we can do is we can do, just to keep it a little bit simple, I'm going to assign a like a device ID that we had before. So that's our device ID. And instead of just doing that, I'm just going to run the \w to see if I can detect any number of, or any of these characters, right? So we want to see if we can pull any of those characters. And it does work. And again, it gives me this weird error message, but whatever. But it does work. It pulled every individual piece right here, right? So it literally pulled the H, the 3, the 2 as individual items from this pattern, or from this string, excuse me, simply by using that. Now, if I do the \w plus and then I run that, it'll pull the full ID for us, because now it's counting everything that would come after that W, and it's going to say any number of alphanumeric characters are going to be found using this simple pattern right here. Okay, now what we're going to talk about are these various additional symbols that come from the regex language, and understanding what those things represent. So first is going to be, let me just type it out actually. Okay, so we got the dot by itself. The dot by itself matches to all the characters, including symbols. Okay, this actually can apply to the asterisk character as well. So if I do the asterisk character, that also matches to all characters, including symbols. \d, lowercase d specifically, \d matches all single digits, okay, just numbers. \s matches all single spaces, and this is a lowercase s, okay. \lowercase s matches to all single spaces. \dot matches to the actual period character, and we've already established that. So the dot by itself, without a backslash, which is the backslash is called an escape character, and it allows you to escape looking for the literal item within, it's weird because you need to do it to find the literal dot, but then over here you're doing it to avoid looking for an actual S. You want to use the pattern that is attached to S. I hope that makes sense. This is where my, towards the beginning I kind of had a little bit of issue. So these individual pieces are actually regex items. So the backslash lowercase d, backslash lowercase s, those are actually specific to the regex language. And what they do is they pull, all single digits or all single spaces, so on and so forth. And then if you did the plus at the end of the d, then it will look for a series of digits, right? So that's the piece that still applies to any of these things, right? So these are our special characters, our special patterns that come with the regex library, the regex module, okay? So let's see what we can do by using some of these things and I'll actually kind of just leave this here. I'll pull these up a little bit so we have some more space to work with. So let's see what we can do just by running these guys and playing around with those. So we've already imported our regex library. So now we're going to do print re find all, and then I need to give it some pattern to search for, and in this case it's going to be the backslash d, and it's probably going to give me an error again because it's so freaking annoying. And then we're going to give it the string that we wanted to search for, which is going to be this specific thing. So now what I'm asking it to do is I'm asking it to find any single digit that it can find from this pattern. So we run that, and of course, yeah, the issue seemed to be that I actually had that dot and everything inside of the text, and it wasn't properly reading it because I hadn't commented it out. So I could either do this where I delete those pieces, or I can actually do this, right? I can just take my hash and just put it at the beginning of these patterns so that it comments out all of those items and it doesn't try to process those items as code. So that's probably the best thing that we can do and still have our data on the screen. So now I'm going to try to run this. And there you go. Now it actually pulled the data that we wanted, and it has 3, 2, da 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 da. So it pulled all the numbers that are inside of this individual piece right here and gave it to us as individual items. If I added the plus at the end of this and ran it, it will pull each chunk of number that it finds. So 3, 2, and then RB was the separator, and then it pulls 8, 9, 7 at the end of it. So it'll pull any chunk of that data that we're looking for. Okay, so one edit I need to make here as I reviewed my notes. I am apologizing right now because I seem to have miscategorized the asterisk. From what I understand, the asterisk can be substituted for the plus sign. And so let's see if that is indeed the case. So let's try to run our pattern in this particular case. So instead of doing the backslash d plus, we're going to do backslash d asterisk, and let me see if that still works. And it does. Interestingly enough, it does. And it's going to, we got some empty strings over here, which is kind of interesting in here. It represents one or more instances of a specific character, or it represents 0 instances of a specific character, which is why we kind of have these blanks right here, because the very first item here doesn't have digits in it, so it's been left blank. And then you have the 2 digits, and then it's been left blank again because it's counting the R, and then another blank one because it's counting the B, and then it's counting the 8, 9, 7, and then another blank one at the end of it, which I don't know why the last blank one is there. But so it does actually count either 0 instances, which is, it's kind of like it makes the output a little bit, I would say, polluted. And I would rather use the plus sign because I don't want these empty pieces right here. I just want the data that's being pulled for me. But I guess in this particular case, because especially if you consider that this is like a very long string and it has a bunch of data in it, or it's a big file and it has a bunch of data in it, all these empty things are just going to take up space in your output, and then you have to start reading through instead of trying to just find individual items just clearly and easily. You would have to read through the thing and try to sift and sort manually, and that kind of is annoying for me. But at the very least, now we know what it actually does, and it's not what I told you earlier. So I do apologize for that. It is not, it doesn't do match all characters, so on and so forth. It can be substituted for the plus sign, which does any number of occurrences of something, including 0 occurrences. So it does 0, 1, or more than 1 occurrences of whatever this is that you're looking for, which is, in this case, we're looking for digits, right? Now what we want to do is we want to learn the piece where you can choose any amount of instances, or I guess you want to specify, you want to specify the number of instances of a specific character. That's probably a better way of saying it. And that would be done by the squiggly, and then the number of times, and then the squiggly, okay? So this is very important because we're going to be using this to find IP addresses, okay? So when you do the \d represents digits, and when you do the squiggly right here, you're saying, hey, show me only 2. I just want to know any pattern that you find that has 2 digits in a row, okay? So it should not show the 825 here, and it should not show this 2994 as a whole. It may show 29, it may show 99, and it may show 94, but it shouldn't show the entire block. It should only show any pattern that has 2 digits in a row. And indeed it does, right? So it shows the 32, which we have here. It shows the 17, which is here. Then we have the 82, which is here. So it doesn't show the 25. It only shows the first portion of it that it finds, the 82. It shows the 29, and then it shows the 94, right? So it won't show the 99. So basically it just kind of cuts off, and it doesn't include those 2 anymore, and it just moves on to the next one. So, but this is any 2 number of characters, right? So any 2 number of numbers, I guess. So if I change this to 3 and I run this, the result will be much smaller, and it will show only these 2 instances where it has 3 numbers in a row, which is the 825, and it has the 299, okay? And there's another version of this that we can run, which we can say, I want any 1, 2, 3 counts. So it could be 1, 2, or 3 instances of a digit that shows up. And if I run this, the response should be greater, right? So it should be the 32, which we got. It should be the 17, which we got, the 825, which we got. There, it shows the 0 right here, which is great. It shows that piece right there. And then it shows the 299, and then it shows the 4, right? So any 1, 2, or 3 instances of a digit, I want you to show me that, okay? So now that we actually have this, this kind of serves as the foundation for trying to find some more complex data points, for example, IP addresses, right? So you can find either usernames, IP addresses, emails, so on and so forth, just with all the data that we just covered so far. So let's go through some examples of actually doing that. All right, so now the first thing that we're going to do is we're going to create a pattern variable, and instead of putting the pattern inside of our find all function, we're just going to put the pattern as a variable, right? So what I'm going to do in this case, I'm going to create my pattern, which is going to be something very similar to this. So see if you can maybe like pause the video and see what this is supposed to detect, right? So what do you think this pattern is actually going to detect? Okay, pause that and then see what it should be. And then we're going to do the string that we have that we want to search through, and that's going to be this. So I'm just going to kind of copy paste this. So that's our string that we're going to search through. And now we want to use our print function, and we're going to do re.findAll. Very good. And we're going to do that. And the first piece is the pattern that we want. So we're going to do the pattern variable, comma, employee, and that's it. That's what we're searching through. Very, very simple, much cleaner version. And now we're going to run it. And there you go. So we found some interesting information. So we found the user ID. So it's B Moreno in this particular case. And it's been separated by a literal symbol, which is our colon symbol. So we found B Moreno, colon, and then there's a space, right? So backslash lowercase s represents the space. And then we have the digit pattern that is followed by a plus sign, which means any number of digits. So this is the logins, right? So what we're searching through is the number of logins that somebody has had. So B Moreno had 12. and then T. Shah had 7, and then S. Gilmore had 5. And notice that B. Moreno's department, which might be marketing, right, is not included in the thing, and the ID number of the individual search. So this is the individual item. 1001 is for B. Moreno, 1002 is for T. Shah, and 1003 is for S. Gilmore. So the ID number didn't show up, their department didn't show up, and the only thing that showed up is their username and the number of times that they logged in. And that is actually very useful. So imagine that you're going through a gigantic document and you want to pull just this specific series of data, and then you want to output it into another document. So that's what we're going to be going through when we start learning how to read through files and do all those things. But this is the foundation of it. This is how you learn how to do that. So first you build your pattern, and you know what kind of pattern you're looking for. Then you supply the search string or the search document, etc., and then you print it onto the screen, or you just output it into another file, and voila, your work as a security analyst / engineer is done. So knowing all of this, let's do some cool in-depth exercises. All right, so I have a long list of devices. So this is a pretty big list. This is probably the biggest list that we worked with so far. Okay, cool. So I have devices, which is my variable, and it has a big list of devices that are provided inside of a string. So this is not a dictionary, it's not a list data point. This is just a string that has a bunch of data inside of it. So that's our first piece that we got right here. And just to make sure that this is all good, we're just going to print devices onto the screen and see what happens here. And there you go. That's all of our devices that we printed at the bottom. So far so good. Python can actually read our variable. Great. So now what we want to do is we want to write a pattern that will find devices that start with the character combination of R15, so R15. So it shouldn't find this one, shouldn't find this one, shouldn't find this one. It should find that one, right? R15, 1D, M4, etc., etc. So what we're going to first do is we're going to write our pattern. And that's it. Super simple pattern. So the first portion of this is the literal portion, right? Because it doesn't have any backslash to say that this is an individual pattern that I want you to find. So this should literally be R15. That's how you create that pattern. And then the following portion of it is basically any other number of alphanumeric characters that would show up is what I want you to find. And now what I'm going to do is I'm going to simply assign a command that says, hey, I want you to find any instance of this pattern inside of this variable string. So we already know how to do that. That's it. So pattern from devices, find it. And there we go. It found it for us. R15 1DM4, XK98, U9Q5, and R1U, or 91RU, I guess I should say. And that's it. So that one was very, very basic, right? So this is a simple one. So now we're going to do a little bit more complex, or it won't be really complex. It's just going to be the data that we're sifting through is going to be much bigger. So let's use a bigger data point here. Okay, so here's my log file. Pretty big variable here. And it's still a string because we put it inside of these strings. \n just stands for new line inside of Python. So if you wanted to output this, it should output it in the same format that we got. So let's run this actually. And there you go. So it actually prints everything on a new line for you because we have this \n form, I guess, not form, what do you say, pattern? That's still a pattern for Python, but it's just specific to Python. So okay, so I'm gonna scroll down because this is very, very large and I've zoomed in on the screen pretty drastically. So for the next portion of our pattern, we are going to now create a specific pattern that's going to detect certain pieces of information for us. So let's see what we can actually drag out of this giant string that we got. Why don't we try to pull all the IP addresses? So all the IP addresses from this series of these string log items, right? So we're going to create our pattern. The pattern is going to be very simple. This time I'm just going to keep it super simple. So if the IP address has 3333, and I know that it has 3333, so I want legitimate IP addresses, right? So this is very important to understand. This one has 5 digits at the end of it, so that's not a legitimate IP address. This has 5 digits in the middle of it. That's not a legitimate IP address. So I want an IP address that is legitimate, and the first version of this is going to just be this. So that will be 3 digits, okay? That's all I'm looking for. I do realize that IP addresses can have single digit, 2 digits, or 3 digits between the dots. But for this instance, I just want to pull anything that has 3 digits. And then I have to put the dot. So if I want a literal dot, I need to do a backslash dot like that. And that's going to be my first 3 numbers, including the dot. And then we're going to do the, whoops, not right there. We're going to do it here. So we're going to do 1, 2, 3, and then backslash dot, and then 1, 2, 3, and then backslash dot. And then for the last one, we're just going to do 3. So that's it. We know that we have 3 dots inside of any IP address, or at least the IPv4 address. We have 3 dots inside of an IPv4 address, and we know that there's supposed to be 3 digits. So that's it. That's our entire pattern that we have to detect these IP addresses. So now, as you guessed it, we're literally just going to print this onto the screen, which is very, very simple. And there you go. That's what we got. So we want that pattern to come from that log file. Let's see what we get. And there it is. Look at that. We have the IP, we have another IP, we have another IP, so on and so forth. There you go. So it actually worked perfectly fine, and it pulled the data that we wanted it to pull. So just to demonstrate why we didn't want to use this version right here, which is instead of doing the 3 Ds technically, if we did this and we included that plus sign, the reason why we don't want to do that, I just want you to see what the output would be, right? So what we saw currently is that it showed us all the ones that actually had 3 digits, which is perfect. And then we have another one here. Let's see, let me just combine all these. So all my backslashes for the dots are there. Okay, great. So if I run this, you'll see that it's going to provide the IP addresses that actually have 4 digits in there. It'll provide IP addresses that have more than 3 basically, because the plus is going to show any number of IP addresses or any number of digits, right? Any occurrences of digits. It's like the better way to say it. So if I know that an IP address only has 1, 2, or 3 digits between these dots right here, then what I want to do is I want to modify my pattern to only show the versions where there's only what? 1, 2, 3 is basically what I want it to show. Instead of showing any number, or instead of assuming that it only has 3, I want it to show me any instance that has either 1, 2, or 3 digits. So this is how we modify this thing. And I'm sorry about the squigglies. I do understand that it's so ignore. Let's see, there you go. So it ignored that error. So now I can actually see what's going on. So there we go. So we have a digit. So \d represents a digit. In our squigglies, we have 1, 3, which represents either 1 or 2 or 3 instances of this digit. And then the \dot represents a literal dot, and then same thing, and it continues all the way to the end. So that pattern is now going to be all of the valid IPs, right? So valid IPs, we'll just do like that, is going to be re find all, and then it's going to say pattern and then log file, right? So that's what it is. So now instead of doing print I could literally just say print valid IPs. Whoops. And there we go, just like that. Now we're going to print it. There we go. So now it has all of them, and look how it actually pulled the one that had 2 digits inside of it, because our very first pattern was saying that I only want you to find something that has 3 digits inside of it. So it actually pulled the ones that had 2 digits inside of it. Here's another instance that had only 2 digits inside of it. So this is the best pattern to actually find IP addresses. and you will most likely use that as a security analyst in the jobs that you have in the future. You need to find those specific IP addresses. So now that we have that, what we're trying to do is we're trying to find a list of IP addresses that have been previously flagged. Okay, so we've been given a list of IP addresses that have been flagged for unusual activity, shady activity, and now you want to sift and sort through those, or you want to try to find any of those inside of a log file to give a big notification to the boss man saying, hey, these flagged IP addresses have actually shown up inside of our logs and we have an issue now. Okay, so that's the situation that we have right now. So I'm going to update some of this data on here, and then we're going to create some new patterns. Okay, so just in the interest of space, the new log file that I have, I'm just going to keep it on that one line just so it doesn't make my screen go crazy. I am going to keep this pattern because I do want to detect an IP address that is correct at that point. I will assign some comments here just to make it a little bit easier for us. Okay, so there we go. This pattern actually finds only the valid IP addresses. And then now what we want to do is we want to we're still going to do this. We're still going to do valid IPs, find all from the log file, any valid IP address. So that part's fine. But now what we got is a new variable that is our flagged addresses. Okay, cool. So far, the amount of spelling errors that I have made inside of this tutorial is kind of annoying, honestly. But okay, so far, this is where we are. So we have our log file, we have a pattern to detect legitimate IPs, and that pattern is being used with the regex module and the find all function to detect all of the legitimate IP addresses that show up inside of our log file. Now, we've been assigned a series of flagged IPs, and this is something that, they detected from malicious activity inside of our security information event manager, right? So this is something that was provided to us. And now what we got to do is we got to create some kind of an algorithm or a very basic function that is going to say for any address that is inside of my valid IPs, if one of those addresses is in this list, then you need to do a specific action for me. Okay, so here we go. Okay, so here we go. This is going to be okay, so far, this is what we got. So for address that's in valid IPs, so for any of the addresses that we found inside of this thing that's actually matching this pattern of valid IP addresses, if that address is in this list of flagged IP addresses, then print onto the screen that that IP address has been flagged for further analysis. Else, so now we're going to assign an else statement here. And it's just going to print, the function, the formatted string is going to be simple. Very, very easy and simple to do. So there we go. That's all we got. And we are now officially done with our algorithm. This is very, very basic and simple to do. This is really like when you see stuff like this is the workings of an algorithm. And just to kind of review, we have the log file, has a bunch of data in it. We created a pattern that will detect any legitimate IP address that doesn't have, 5 or 6 characters between the dots. And then we established, using the regex module, we're going to find all of those IP addresses from this log file. And then against the IP addresses that we found, we're going to check to see if any of those IP addresses have been flagged. So for the address in the valid IPs that we found, based on this pattern, if that address is in the flagged IP addresses, print, hey, this has been flagged for further analysis. Otherwise, hey, the IP address doesn't require further analysis. That's basically it. Very, very simple to do, really easy to run. So we're going to run this and see how it works. Look at that. How amazing is this? So this has been flagged for further analysis. This does not require further analysis. This has been flagged. This doesn't require. This has been flagged. These two are good. And this has been flagged. How amazing is this? How useful is this? Honestly, because this drives me wild. The first time that I ran this and I was like, yo, this is super freaking useful. This is an actual use case that you're going to run into. And they're going to say, hey, listen, we got this list of IPs. These are flagged. We also have, our general log file that includes a lot of good activity. The log doesn't only include malicious activity, but I need you to search through that log file to see if any of these shady IP addresses show up. And if they do, I need you to give me that information and I need you to let me know because we need to take further action. And this is it. This is like from here on, just being able to detect this information, you have the workings of the rest of your algorithm. Because from here on, it's like, okay, well, now we just need to go ahead and, either send this report to somebody for them to do something, or what I'm going to do is I'm going to code something else in here that is going to add all of these shady IP addresses to this other document that's going to be reserved for all of my shady IP addresses. And then my firewall is going to read from that document and just block any activity from these IP addresses. That's it. And if you really want to get fancy with it, you learn the Python library for that firewall, or you learn how to communicate with the API of that firewall, and you just code all of it inside of Python. And you say, hey, listen, for all these shady IP addresses, because of the fact that we detected them inside this log file, I need you to go ahead and make sure that all of these are blocked. And you just communicate all of that inside of Python. That is beyond the scope of this training because it gets very advanced. But this is the workings of it. This is the groundwork, the foundation. If you understand how to create a specific iterative statement and then create a conditional statement inside of that, that's basically the foundation of creating a very workable, functional script that will do a lot of really good work for you. So I'm really excited about this one. This was actually like I was just, as I was recording this video for the last several days, I was really excited to get to this portion because now you get to see how all of these things kind of stack on top of each other to give you really good functionality. Okay, so we are getting close to the end here. Where is my original text document that actually has all of our notes? Here we go. So we are officially at the very, very end. So we have working with files and parsing algorithms is the very last piece where we actually start creating some more advanced algorithms for just extracting data from files and looping through that data, finding specific information and taking specific actions for the data. So the big piece right here is now what we're going to do is we're going to learn how to read through a file. We are going to learn how to access a file, read through the file, so on and so forth. And this is where it becomes very, very, very freaking useful. So the first thing is I want to show you our file. So we have a file that we've created, and it's basically saying all of this information inside of a txt file. So what I'm going to do is, instead of just kind of going and showing it to you, the piece that I'll actually open my terminal at the bottom right here. So we have the, once we open the terminal inside of PyCharm, because it gives you access to your actual terminal, it opens it inside of the project file that you're in. And inside of that project file, I can just simply run a terminal command, which would be ls for me. And it'll show me that I have my login attempts.txt, a txt file, inside of my, my working folder. So inside of the working folder that this actual Python file is inside of that working folder is where my txt file is. Now, if that txt file that you're working with is not inside of your working folder, you need to provide the full path of that file so that everything that we talk about from this moment on is actually going to work. And I'll show you what that actually means, because if we go over here, so let me again open this terminal back up, and then I'm going to do print working directory, and it's going to give me this long path because that's basically what it is for me right now. And if I'm not inside of this working file, or this working folder, if I'm not inside of this working folder, instead of just saying loginattempts.txt, I need to give the entire path. And then at the very end of this, because this is the name of the folder that we're in, at the end of that, I would do / loginattempts.txt. Okay, so that's what that would look like. And just to kind of give you a heads up. If you don't know how to do this, this is like one of those super basic things with system administration. So if you don't know how to do this, go watch the SysAdmin video that I created for Linux. The same concepts apply to Windows, but I will create a Windows SysAdmin video as well, just so you can try to find the working directory and know how to use that as the path of whatever file you're working with. So first and foremost, what we're now going to do is we're going to learn how to open a text file inside of Python. Super simple, but super powerful. In order to do this, we are going to start with a keyword, which is with. Now, with is going to handle a lot of different things inside of Python. But in this particular case, what we're going to do is we're going to manage external sources from Python. So in this case, our external sources is going to be open, which is one of the functions that we're going to use, and then the actual file that we're going to use. So the combination that for any reading of file or writing into a file or anything of that source, the combination of commands is going to be with, open, and then parentheses, and you're going to provide the name of the file or the path to the file. And if I start typing this piece, it should start, there you go, it'll fill in the rest of that word for me because it's detecting the file that's inside of my working directory. So this is the first piece of our open function. Then we need to put a comma, and then we need to give it the command or the format, I guess, that we want this file to be opened with. So do we want it to be opened in read mode? I guess the mode is probably the better word. So do we want to open it in read mode, or do we want to open it in write mode? And that's very important, because if I want to read this onto the screen, or if I want to read this using a print command, I would have to use R. If I use R and I want to write to it, I won't be able to do it. If I use W for write and I want to read it, I won't be able to do it. So it's very specific. So if you want to print it, or if you want to display it, or if you want to read the data so you can create a variable with the data that's inside of it, you would have to use that with the R mode of this function. And then we're going to now create a variable as file, this is kind of like the best practice. Usually how it works is that whatever file you actually read or want to write to, you're going to save it as file variable. And doing as file is very similar to just doing file equals with open . But the common practice that's been done, this is how I was taught, so this is how I do it. But you doing as file is you're essentially assigning this whole thing to the file variable. So doing as file, you're creating a file variable. It's very similar to doing file equals with open . So that's basically the command that we have in this particular case, where we've done with the open function. I want you to read this file and then turn it into the file variable. Okay, so now once I've done that, I press enter and it's indenting it for me, because this is very similar to any of our iterative or conditional statements, where now we have to do something with this. So with this file open in read form, what do we want to do? We want to read the file. So we're going to do file text will just be our variable, and file text is going to equal to file, which is our variable. And as soon as I press dot, you see all of these things show up. And what I want to do is I want to read the file. So I'll do file.read, and that's it, basically. And now I have the contents of the file. I have the contents of this thing inside of my file text variable. And now I can print file text. I run this, and there we go. There's all of the items inside of our login attempts text file. Okay, so far so good. So we have our login attempts inside of our working directory as a text file. With the open function, we've opened this file in read mode, and we've saved it as the file variable. And now a new variable has been created called file text, which equals file.read, which basically means that we're reading this file. So now this variable can be printed. And I just printed it, and this is what it looks like onto the screen. So very simple. That's how we access a file. All right, so I basically just created another text file inside of our working directory just to kind of demonstrate this to you and just to use it for future examples that we got. It's the sonnet.txt file, and this is one of Shakespeare's sonnets. I have never read this sonnet up until this point in my life. This is literally the first time that I'm reading this sonnet. But now we have a new .txt file inside of our working directory. So if I just go over here and just modify this, right, sonnet, there we go, and then we read it again, and now we can read the file. It's very, very simple. This is not like a complicated command, right? So the open function, reading it in, or writing it, in opening it in read mode. Good God, I can't speak English. Opening it in read mode will read it for us. Opening it in W mode will write onto it, and W mode will replace the contents of the file. So let me repeat that. W mode is going to replace the contents of the file. So this is very, very important to understand. When you open a file in W mode, be very sure that you don't care about the stuff that is inside of that file. So since I already have this sonnet, what I'm going to do is I'm going to open it up in W mode. And I don't care about the contents of the sonnet because, yeah, I don't care. I can just go to Google and get it again. So what I'm going to do in this particular case is I'm going to open it, and I'm going to write to it. And then what's going to happen is that it's going to kind of mess with this whole piece for us. Now, in this case, I don't actually need the file text variable anymore, so I could just delete this entire piece right here. And what I'm going to do is I'm going to do file, and then we'll back that up just so you can see what all the options are as well. So we'll do file dot, and then we see all these options that come here. And if we go down here, we're going to see there's something called write. So we can write into the file. And we're going to write, sorry that this happened. Okay, so there we go. That's what this thing is. And now actually just to kind of show you the difference, I guess, in these pieces, right? So we have with open, and I'm going to reopen this real quick, and I'm going to open it in read mode, and we're going to open it as file again, and then it's going to be file text is going to be file.read, all that good, right? And then we're going to print file text in this case. There we go. And then I'm going to open it again, but I'm going to open it in write mode as file. I'm going to write, sorry that this happened, and then I will actually do this. So I'll create this also into a file text variable as well. And then we're going to print file text again, and then see what happens to our sonnet. So here we go. We're going to click on that, and whoops, what just happened? So loving in truth is all good, da 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 is all good. And then something happened interesting here that says 24, which I guess what I did didn't actually work. So what I wanted to do, or what I thought I was going to do, didn't work. So now I get to kind of debug this and see why this didn't work. Oh, interesting. So the first time that we ran it, it read the full sonnet and it printed it for us. And it actually did process this correctly as well, but it didn't print it onto the screen that it had done that because I didn't do this piece. I didn't reopen it in read mode and read the file text again. So the actual piece where it was supposed to write this actually did work. I just missed this part right here where I had to reopen it in read mode to be able to read the contents again. So now we actually see that we have both of this printed onto the screen. It was the first instance that happened because it already did rewrite over the file and the sonnet is gone. And then now it's just reprinting the whole thing onto the screen as well because this is also onto the screen. So it actually did work. I just was supposed to read it again so that I can print that text onto the screen. So now our sonnet is gone. So what we want to do in this particular case, instead of writing onto the file, we want to append to the file, which means we want to add the information to the file. And that way it won't replace what originally was the content of the file. So in this particular case, since I already know that it's going to read and print out, sorry that this happened, I'm going to just write another line and we're going to append it this time so that we can make sure that it doesn't erase over the last piece. And then hopefully that appended statement will stay in it, and then now we'll get 2 lines of text, right? So let's add, it's all good, basically. And then we're going to run it. And look at that. It says it's all good. But do notice that there is no period here. Do notice that there is no space there because it literally concatenated the 2 strings. So I'm going to do a dot and a piece at the end. Now it's going to add another dot, it's all good, because it's not going to rewrite over the file. And so if I run that again, so we'll see this one actually ended because we put that period at the end, we have a space, and now it says it's all good. So that's exactly how it works. So there is no, just keep that in mind, right? So it's like, it's going to concatenate the data, and it's going to, if you don't have line separators or anything like that, it's going to just have them be mashed up together. So now that we have this, now that we know exactly what's going on, what I'm going to do is going to start working with our log file. So what we want to do in this particular case is we want to add a new log item to our log file, right? So the log item is going to be line in this particular case. And I'm just going to copy this because I really am lazy when it comes down to typing IP addresses and doing all that stuff. So that's our log line that we're going to add. And now we're going to do with open. And we're going to open our login attempts, and we're going to open it in append mode because we don't want to rewrite over the file. And we're going to open it as the file variable. Then what we're going to do is we're going to write to it. So it's going to be file write, and that's going to write the line onto the file. And then I'm going to reopen this file in read mode, right? And I should actually, you know what, just to kind of display, or you know what, I'm just going to open it up inside of our window here just so we can see the before and after of this file. With open, and I forgot to do read and as file, and then we're going to say file text equals file.read, and now we can print file text. Okay, so this is what we got. So let me actually show you what the file looks like now, and then we'll just make sure that we've appended this thing to the end of the file. All right, so this is our file as it stands currently, and we have the last item is the Aquino, and this is the log item. So this is actually not even going to be a similar log item as the last one, because these are login attempts, and I guess the one that I got is from an access log that actually has given the person access, because we have a true value at the end of it, meaning that they did get access at this time to this. This was their IP address and that was their username, so they did get access. So technically it doesn't belong in the login attempts file, so whatever, just humor me. So what we're doing is we're appending this line to our document, and then we're just going to read it and print it onto the screen. So we are going to see that we actually have this piece right here. So this person was indeed added to our log line, or our full log. The previous log had an ending value of Aquino, and what I love about PyCharm is that it just updated the txt file while it was still open inside of PyCharm, and it just added this last line to it for us. So this is what is absolutely lovely about this thing. But I don't think that this was supposed to be at the end of it, but whatever. Okay, so that's how you append data to a file. So now we know how to read from a file, we know how to write over the file and completely replace the document contents, and we now know how to append data to a file. So now that we have this information, we can now go into parsing the file, meaning we're going to pull data from that file. So let us have some fun. All right, in order for us to parse a text file, we are going to use a couple of functions that come built in with Python. The first one is the split function, and then we're gonna use something else that will do the opposite, which is going to be the join function. So that being said, first and foremost, we're going to open the file, right? And then we're gonna read it, and then we're going to split the content of that file, and it's going to be very similar to what we just did. So with open, and we're going to open our login attempts, so we're going to open it in read mode, and then we're going to assign it to the file variable. Now file text is going to be this, all of this is literally the same that we just went through. So now here's the key difference. When we print this, is going to be with the function at the end of split. Okay, now what this is going to do, as the name implies essentially, is going to turn a string into a list. And this is going to be a lot of content that we're just going to print right now, because the login attempts is kind of a big file, or there's at least a decent amount of data inside of it. But it's going to turn any string data into a list, meaning it's going to split the various elements of that into individual elements. So for example, let's run it. Okay, so now you see this, right? So we have the username, which was the first piece. Then we have the date, that we have the time, and we have their IP address. And then you have another username, date, time, IP address. Username, date, time, IP address. This is basically what it's doing. Previously, so if I went, let me just actually do it the normal way so we can kind of see, my God, what's happening. Okay, so there we go. We're going to read file text. So this is the original file text, right? One per line. This is what you have. And now split is just splitting these, and the character or the position that it's finding as a split is the space, because we haven't designated anything that we want to use as the separator. So that's what that means. The separator in this particular case is just being automatically detected as the space. And I'm actually really interested to see what the very last item, since there is no space as separator, we have a comma as a separator. I'm interested to see what the last item looks like. And the last item, interestingly enough, has been considered one whole item, because there is no space separating it, there are commas separating it, and so it's reading this entire piece as one entire item. And that's actually very, very useful to know. So unless we declare what we want our separator to be, the split method is just going to automatically assume that we want the space to be a split point, the separator, and from there it's going to split each individual item from the list or from the string, because these are all string values. It's going to split each individual item from the string into one list item, and then you can see what's happening over there. Now, since we understand separators, what we're going to do is we're going to work with another variable, which is in this particular case our approved users. And as you can tell, these users have been separated by commas. So in this particular case, we would have to declare how we want this to show before, I'm going to do before splitting it, and then after splitting it, and then what we're going to use as our separator is the comma. So this is going to be our before split, and then we're going to have approved users, and then we're going to just reuse our variable, but in this case we're going to split it, and then in our parentheses we're going to put our separator to be the comma, and that has to be inside quotations. And that is basically how we split according to commas, if we have commas as our separator. So now we have that, we're going to go ahead and print the after split version of this, which is going to look like this. And there you go. So before dot split, this is what it looks like. After dot split, we have each individual item, and then it's turned into a list. Okay, so you can have essentially anything be a separator so long as you declare what you want the separator to be. If you don't declare a separator, it's just going to assume that the space sign or the space character, whatever we want to call it, the space is going to be the separator. If you don't declare a separator, the space will be it. If you do declare a separator, it will be whatever you actually declare. And just for your reference, this is what that would look like. So this is a list that's been separated by the space, and we didn't declare anything in our split function, and it automatically detected it for us using space as the separator, and it just did that automatically and just split it for us and turned it into a list with individual items. And as you already just saw, the same thing applies to reading a file, and then you can use the contents of the file to be split, and if you don't declare a separator, it will just detect the space to be the separator. If you do, it'll be whatever character you choose as your separator, and it'll split the content according to whenever it finds that inside of the text of the file, and then it'll convert everything inside of that file into a dictionary, I keep saying dictionary, not into a list. It'll convert it into a list, and then you'll have each individual item be the contents of whatever was inside of that file. So now that we have that, let's go into our next function, which is the joint function, or the join function, excuse me. Okay, so this is what it looks like when we use join as our function. So in this particular case, the content or the list, right, is what we're trying to join into one string. And this specific piece is just our usernames, and then we have the instead of doing dot split after the variable, we are first declaring what our separator is, which is in this particular case, it's going to be a comma. So all of the users are going to be separated by a comma. And then we're going to do dot join. So our approved users is going to include or it's going to be the comma dot join and then each item of the approved users list. So if we ran this, that's what it would look like, right? So if we wanted it to be a little bit prettier, I could do a space right after our comma right here, and then we run it again, and now we can see it's a little bit nicer because there's a space between each one of those things. So join, first you declare what you want to add to your string to join each one of these individual items, because since it's coming from a list, it's already assumed that that list has multiple items inside of it, and what you're trying to do is you're trying to join all of the items inside of that list, and then you have to declare what you want to separate each one of those individual items, and it could be a couple of spaces, it could be a comma, it could be a colon, it could be anything really, and then it will just do that for you, and then it will create one long string after the fact that has been joined, that has joined each individual item that's inside of your list. And now we can do essentially the same thing by reading a file, right? So if we were to split a file, you already know what that looks like. So what we're going to do is now we're going to join the items of the file, and then we'll see what that looks like. Okay, so this is what I have. Hopefully this will actually print everything onto the screen. If not, we'll just, we will rerun this and then just read whatever the new content of it would be, because we're doing a write mode in here and we're not doing append. So we're technically just going to be rewriting everything. So first and foremost, this is our current login attempts file, and you can see everything's been separated by spaces. So that's the first piece, is that we know that the original content is separated by spaces, and what we're trying to do is we're going to separate it by commas. So that's essentially the goal that we're trying to have here. So we're going to open the login attempts file in read mode, and then the file text is going to be read, and then the new text is going to be what this was, and split. So we're splitting the new text, and then we're printing the new text. So this portion should just give us something similar to this at the end right here. Now that we have that, we're going to we're just going to recreate the new text variable, but we're going to join this piece right here. And then we're going to open it in write mode, and then we're going to write all of this stuff that's been separated by a comma, and then just print all that out into the screen. So hopefully this will work in a way that I think it should. So let's try it out. All right, so the first portion of it did work. It did actually separate the stuff. It did split everything for us. So that part did work. If I go over here and I look at it, it actually did also write everything onto the file separated by a comma as well. So it actually did work, that part as well. It's just that unfortunately in the same script, it won't reprint the correct stuff onto the screen for us, but it did actually work. So the first portion of it was to split everything. The first portion was to split everything. And so what it would have done is it would look just like this. This is what that log file looks like when it has been split and each item separated by a space was split for us. Then what we did was join all of those items, and this is what it would look like in that particular case. Because notice at the very beginning it doesn't have the square brackets, so I know for a fact that this is not a dictionary, or I keep saying that it's a list. I know for a fact that this is not a list. This is actually a long string of data, as we can tell right here, that has now been completely replaced the original log file. So now that's all I got. So now we can move on to the next piece. So now we know what split does, we know what join does, and we were able to use files to actually make all of that work. All right, so now we're going to run a couple of exercises where we are going to import our text file, we're going to read our text file, we're going to do some splitting and joining, etc. And then we're going to start adding and removing some elements from the text file as well. So we're just going to put together everything that we just learned with opening the file, reading the file, writing to the file, splitting data from the file, so on and so forth. So that is where it all starts. And what I did was I just replaced the contents of our login attempts file, and that's basically all we got over here. So this is the full contents of the file itself, where we actually have a username, IP address, time, and date as our header, and then we have the items themselves of each individual file. So that's what we got. That's what we're working with in this particular case. So first and foremost, let's see if we can just read this file. And what I'm going to do, instead of saying with open and then putting the name of the file in there, we're just going to assign the name of the file to a new variable called import file, and that's going to be the name of our file. So that's going to be our file, okay? And now what we're going to do is we're going to use our with open statement, and we're going to use import file as the file name. We're going to open it in read format, and we're going to assign it to the file variable. Now the text is going to be file.read, and all we're going to do is we're going to print the text. We just want to make sure that we can actually do this. So there we go. And that is indeed the contents of our file. And of course, it even printed the header of that file. So far, so good. Now, the next thing that we want to do here is we want to split that text. So everything stays the same up until this point. Nothing changes. The only thing that we're doing is we're just going to do dot split at the end right here. And then we're going to see what happens here. And it technically should, I think, print everything exactly the same, except now it should just change everything into one list item. So this should be a list item. This should be a list item because we haven't declared what our separator is going to be. So it's going to assume that a space is the separator And since there are no spaces here, the new line, so at the end of each line, this is all a new line. The new line is going to be considered the separator in this particular case. So when I run this, we do indeed see that the first line is now an item, then the next line is an item, the next line is an item. So it did split everything correctly, and it split it according to the new line being the space, because we didn't declare what we want our separator to be. So okay, so far so good. It's reading the file, it can split the file, and so far everything's working exactly as it should. So let's add some elements to this. The first thing that we want to add is a new entry that we're trying to add to our login file, right? So it's going to be missing entry, and I'm just going to copy paste this bad boy right here. And this missing entry is going to, as you guessed, is going to be added to our file here. So now instead of opening it in read mode, we're going to open it in append mode. So with open of that import file in append mode, now instead of reading, right, it's going to write onto it, and I don't even need to do text equals etc. I'm just going to do file.write, and then what I want you to write is the missing entry. You guessed it. So it's going to open it in append mode. It's going to read or it's going to append the missing entry. So now I just want to make sure that you actually did write it the way that you were supposed to, and everything looks the way that it does. So what we're going to do in this case is we're going to open the file again, and it's now going to be opened in read mode, and still going to stay as the file variable, but now it's going to just have these elements where now we're just going to read the file, and then of course we're going to print it. And I'm not going to split it because I don't want it to be all this one line. I just want to see if the file actually appended our new item JRafael, right? So the last item is J Soto here. We just want to make sure that JRafael is going to be added to our list, and it is. Look at that. And if we went and checked our text document, it is actually added to the text document as well. So far so good. Everything's working exactly as it's supposed to. All right, so here is now what we are going to do. We are going to use this little with open function to actually create a file. And the way that it works, I mean, you're literally just going to write it as if the file already existed. And then what Python is going to do is it's just going to create the file, since we're going to be using the write mode for it. So currently allow list does not exist in my current directory. So that's the basic format, right? So I don't have allow list. Now I'm going to use this string that has all of these different IP addresses to add to my allow list. So if I try to print the import file, it shouldn't exist. So nothing should actually print. And then if I try to print the IP addresses, it should literally just print the list of IP addresses. So yeah, so the allow list doesn't exist. So literally all it's doing is it's just printing this string that I have attached to this. So technically there's literally no list or anything that exists in that situation. But what I'm going to do is I'm going to use the with open command to actually write onto that file, which means it's going to create the file, right? So this is basically what it is. So with open import file, all of this stuff is going to stay exactly the same, and it's going to be in the W mode, which is in write mode, and we're going to do that. That part doesn't change. It's as if the file already existed. And I'm just going to do file write, and then I'm going to do IP addresses. Okay, that's basically what I'm doing. So now if I run this bad boy, process is finished, everything is all good. So now I just want to see if my import file actually has anything in it. So let's see if we do print import file in this particular case, if anything is going to happen. Oh no, you know what? It's still reading this as the thing. So I need to actually now open the import file in read mode. And instead of writing, I'm just going to read it. And then I'm going to delete this piece right here. And so now hopefully it will actually print something. Oh, it didn't work. So here's what I thought was going to happen, and it didn't actually happen. So now what we're going to try to do is we're going to try to actually make sure that number one, that file even exists, because it seems like it didn't even create it, so I don't think it even exists. So since it doesn't exist, I guess everything that I just shared with you is absolute bollocks, and it's not correct, and you would need to create the file in advance. So let me just double check. No, I was absolutely right. It did work, and it did actually create an allow list txt file for me, but for some freaking reason, this thing, oh, you know what? That's why. So with import file as file, I didn't do this portion where we're going to say text is this, and then I'm printing the incorrect piece. I'm supposed to be printing the text. So if I do that, voila, there you go. Okay, perfect. So it did actually work. I just made a very basic mistake. So it did work. It did create our allow list file for us because we used the with open in write mode. So all of that actually did work. I just missed this portion where I was supposed to assign the contents of this file read to a new variable, and I was supposed to read that variable instead of trying to read the import file at the top right here. So yay, I'm so happy that actually worked. All right, we have arrived to our last segment of this tutorial, which is going to be combining everything that we have learned up until this point. Well, not the beginning stuff with the installation, but all of these other things. We're going to combine everything else that we've learned to officially build a parsing algorithm. And it's going to be very functional. It's going to be very useful. And it's going to be something that you can modify to do essentially many other things. So just because we're creating this version of it doesn't mean that you can't modify it to have it do other things for you. So I'm very, very excited that we finally arrived. If you watched this entire thing in one session, or if you watched it in 1 week even, I'm very proud of you for making it as far as you have gotten right now. If you were one of those clever cookies that just used the timestamp and you skipped to this portion, I completely recognize your gangster as well. I think it's very cool. I just hope that you know exactly what we're going to be talking about, and all of this is going to make sense to you. I'm assuming that you already know, what regex is, and you already know how to work with files and all that stuff. So that's going to be something that I'm just going to leave up to you. So, I would recommend you go through the entire thing just to get your foundation strong. But if you just skip to this portion just because you wanted to get all the goods, then I completely understand that as well. I have done that plenty of times in my life. So no hard feelings there. Okay, so what we're going to do is we're going to build ourselves a parsing algorithm. So let's do it. All right, so what we're going to be doing essentially, first and foremost, we're going to be working with our allow list file for this one. And the allow list file, as you already know, has a bunch of IP addresses inside of it that have all been separated by a space between them. And these are all just on one line, which technically is one long string of data. And these are our allowed IP addresses. That's basically what we're working with. So we're going to assign that file to our import file variable, which is going to be the allow list. And that is our first variable that we've created. Now what we need is we need to have something that we're going to now remove from that list. So for whatever reason, these IP addresses are not supposed to be on that list. Those IP addresses should be removed from the list, essentially. So these are our two working variables right now. Just to affirm everything that we've learned so far and to just show that we know what we're doing, we're going to open our import file, and we're going to open it in read mode, and it's going to be in the file variable. We are going to essentially assign that information to the IP addresses variable, which is going to be file.read. So since we already know that inside of this list is a bunch of IP addresses, they're going to be assigned to the, they're going to be assigned to the IP addresses variable over here, and we're just reading them, right? So I just want to make sure that we still know what we're doing, right? So we're going to do that, and we're going to run it, and there you go. It's reading the file perfectly. So, okay, good. We got our content. We have the content of our import file. So now what we're going to do is we're going to work with a few pieces, few functions that we've already worked with, because now we need to be able to manipulate this data. Because remember, this data is currently in string format. And if we wanted to remove something from this list, because we already know that we're supposed to remove these items from the list. If I wanted to remove items from this list, Python couldn't read it because it's all just one giant string. So the first thing that I have to do is I have to convert that information into a list. And the way that we do that is by using this split function. So this portion is still going to be all good, right? So we're still opening the file, we're reading it, the IP addresses portion is going to be fine, and we're still reading that information. Now what we're going to do is we're going to do another version of this IP addresses variable, but it's going to be IP addresses that is split, right? That's the piece. And now this specific variable is going to be a list instead of being just one giant string. And so we need to confirm that. So we're going to now print the new IP addresses, and it should be a list. Perfect. So this is now a list. And now that IP address is actually one item. This is another item. This is another item. So now that we have this version of our allow list document, what we can now do is we can start parsing through this and remove pieces from it. And we've already done something similar in earlier exercises. So none of this should be surprising to you, or it shouldn't be anything that you haven't really seen before. So we're just going to build on our iterative statement. Okay, we're going to essentially first just write the statement and make sure that it's going to work how we want it to work. So it's going to be for address in IP addresses, right? Print address. That's basically what I wanted to do. And instead of it coming out all in one line, it should now technically just give me each IP address, instead of it being in a list like this, it should now give me everything one per line. So we run this and there you go. So now we have all of those IP addresses one per line. So our for loop also works. It's iterating through every single one of the addresses inside of our giant list of addresses, and it was able to print it onto the screen for us with no problem. So far, everything's working exactly as we want it to do. So the next thing that we want now is we want to create the portion where it's going to check this list for these items, and if any of these things are in this list, we want them removed. Okay? So this is where it kind of starts combining all of the stuff that we've learned so far. So here we go. We still have our iterative statement right here, which is for address in IP addresses. I am going to now write if there is an address that is in my remove list, right? I want you to remove that address, right? So really, really simple, right? So for the address that's inside of this address list, if that address is in the remove list, then I want you to remove that address. That's it. Very, very simple. And then what you're going to do is you're going to print my list again, and I'm going to make sure that it's all good. So just to kind of give us a little bit of difference here, let's see just what this would look like. So now we have two print statements. The first one is just going to print the entire thing as a list for us, and the next one should be printing the updated version of it for us. So there we go. So now we have it. Oh, automatically I see that this one is gone, so this item doesn't exist anymore, and it seems like it actually worked. So 225, 170, 40, and 57 are gone. So 225 is no longer here. Let's see, 170, is 170 in here? I don't think that's in there either. So it worked. It actually did what it was supposed to do. Very, very excited. Our item has worked, and it's basically just removed one item from the list, right? So this is the only thing that existed in the list, and it removed that for us. So I'm very, very excited. This actually worked. But our job isn't actually done, right? Because we basically just removed it and we just printed it onto the screen. So we need to rewrite onto our allow list and write onto our allow list the IP addresses that are actually supposed to be on there. So literally the only thing that we did in this particular case, we just printed what the updated information would be. So what we have now is we have an IP addresses variable at the very end that was split, and now we need to join them all back together so they will end up being one long line again, and then from there we would be able to do it accordingly. So this is actually just to kind of give ourselves the comparison here, right? So we have the original data, which is just one long string, as we can see right here. The second version of it is the split version that has now turned each one of these into an item in a list. The third version is the version where we deleted the IP address that was on the remove list. Okay, so far these are the three different versions that we have. So what we don't have is the updated document. So what we need to do is now we need to write something in our code that's going to actually update our document. So this is going to come after our iterative statement and our conditional statement. So this is our iterative, this is our conditional, and it did exactly what it was supposed to do. So now what we're going to do is we're going to take this new variable that has the list that's been updated. We're going to now join everything the same way that it should be originally. It should be all separated by spaces. So we're going to separate them by spaces. We're going to join them, and it's going to be joining the items inside of that IP addresses list. And then what we're going to do is we're going to confirm that this actually worked. So I'm going to confirm my import file in right format, and I'm going to write it import it as the file variable, and then I want to write onto that the new list of IP addresses. So IP addresses in this line has now been converted to a string that looks just like this. It's been joined and converted into that string, and then we are now going to write that new data with the updated IP addresses onto our text document. All right, cool. I ran it. There were no error messages or anything, which leads me to believe that it did indeed work. And so since it did work, and I have now confirmed that it worked, what I'm going to do is I'm going to read the file and make sure that the file now actually has the IP addresses that it should have. So the original document had that 225 IP address in it right here. And now this document, we should check to see, and I'm going to just verify over here that the 225 doesn't exist in this anymore. So I don't need to confirm whether or not that has been removed. I just know that it's been removed. I know that my for statement and my if statement over here, I know they did their job and they were supposed to do exactly what they did. So now I just want to confirm that my file actually looks the way that it's supposed to look. So what I'm going to do is I'm going to open my file in read format, and I'm just going to read it and print the text onto the screen and just make sure all of that is good. So let's see. All right, here we go. Moment of truth. Let's see if this actually worked. And it did. So perfect. So the original list that we read over here obviously does not include that address because it's already been removed. So when it reads it the first time, it's now reading the version that we already rewrote, and it doesn't have any of that information. So we can actually just remove this piece right here because we know that this is actually working. We also know that the IP address split function for us over here is actually working, so I can just remove that. And now I just know for a fact that this is working as a complete file. And so what we can do is we can add items to this remove list anytime that we want to update our text document, our allow list document. Anytime we want to update it, we can just add the list of IP addresses that should be removed, and it's going to run everything accordingly, and it's going to remove that IP address from our list, or those IP addresses from our list, and it's going to give us the final version in our text document. And that final version is going to be exactly the way that it's supposed to be, formatted in this way, which is all one giant string separated by spaces. That's exactly what it's supposed to do. So this is now a complete algorithm that can be recycled and reused multiple times for a variety of different lists. And even if you wanted to, this is actually what gets really exciting, right? Because you already know how to do this. So you know exactly what you're supposed to do. If this remove list was also a text document that was in a string format, you know that you would read it and then you would split it so that it becomes a list format. And once it's inside the list format, you can then continue with this portion right here that says, hey, for address in that original IP address import document right here, for address in that document, if that address is in my remove list, then I want you to remove it. And then I want you to join the final variable separated by spaces, and I want you to write that onto my document, and then I want you to read it back to me just so I know that the list has been updated. So what I'm going to do right now is I'm actually going to add all the comments to this just so it looks proper and we know exactly what each line is supposed to do. And I was supposed to do that at the very beginning, but I don't follow my own rules sometimes. So, don't kill me, sue me. So here we go. So let me just add all the comments real quick. Okay, here we go. These are all of our comments. Now our script actually makes sense here. So the first one, you assign import file to the name of the actual file that we've imported. And then in the next one, we assign remove list as a variable to the list of IP addresses that are no longer allowed to access restricted information. And then the next one is going to be the beginning of our with statement, right? So we're going to build a with statement to read the initial content of our file, which is our import file variable right here. And we're putting it in read format and we're storing it in the file variable. And then we're going to use, I'm actually going to keep this in one block. We're going to use the .read function to read the imported file, and then we're going to store that inside of the IP addresses variable. And then we split the IP addresses variable so that everything is turned into a list from a string. And then now we have our major operator here, because this is like the more, I would say this is probably like one of the most important parts of the script. So it's going to check the IP addresses variable that has now been converted into a list. And it's going to check to see if any of the addresses that are inside of that are on the remove list. And if the address is on the remove list, we want to remove that address. And then we're going to convert our IP addresses list back into a string by using the .join function and then separating them by spaces. And then now we have another with statement that's going to import or open the import file, It's going to open it in write mode so that we can actually write the IP addresses back onto it. And since we're putting it in write mode, we are replacing the contents of that file, meaning we're just overwriting everything that's already in that file. So there's no duplicates and nothing like that. So we're just rewriting everything that's inside of that file. And with another open statement over here where we're now going to open the import file in read mode to be able to actually read everything that we did and make sure that we did it correctly, right? So it's just going to print everything back onto the screen for us, and everything is now perfectly done. Okay, so just to make this professional and to really make it look like we know exactly what we're doing, we're going to turn this entire thing into a function. And what's beautiful about this is that our function can be reused in a variety of different portions and it can be called from different Python files, all that good stuff. So what we're going to do, just to make this really, really official, is we're going to create a function, and it's going to be called update file. We're going to feed it an import file and remove list. And then, just to make this like really, really awesome, we're going to indent all of this stuff. Actually, so what I think I need to do is, hold on one second. Actually, so just to do this correctly, I think I did that incorrectly. So it's going to start here. This is where our function is going to start. And our import file is going to be passed as an argument to this function. So we can actually remove this piece entirely right here, and we're going to pass it into the function when we call the function. Okay, and we already know how to do that. So you've seen how to do that before. So I'm just going to delete that, but I'm going to show you exactly what we did just to make sure it's all good. And then our remove list is going to be passed into it in the same current format. So we're just going to pass it as a list. So that's all good. I'm just going to delete that entirely. So this is what the function looks like. And in order for this to actually operate properly, I need to go ahead and make sure that everything is indented. So this is a very big piece about this, that if it's not indented, this whole thing is not going to work. So we need to make sure all of this is indented one time just to fit under the function that we have over here. So we're gonna highlight that entire piece. I'm gonna press indent, and everything now works, and it's all properly indented and working over here. So what we're gonna do to actually fill this in correctly is we're going to call on our function, and we're going to feed it the parameters that it needs, and then we're going to essentially just read. Actually, I think this entire piece is also supposed to be unindented. So I think that piece is supposed to be unindented. Yeah, you know what? There we go. And then we're going to call on our function. So it's going to be update file, and then we're going to pass the import file into it, which is going to be the allow list as a txt file. And then we're going to paste our list of items that are supposed to be removed. So that is all good. And then we're going to text file read. Yeah, I think all of this is actually perfectly fine. So let me just make sure. All right, that's it. That's the final piece right here. Okay, so everything is perfectly aligned now. It does seem, I mean, I feel like this is a little bit more functional, because this entire piece that's supposed to be repetitive and just reusable is not going to be reused as often as we need it to be. And all of the elements of it are correct, and everything after the function, which is going to be the calling of the function, is all good. So let me actually make sure I properly space these out. So we call the function over here, and let me remove this squiggly so we can actually see what's going on here. So we called our function. The first argument that we fed it was the allow list. So now we no longer have the allow list sitting inside of the entire process. The function is reusable, and the import file can be interchangeable. So we can give it any import file, and it'll still run the way that it's supposed to. So the allow list can still be the same file. It could be a new file, whatever. The second portion is the IP addresses that are supposed to be removed, which is going to be the remove list. And that can also be sitting inside of a text document, except it actually needs to be in list format because of the way that we've written our code. In order for this to actually be read from another file, we would need to simply write it into this piece right here, where it reads the remove list, and it uses the split method to convert it into a list, right? So it reads that text file and it converts it into a list format like this. So that it's not complicated. You should already know exactly how to do that. If you just follow the instructions that we've done so far, that is not going to be a problem for you to do. And I'm going to leave that as kind of like a homework. But honestly, if you have any problems with it, ask in the comments section and I'll probably just drop that in the comments. I want to kind of leave something for you to do on your own. I don't want to spoon feed that piece to you, but you can literally just follow along exactly what we did over here with this specific piece, and you would be able to then read this whole piece right here. You would be able to read whatever your remove list txt file is and then convert it into an actual list data type, and then just feed it into this piece right here. The same way that we put .txt and the actual file name, you would just put this as a .txt file name, and then the script would do the rest of it for you. So your update file is your allow list. It is reading from this list, which is going to be your remove list, and then it's going to run everything that it's supposed to do, and it's going to rewrite to the file at the very end of the function. And then, since we already have that, we're going to open the allow list in read format. We're going to read it, and then our script is going to write it onto the screen to make sure that we've actually done everything correctly. And with that, we should actually be all good. So what I'm going to do is I'm going to read this, or actually run this one last time to make sure that we have done this correctly. There you go. That's it. So it is officially the document that it needs to be. It's only reading the final portion, which is just the file, the final allow list that's been updated. And the file allow list was fed as an argument to our update file function that compared it against this entire list that was supposed to be removed, which has already been removed. So it's like that part of it is all good. And that's it. We're done. This is it. This was officially the algorithm that is now reusable. And if you followed along from the very beginning of this entire thing, you should really honestly come to the conclusion that this was very, very easy to do. Like, once you understand the foundational pieces of it, and I over-explained in certain pieces, and I wanted to make sure that I said it in multiple ways so that it really registers and you really know what we're just talking about. But if you followed along from the very beginning, everything that you see here is something that we've already used and we've already done inside of the foundational pieces of this training. And now you just combined everything to build a function that will read a file. It'll check against the list of blocked IPs or IP addresses that shouldn't be there, and it will remove it. And all of these pieces can be interchangeable. You can modify this, you can add to it, and you can play with this essentially in as many ways as you want to customize it to do exactly what you want it to do. So I personally loved going through this training. I think this was a great, it like reaffirmed a lot of these ideas for me. A lot of these things have like really been ingrained in my brain right now. And I feel very confident about using Python for just developing a variety of different algorithms to do a lot of different types of jobs that I have to do as a security analyst and a pen tester. So this is something that you can use in your job as a security analyst and a pen tester. So I hope you found use from this. This is essentially the last portion of this training, and we're just going to wrap it up. All right, as a wrap up, this was the Python for Cybersecurity training series. And I don't know how long this video is going to end up being, but I think it's definitely going to be like probably over 4 or 5 hours. I think. I'm really not sure, because I may have talked a lot or I try to be straight to the point, but I think I may have kind of over explained certain things. I just wanted to make sure that you got it, you know what I mean? So we went through the Python version on your computer just to check how you find it. We went through the installation of the most recent Python idle, which is the current shell that comes when you install Python. If you don't use an IDE, then you would have idle to use as your code developer and code writer, and then you can save your Python documents with idle. But we installed an IDE, which is in our case PyCharm. And then we learned how to install libraries and modules, which is very, very useful, and we used a few of those. We went through commenting and readability to make sure that your code looks good and people understand what your code is, and even you understand what you wrote in your code. Then we went through writing our very first program. We went through the data types in Python. We created variables. We started creating conditional statements, which is the if, elif, and else statement that was included. Then we went through the logical operators. Then we started building iterative statements, which are the for and while loops. And then we started building functions. Then we started manipulating lists, and we started manipulating strings. And then we built our very first algorithm, which was a very basic one, but I think it was also very useful. Then we learned about regular expressions and how to import the regular expression module inside of the Python environment so you can use that. And then we learned how to work with and manipulate files. And finally, we built the algorithm, the parsing algorithm that you just saw. So that was it for our entire series. I do hope that you actually found this useful. I hope this is something that you will refer back to and use as a refresher and use kind of like a cheat sheet to develop further scripts, because I'm going to include all the timestamps for all these various pieces, and there will be a lot of timestamps. So you can click around and find anything that you want that would be useful to you in that moment and reuse it and build a bunch of cool scripts. If you found this video tutorial useful, and if you found anything else on our channel useful, I do encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video like this comes out. And if you're interested in cybersecurity, there's a lot of playlists on this channel. There's a lot of great videos on this channel. So feel free to click around or click this search button here and see if there's anything on a topic that you're interested in. And if there isn't anything that's on your topic, please leave a comment in the comment section and make requests. I do adhere to the requests that people make in our community. And this video, this training series, is a direct result of several requests that I got from people who wanted to use Python and cybersecurity. So hopefully this was actually very useful for those people, and hopefully this was useful for you. And if it was, I would very much love it if you give us that like, subscribe to the channel, and share, drop a comment, say hi, say thanks, ask a question if you need something clarified. I definitely respond to all the questions. So it would mean a lot to me if you actually joined our community. And we are very close to hitting our 10,000 subs, because I'm about to reveal my face. Apparently people want to know kind of who I am, maybe. So I'm gonna go from the faceless guy to the guy that you see the face but you still don't know what my name is. And then when we hit that big milestone of 100,000, I'm gonna reveal my name, if people don't already figure out who I am. Once people see my face, if they figure out who I am, they're probably gonna reveal my identity, and if they do, then whatever, we'll just keep making content anyway. But until then, we're gonna reach our 10K very quickly, and from there we'll get to officially finally meet each other. So in case you're interested in getting some really crazy stuff, I do encourage you to check out the Hackaholics Anonymous membership community. It is my goal and intention to make it the premier YouTube community for security professionals and hackers. And there's already a lot of Python automations that I've already built that I give away as perks to our members. We have bug bounties that we go in on. We have member Discord chats that we go back and forth with. There's live streams that I do just for the members that nobody else gets access to. There's downloads for the members that nobody else gets access to. There's a lot of stuff that comes as perks of being Hackaholics Anonymous members. So if you haven't already checked that out, definitely check that out as well. And that's pretty much it for all of these, all of the notices and announcements and everything inside of the video. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. I hope you found value from this video. Love, peace, and chicken grease. If no one else loves you, Hank loves you, and I will see you in the next video. Later.